Hello there! In this tutorial, we will create a Metroid-inspired platformer. It will include fancy movement systems, lots of guns and enemies, along with pretty environments. For all of this, I will also talk about how to manage larger projects, meaning we are going to cover a lot of inheritance and building tools. I am also going to cover how to store data between scenes, so that dead enemies stay dead. In terms of requirements, you should already know the basics of Godot. If you have some knowledge of nodes, scenes, and signals, along with physics bodies and a bit of GD script, you should be good to go. If you followed my ultimate introduction to Godot, you will be super well prepared for this project. But it's also okay if you followed other tutorials. Besides that, we will also cover math topics like vectors and basic trigonometry. If you want to get really good at these topics, check out the sponsor of this video, brilliant.org. Brilliant is a website or an app that you can use to learn math and programming concepts. They offer interactive lessons along with lots of exercises, so you can master a skill in a fun and engaging way. Every exercise was made with an enormous amount of care, and the content comes from industry professionals, so you know it will be relevant to your career. Doing these exercises is also much more engaging and rewarding than passively reading a book or watching a video. And since the exercises are available on a computer or a phone, you can even do them on the bus or at the gym. They also regularly update and add new content. Just recently, they added a section on Python, data visualization, and how LLMs work. If you head over to brilliant.org/clearcode, you can get 20% off a subscription, and the first 30 days are free. By signing up, you also support me making more of these videos. So thanks again to Brilliant for sponsoring this video. Before we begin, there's a setup project that I will be using as a base. If you go to the video description, you can find a link to a Google Drive folder with the starting files. There's one for Godot 4.2 and another for 4.3. Since the latter version is still in development, I will be using Godot 4.2. But if you're watching this in the future, you can very safely use 4.3 or any more recent version. For our purposes, the differences really aren't that relevant, and I'll talk about them in just a bit. Download one of the folders and import it into Godot, and then you should see something like this. Most importantly, we have a level scene, which contains a whole bunch of nodes. I will talk about them in just a second. First of all though, this level scene is the parent for Sky, Station, and Underground. And you can tell quite easily, those are going to become the levels of the game. The way all of them are going to work. For that, let's work inside of level. We have a whole bunch of nodes. Nodes that are supposed to be in the background, nodes that are supposed to be on the main layer, and then nodes that are supposed to be in the foreground. On each of those layers, I have a whole bunch of tile maps. These nodes all work with the same tile set, which has a bunch of collision layers and a tile size of 16 by 16. In there, we have 3 graphics, which are going to be all of the level graphics. And those I have used, for example, inside of Sky to draw the main level. If I hide main, you can see what's disappearing. So for example, on main, I have the actual outline of the level. Whereas for background, I have the background, and then we have some decoration. That's all that's happening in here. I suppose one thing you should keep in mind, if you look at the tile set, there under paint, we have one physics layer. And via this physics layer, we are drawing a bunch of collision shapes. It doesn't apply to that many tiles, but well, you can see the result. I'll talk about this part later. For now, it's not too important. And while watching it, you might have a question. Until now, if you're working with a tile map in Godot, the tile map itself lets you define a couple of layers. So why do I have so many tile map nodes? And well, that is because in Godot 4.3, the system with the tile maps is going to change, where you don't have individual layers inside of one tile map anymore, and instead you are defining one tile map layer inside of the node. And if you want to have multiple layers, you are creating multiple tile map layers. In fact, let's have a look. So here we are in Godot 4.3. At the bottom, you can see that it's 4.3 beta 2. The latest available version. And in there, we still have tile layers. Or in other words, if you look at Station, the game looks basically the same. However, the icon is a bit different. And if I try to add another node, just type tile map, we now have the old tile map. That's the one I have already used. And this is depreciated at this point. Instead, you are supposed to use multiple tile map layers. And that is this tile map layer. It works in pretty much the exact same way. The only difference is that on this tile map, you do not have individual layers anymore. Instead, every single node is supposed to be a separate layer. Besides that, everything else works just as before. So the change is really minor. The only other difference that is relevant to us is that visual shaders look very slightly different. So here's the shader we are going to create later in 4.2, and here's the one for 4.3. So in 4.3, we have a few more colors, but that's literally it. Functionality-wise, nothing has changed. So let's return to the main project. Now, I suppose if you don't know that much about inheritance in Godot, this yellow text might be a bit confusing. So let me do a demonstration. The way I have created all of these levels is by going to Scene and then New Inherited Scene. After which, we have to select one scene that is going to be our parent scene, which in my case is always going to be level.tscn. If I double click on that, we have created a new scene. And then we have some yellow text for all of the nodes. And via that system, you can simply select one layer and then start drawing whatever kind of level you want to create. So in there, you can select anything from the tile set and then start drawing. That's literally all I have done for underground, station, and sky. And if you want to save it, you want to rename the parent node. For example, this one could be the test scene. Then save it, and then you get test.tscn, save it, and you should have under scenes and levels another scene that you can play with. Although not something I want to do at the moment. Next up, if you look at project and project settings, you can see that inside of run, our station scene is the starting scene, which means if I run the entire game, we can see the station level. There we go. Besides that, if you look at textures, I have set the default texture filter to nearest, which is what you are supposed to be using when you have pixel art. Other than that, if you scroll a bit further down, we have the 2D physics layer, and in there I have a bunch of named layers: terrain, player, enemies, transition, and projectiles. Not too important for now, but just keep it in mind. Other than that, if you look at input map, there we have a whole bunch of actions. I am going to cover input for mouse and keyboard and for using a gamepad. Meaning for the actions, for example for shooting, we have a left mouse button and two buttons you could be choosing from a gamepad. Once again, I'll talk about all of this later on. For now, it's not too important. Finally, there's one more scene that is not going to be part of the game, but that is going to make our life much easier: tutorial data. In there, we do have quite a bit of material. Let's have a look at the player animation. We have an animated sprite 2D, a sprite, an animation player, and an animation tree. I will explain all of this in a lot of detail later on. The reason why I have it here is because later on, for example for the animation player, the player has a huge amount of animations that are all fairly simple, but it took a while to create all of this. Having all of this in here makes our life quite a bit easier later on. The same with the soldier animations. In there, we have an animation player with a bunch of animations. Let me play one. You can see this is all we are doing in here. Although for now, this really isn't too important. So for now, I only want to have level and station open, because those are going to be our main scenes that we will work on. And the first thing that we are going to work on will be the player movement. For now, I don't want to worry about graphics, so we are going to be using the Godot logo for all of this. Now, for the movement system, we want to implement a whole bunch of abilities. Number one, the player can move left and right and has acceleration and friction, meaning the movement gradually changes. Number two, the player can jump at various heights, depending on when the player releases the jump button. Next up, we're going to expand the jump mechanic a bit more. After the player walked off a cliff, there should be a small window of time where the player can still jump. which is called the coyote jump. Besides that, when the player is just about to land and presses jump, there should be a jump the moment we land. This system is called jump buffering, and both of these systems make the game feel much snappier. Besides that, the player is also able to dash, which we will implement via a tween. Finally, the player can duck, but that's not important until we get the graphics part. And that is all we need for the basics of the player. Although there's one more thing that I do want to talk about. Inside of the game, we have a whole bunch of entities, and the player is one of them. But besides that, we also have the soldiers, the monster, and the drones. And all of these are somewhat similar, meaning they can share a couple of attributes and shaders. In other words, I want to have a parent class that contains all of these methods, and then the children are going to be the nodes that we actually see in the game. Let's start with that. For all of that, inside of Godot, I want to create a new scene, and the parent scene is going to be a character body 2D, which I want to rename right away to entity. After that, I want to save the scene under scenes and then create a new folder called entities. In there, I want to save the entity scene, and then we have a name in the tab. That's a good sign. Besides that, for the entity, I want to have a collision shape 2D. Although I only want to add the node, I do not want to add an actual shape in there. That's going to come later when we actually create the specific entity. So for example, the player and the drone have different collision shapes. Speaking of which, we can start right away. I want to go to scene and then new inherited scene. The scene I want to create should have a parent of entity.tscn. If I now click on open, we have an entity parent node, or well, a character 2D, and then collision shape 2D is yellow because it's getting inherited from the parent entity scene. This entity I want to rename right away to player. And to make sure we can see something, I want to add another node, which would be a sprite 2D, to which I want to add the Godot logo. So drag it into the texture, and then we can zoom in, and there we go. We have the Godot logo. Once we have that, we can also set a collision shape, and this has to happen inside of the player, which means I want to go to shape and then select a rectangle shape and set it to the right side, something like this looks okay. Now we can save it under player.tscn. Cool. With that, we have the very basic player node. This we want to add to our level. So for example, in the station, I want to have the player somewhere. And to keep all of this organized, I want to, inside of level, add one more node, which should be a node 2D. And I am going to jump around quite quickly between the different nodes. So definitely pause sometimes if you get confused. At the moment, I am working inside of the level node and create node 2D called entities. If I now save the level and go back to station, we have another node with yellow text. To that, I want to add the player node, like so, and then let's move the player, I don't know, let's say here. Although the player is a little bit large. To fix that, back inside of the player scene, I want to go to transform and then set the scale of the player for now to 0.25 for X and Y. On top of that, we need to update the collision shape to align with the graphic, like that. If I now save all of this and go back to station, this looks much more reasonable. So we can move the player somewhere here. Although that being said, I think the collision shape is a little bit too large. It should only cover the graphic, nothing more. That's better. To make sure all of this is looking good, let's run the entire game. And that seems alright. I guess what we could also do to the player is add another node, which would be a camera 2D, which we do want to make sure is enabled, which it is by default. And then for the zoom level, I want to go with 5 for X and Y. Let's try all of this again, and that should be looking a lot better. Cool. So now we are focused on the player. The issue now is that the player doesn't do anything at the moment. And for that, we have to add a script. With the character body 2D player selected, I want to add a script, and then player.gd in the same folder. So create, and now we have a script for the player. In there, I want to define quite a few attributes that should be changeable later on inside of the editor. Or in other words, when the player node is selected, inside of the inspector, I want to be able to set something like the speed, or the acceleration, the friction, the gravity, the cooldown for the guns, and things like that. Or in other words, I want to create export variables, for example, for the speed, which for this particular example should be an integer with a default value of 200, which you could write like this. It simply means that for the speed variable, we are only accepting integers. And the default value is going to be 200. But if you look on the right, we have speed, and we can update the value. Although all of the values have to be integers. Now, this is not usually what you see in Godot because it takes a bit longer to write than doing something like this. But the result would be the same. If you're writing this walrus operator, the data type of the first value that you assign to this variable is going to be the only data type this variable can accept. So in this case, this would be an integer. I can save all of this, and inside of the parameter, we have the same result. Now this we can organize just a bit better, because later on we are exporting quite a few variables. So I want to organize them via export groups. To assign a name, you have to add an argument, which should be a string. In my case, the first one should be move. If you now look at the inspector, we have a drop-down menu that we can open, and in there we have the speed. If you want to have multiple groups, you can add another export group as well. For example, later on, I want to have one for jump. And any export variable you assign afterwards is going to be inside of this group. For example, if I save now, at the moment, we can't see anything because we are not exporting a variable in there. But for example, what we are going to define is a variable for the jump underscore strength, which is going to get a default value of the integer 300. If I now save all of this, on the right, we have a tab for move and a tab for jump. That way, the inspector doesn't get too cluttered, which I think is better, but is entirely optional. If you don't think these groups are useful, you can just skip them entirely. Besides the speed for the movement, I also want to have a few more variables. The first one is the direction of the player, which is going to get a default value of vector 2.0, all in uppercase letters. That way, we are creating a vector 2 with x and y, where both values are 0. And this we are using for the movement very soon. Besides that, I want to have one more variable called can underscore move, which should simply be a Boolean value that by default is going to be true. Also, direction and move should not be exported. They are simply there to process what we are specifying in the game, but they shouldn't themselves be modifiable by the game designer. To actually make the code do something, I want to use the underscore process function, which is going to be run on every single frame of the game. In there, I want to first of all check if we can move in the first place. And if that is the case, I want to get the player input and then apply the movement. Neither of these functions exist at the moment, so Godot is going to complain. To fix that, I want to create func get underscore input without any parameters, and it doesn't do anything at the moment. And I want to create func apply movement. This one also doesn't do anything at the moment. To get started with the input, I want to get the horizontal movement input, for which we're going to overwrite the direction vector, and since we are only moving left and right, this should be direction.x. This value should be set by the left and right movement from the input map. Or in other words, if I go to project and project settings and the input map, we want to get the left and right input and determine from that if the player wants to move left or right. The best way of doing that is with input and then get axis. This will measure the strength of the left and right input. So what we have to add in here as an argument is the negative action first of all, which in our case is the left input. Next up, and let me expand the code a bit, Godot wants to have the positive action, which in our case is going right, so the right input. Godot is then going to combine these two values, and we're getting a combined output in the form of a floating point value. I can demonstrate that right away actually. I want to print direction.x. If I now run the code, the game doesn't crash, that's a good sign, and in the output you can see a 0. So this happens down here. But if I press D on the keyboard, we're getting a 1, and if I press A, we're getting a -1. So with that, we're getting a direction. That's a really good sign. But you might be confused now. I said that we're getting from this method a floating point value returned. But in the output, let me open it, we have gotten 0, -1, or 1. So what happened here? And well, at the moment, I have only used the input from the keyboard, which can only be on or off on basically any keyboard. But this changes if you're using a gamepad. So let me run all of this again, but now I am going to use input from my gamepad. And in there, the further I go to the right, you can see that we get an increasingly large value that ends at 1. And if I go to the left, we're getting smaller and smaller values that end at -1. Meaning with that, I get much more detail in my movement. You do want to be aware of these differences, but in our case, they don't actually matter that much. But keep them in mind, in some cases they can be really important. Anyway, with that, we're getting the direction for left and right. This we want to use to actually move the player, which happens inside of apply movement. In the most basic sense, what we want to do is override the velocity of the player. And at the moment, we want to update velocity.x, which in the simplest terms could simply be direction.x multiplied with the speed of the player, the variable that we have defined earlier. After we have that, we want to call move and slide to actually apply the velocity to the movement. And with that, if I run the game, I can move the player left and right. This works either on the keyboard or with a gamepad, so we are capturing both mouse and keyboard input or gamepad input. Also, if I move very carefully on the gamepad to the right, I can move very slowly, or rather I can define the speed I want to move at. Whereas on the keyboard, I only have move or not move, basically. Now, while this is a good start, this kind of movement usually doesn't feel good. So at the moment, if this is the time of the game and this is the movement speed, our player has a movement graph that looks something like this. We have no movement at all, then all of a sudden we're moving at a certain speed, and then we stop moving. This does not feel natural. What you would rather expect in proper movement is a curve that looks like this, where player accelerates, then has a speed, and then decelerates at some point. This is also what we want to have in the game. Once we know that direction.x is not 0, we want to move from 0 to our maximum speed. And then once direction.x is 0 again, we want to go from our maximum speed to 0. And this should happen over a certain amount of time. For that, I don't want to have this very basic velocity update anymore. Instead, to apply a very simple mechanic for left and right movement, I want to check if direction.x has a value different from 0. If that is the case, we want to accelerate from 0 to our maximum speed. But we still want to update velocity.x. And to get the value, we want to use the move toward function, which wants to have a couple of arguments. We want to have a starting value, a final value, and then a delta value, which is going to define how fast we are accelerating. Our starting point is going to be the current direction.x. Our final value is going to be direction.x multiplied with the speed. Finally, for the delta value, I want to have an acceleration that we have to multiply with delta that we are getting from process, to make sure that all of this is frame rate independent. Now, for that to work, inside of apply movement, we have to pass through the delta argument. And this has to become a parameter inside of apply movement. The only other error we are getting now is that acceleration doesn't exist, but that we can fix quite easily. I want to create another export variable called acceleration, which is going to be an integer that by default is going to be 500. If we now run all of this inside of the game, I can press to the right and the player is moving, and if I release the button, the player doesn't stop moving. That is because inside of direction, we are only doing something if the player is not moving. So once the player is moving, we cannot change the movement anymore. Although inside of the game, the player movement was really slow. That is because inside of move toward, I have made a mistake. This should be not direction.x, but velocity.x. That way, if I now run all of this again, if I press to the right, the player starts to move much faster, but there's still acceleration. Or in other words, if I set the acceleration to a really low value, let's say 100, you should be able to tell this much better. If I now press to the right, we are starting slow and at some point reach our maximum speed. That's a good sign. Although I want this value to be 500. And also, inside of apply movement, if the player stops holding down left or right, the player should feel some friction and slowly move back to a movement speed of 0. Or to be a bit more specific, velocity.x very slowly should become 0 again. Implementing that is going to be your exercise. I want you guys, if there's no more input, to gradually change the player speed to 0. Pause the video now and figure this one out on your own. Inside of apply movement, I want to add an else statement. This is only going to trigger if direction.x is 0. And if that is the case, I want to update the velocity.x once again via the move toward method. For the starting point, I still want to use velocity.x, but now the target value should be 0. And for the delta value, I want to get some kind of friction that we will define in just a second and multiply it with delta. Now at this point, Godot is going to complain that friction does not exist. That we can fix quite easily. I want to have another export variable called friction, for which I have set a default value of 600. I can now run the game again, and if I move to the left, we are accelerating, and if I stop holding it, we are getting some friction and slowly stop. And this is feeling much better. Although I think the game is quite soft in terms of acceleration and deceleration. The default value for friction could probably be 900, and for acceleration, we could go with 700. Let's try this again. And now we are starting faster, and we are stopping also much faster. Now, these values are really subjective, so play around with them for your own game and just see what feels good. There just isn't a universal answer. Or well, in other words, whatever feels good to you in the game is the right answer. And the only way to get there is to experiment a lot. So play around. In my case though, I want to go to the next part, and that is jumping, for which we will need two parts: a jump strength and gravity. Now, in this game, I want to have the gravity as an export variable inside of the player, meaning in there, I want to have gravity with a default value of 600. I am only doing this because the player is the only entity inside of the game that has any kind of gravity. If in your game you want to apply gravity to more entities, you want to have this gravity either in some kind of global script or inside of the physics part in Godot. So it's more globally available. But I want to keep things simple. Now for jumping to work, we first of all need gravity, which I want to keep in a separate function. So apply underscore gravity, and then create func apply underscore gravity. In the most basic sense, all that we want to do in here is velocity now dot y plus equal gravity multiplied with delta. So it's frame rate independent. For that, we will need the parameter delta, and then pass delta into apply gravity. Once we have that, I can run the game, and at the moment you can't see anything, because inside of the station, the player sits on a collision shape. But if I move the player to, let's say, here-ish, and try all of this again, the player should be falling. And he does. Perfect. Also, apply gravity should always be applied. It doesn't matter if the player can or cannot move. So, next up, we want to apply jumping. For that, inside of get input, I want to capture the jump input, for which we want to have an if statement, if input and is action just pressed. The just pressed is really important because we only want to capture this input once. The specific input that we want to capture is jump, and if that is the case, I want to set a jump variable to true. Now this jump doesn't exist right now, so Godot is going to complain. To fix that, under my jump section, I want to create a variable called jump, which is simply going to be a Boolean value that by default is false. Once we have that, inside of apply movement, I want to move and slide a bit further down, and then add a section for jumping. If jump is the case, then I want to update velocity.y and set it to the negative jump strength. That way, the player is going to go up. If I try all of this, I can press space and the player is moving up. The issue is the player never stops moving up. And that is because this jump keeps on being true forever, which means we keep on lowering velocity.y, which is not ideal. To fix that, I want to set jump to false once we have done a jump. If I now try all of this again, I can jump, and the player only does a jump. And I can also move left and right, and that is coming together. This is a good start, but this jump system we have to modify quite a bit. And I guess the part where we can start is terminal velocity. To illustrate that, if I go back to the level and then remove these platforms. So I want to get rid of those two. And then you can see the player falling for a bit longer. And I guess for that, we can also move the player up just a bit. If I now run the game, the player is going to fall, and it's going to fall increasingly fast. This, at the moment, isn't particularly visible because we still have other things there that the player can land on, and the entire distance isn't even that much. But the issue is still important, that the longer we fall, the faster we fall. And at some point, we are falling so fast that there's simply no point in controlling the player anymore, which we really want to avoid. And avoiding all of that is actually quite easy. We want to set on that jump, I guess right below the other export variables, another export variable that I called terminal_velocity, for which I have set a default value of the integer 500. And then, when we are applying the gravity, just to demonstrate what we are getting, I want to print velocity.y. If I now run all of this, you can see that we are getting a whole bunch of values while we are falling, and we are landing at this point. So I want to make sure that we never fall faster than 500. For that, all we have to do is get velocity.y once again, and then use the minimum function, which is going to pick the smaller of two values. In there, I want to have velocity.y itself, and then the terminal velocity. That way, once again, I can print velocity.y, run the entire game, and now you can see that we are falling, but we never exceed 500. This is our maximum fall speed. Cool, that is working well. So we don't need the print statement anymore. Next up, I want to work on a variable jump speed. If this is the player and we are pressing jump, the player should be jumping. But then we only get to the maximum height if the player keeps on pressing jump. But if the player releases the jump button, let's say somewhere here, then the player should start falling from this point. and this needs to happen gradually. The way I implemented that is that once we are jumping and the player releases the jump button really fast, then we are increasing the gravity for a short amount of time. Or well, until we are landing. For that, I want to create one more variable, which I've called faster_fall. By default, this one is also going to be false. After that, when we are capturing the input, I want to check below the jump if input is action just released for the jump action. If that is the case, then I want to set faster_fall to true. That value we can use inside of gravity, because in there we can add velocity.y once again and set this value to velocity.y divided by 2 if faster_fall is the case and we are moving down. So, and velocity.y is smaller than 0. If that is not the case, else we simply keep velocity.y. With that, let me move the player back to the ground area, run all of this. If I now jump, we can only jump a very small amount. So something went wrong, and I think to diagnose what's happening here, let's print faster_fall. If I now run the game, you can see that we are getting faster_fall all the time, even though it should only be the case if we are in the air and we are releasing the jump button. We only want to set faster_fall to true if the player is releasing the jump button and not is on floor. Or in other words, if the player is releasing the jump button, if we're not on the floor, and velocity.y is smaller than 0. So we are going up. With that, if I run this again, you can see in the output that now faster_fall is false, which means if I jump, we're getting the full jump height. But if I start jumping and then release it, we are setting faster_fall to true. So now we can only jump a little bit. To fix this last bit, when we start a jump, I want to set jump to false and faster_fall false as well. Let's try this one again. And now I can jump the full height. I can jump a bit and then release the button. And now every time I jump again, faster_fall is false when we start a jump. So that way, if I press jump very quickly, we're only jumping a small bit. But if I hold down the button, we're jumping much further. And then you can control the jumping height quite a bit. And while we are here, there's one more thing that I do want to work on. If I run the game again, the issue is that the player at the moment can jump in the air, so we basically fly, which obviously is not ideal for a platformer. I only want to allow jump if the player is pressing the jump button, and in there I want to check if is on floor, and only then do we allow a jump. That way I can run all of this again, and I can press jump. If we are in the air, we cannot jump. This only works on the floor. So that is much better. We are still not done with the jumping though, because there are 2 more things that I want to implement that I talked about earlier. We want to have a coyote jump and a jump buffer. For a coyote jump, if the player falls off a cliff and then presses jump right away, let's say after 0.1 second, then the player still gets to jump, even though technically he shouldn't be allowed to. While this system doesn't make any sense in terms of physics, in practice it makes the game feel much better, and that's all we really care about. For a jump buffer, if the player is falling and presses jump just before landing, then we want to jump right away. With that, we avoid an awkward pause when the player is landing. For both of those systems, we are going to need a timer. Or, well, we're going to need 2 timers. And to keep everything organized, I want to add inside of entity another section called a node and timers. Although inside of the entity itself, we are not going to add any timer. We are just going to save the scene. Now inside of the player, we're getting a node called timers. And to that, I want to add two timer nodes. The first one I've called Coyote. Then we can duplicate this. The next one is called the jump buffer. Both of these need to be one shot. They should not be repeated. Also, auto start is not going to be the case. For the wait time, for the jump buffer, I want to have a value of 0.25 or a quarter second. For the Coyote jump, I want to have a value of 0.15. Once again, these are values you can play around with on your own. There's no universal answer here. Once I have those two timers, back inside of the code. To get started with the Coyote jump, I basically want to start the Coyote jump timer if the player is falling off a cliff. Which means, first of all, we have to figure out when the player is falling off a cliff. For that, we want to work inside of apply movement. And we don't have to print faster fall anymore. Basically what we want to check. After we have done all of the movement, we want to know if the player is currently on the floor, and if we are then updating all of the movement, is the player still on the floor afterwards? And also, is the player falling down? Then we pretty reliably know if the player is falling off a cliff. To figure this one out, I want to create a new variable, var on underscore floor, which is simply going to be is on floor. So that way we know before we are applying the movement if the player is on the floor or not. And then after we have done the movement, we want to check if on floor and not is on floor. That way we know if the player was on the floor and is not on the floor anymore. On top of that, I want to check and velocity.y is greater or equal to 0. If that is the case, we want to, for now, print fall off cliff. Let's try this one. Inside of the game, I can move to the right, and we are falling off a cliff. Let's try again. We are falling again, and once again, this is working pretty good. Cool. So once this is the case, I want to start the Coyote timer. And then you can simply type Coyote, and we get timers and Coyote. I want to start this timer. And while the timer is running, I want to give the player the ability to still jump. Now, for that, you could work with the signals and check if the Coyote timer hasn't sent a timeout signal, and during this time, allow for a jump. That would be possible, but kind of overkill. What I think would be much better, let me minimize apply movement and apply gravity and func underscore process. Inside of the input, we know when the player is pressing jump, and at the moment, we are allowing a jump if the player is on the floor. This we can expand. We want to allow a jump if the player is on the floor, or if the Coyote timer has some time left. So essentially, once the player is falling off a cliff, we are starting the timer. And this timer runs for 0.15 seconds. And during this time, the player is still able to jump. Let's try this one, although it's going to be a bit difficult to demonstrate. So I'm going to fall off a cliff, and I can still jump. Let's try again. There you can see it works fairly well. The duration might be a bit too long, so let me fall a bit longer, and I cannot jump anymore. This you might want to test in your own game, because it's probably very hard to see on YouTube. But it definitely works, and I guess to demonstrate that this is working, we can set the Coyote duration to 1 second, which would be a crazy long time. So now I can fall off and still jump, even after falling for a while. Which does look very strange indeed. Let's not do that. 0.15 seconds, I think it's a decent value. With that covered, we can work on the jump buffer. This part is going to be another exercise for you. If the player is falling and presses jump just before landing, make the player jump right away. Or to be a bit more visual, if the player currently is falling and we are just about to reach the floor, and the player presses jump with a bit of space before the landing, then the player should jump right away as soon as we are landing. For that, we already have a timer node. use that to implement this jump buffer mechanic. So pause the video now and see how far you get. We have to expand the input for the jump just a bit. If the player has pressed jump, at the moment we are only checking if we are on the floor or if we have the Coyote timer running. Besides that, I also want to check if velocity.y is greater than 0, i.e. we are falling, and not is on floor. Or in other words, we are falling and we are not on the floor. If that is the case, I want to get the jump buffer and start the timer. After that, inside of apply movement, at the moment we are only checking if the player is jumping, or well, if the jump variable is true. But we also want to check or jump buffer has time left. This we have to combine with and is on floor. We are going to jump if the player is pressing the jump button or if the jump buffer is active and we are on the floor, which can only be the case if we have recently landed. So with that, I can try the game again, and now I can jump right away if I press jump just before landing. And just to demonstrate, if I comment out this part and run all of this again, and I try to jump multiple times, there's always a very small pause between the jumps, which just doesn't feel good. So this jump buffer can make quite a bit of a difference. But that's basically all we need to implement a jump buffer, so I hope this part wasn't too difficult. The last major part for the movement is going to be a dash mechanic, for which I want to go all the way to the top, and then under move, I want to have another variable called dash, which is going to be a Boolean value that is false by default. Besides this variable, I want to export another variable, and for this, I want to have export range with a value from 0.1 to 2, which is going to define the variable dash underscore cool down. By default, I went with 0.5. This variable is going to define when the player can dash again after having just dashed. And if you have export range, you can go to player, and under move, you now have a slider that sets a floating point value, which is quite nice to work with. So with that, we first of all want to figure out when the player is pressing the dash button. And let me clean all of this up just a bit. There we go. Inside of get input, I want to check for dash. Or well, dash input to be a bit more precise, but you get the idea. In there, I want to check if input is action just pressed, and we have a dash action. Although we do need a second condition and velocity.x. You could add is different from 0, but it's not really necessary. The basic idea here is that the player should only be allowed to dash if we're moving in one direction. We cannot really dash in place, that would be weird. If this if statement triggers, we want to set dash to true. With that in place, we can work inside of apply movement and then work on the dash. First of all, like for the jump, I want to check if dash is the case, and then set dash to false right away. Now we have to implement the actual dash mechanic, and for that, I am going to use a tween. I want to have a dash underscore tween, which we are creating via create tween. Now, in case you don't know what a tween is, it's basically a move toward function that is much more powerful. Or in other words, we can specify any attribute of the player and then gradually change the value of this attribute over time. This we can do in a couple of different ways. Tweens are quite flexible. For example, what we could be doing is we can use the dash tween and then tween a property. First of all, for that, we will need an object, which in our case is the node itself, so self. Then we need the actual property, which needs to be a string. In our case, the velocity. Although in our case, we only care about the x part of the velocity. which we can get via a colon and then x. Next up, we will need the final value, which in our case is going to be velocity.x plus direction.x multiplied with some kind of static value that is going to be our dash distance. For now, let's go with 600. Finally, we will need a duration, which I have set to 0.3 seconds. And I suppose this part could be slightly confusing. Basically, imagine that this is our player, and our player is currently moving to the right. From that information, we want to make the player dash in this direction. Or in other words, we want to get the current velocity and then update it by adding the current direction multiplied with some kind of speed. Let's try all of that and see what happens. If I now run the game and press dash, the player is dashing. So that is working, although it's quite strong. That is because after applying this tween, our velocity is really strong. So ideally, after this tween is finished, we want to set the velocity of the player to something more reasonable. Or in other words, we are stopping the player. For that, we can get the dash tween again and then connect it to a signal. The signal that we want to target is called finished. So we know when the tween is finished. And then we want to call a function, which I have called on dash underscore finish. This function doesn't exist at the moment, so let's do it all the way at the bottom. I want to have func on dash finish. If that one is the case, I want to get the velocity.x of the player and move toward from the current value, so velocity.x to 0 by a certain value. I simply added 500 in here to keep it simple. If I now run all of this again, I can move to the left and dash, and now we are stopping, which is much better. And that is actually controllable. I can also jump and dash. This is mostly working. The one thing I don't like about it is that if we are dashing, gravity is still applied to us, so we are always falling down. To fix that part, under jump, I want to add another variable, the gravity underscore multiplier. The value for this one, and this always has to be an integer, is going to be 1. And essentially, once we start dashing, I want to set the gravity multiplier to 0. And when we are applying the gravity, before we are setting the minimum value, I want to update velocity.y one more time. All I want to do in here is get velocity.y and multiply it with the gravity multiplier. Also, after we have finished dashing, we need to set this gravity multiplier back to 1 so that the gravity applies to us once more. Let's try all of that. If I now jump and dash, we stay in the air. So that is working really well. Perfect. That is looking really good. We are nearly done. There's just one more issue. If I run the game again, and let's say I jump and then press dash really fast, the player can basically sprint through the entire level, which obviously isn't good. For that, we have already started setting a dash cooldown, but we're not using it at the moment. To fix that, I want to add inside of the timers another node. I guess I can copy the jump buffer and change the name to dash cooldown. For the wait time, we can simply go with 1 second. We're going to override this using the dash cooldown variable anyway. But one shot has to be activated. Back in the code, once the scene is ready, or in other words, func underscore ready is running, then I want to get the dash cooldown node and set the wait time to whatever we have specified inside of dash cooldown. This part isn't strictly necessary. You could simply define a value or a wait time inside of dash cooldown and you would be good to go. But I find this setup a bit more elegant because that way, inside of the player, under move, we have a dash cooldown and that just feels more elegant. I suppose this part is a bit more subjective. In fact, when I have created the coyote timer and the jump buffer, I haven't used that system, so I'm not entirely consistent myself. I suppose in your case, if you create a real game, be consistent. Either always work with the wait time inside of the timer, or have some kind of export range variable. Either way is fine, just be consistent. If you mix the two ways up, it's going to get really confusing really fast. Now, to use all of that, we want to work inside of get input. In there, at the moment, we are checking for the dash input if the player is pressing the button and if we have movement. On top of that, I want to check and not dash cooldown timer has time left. And then, as soon as we are pressing the dash button, I want to start the timer. So dash cooldown dot start. And with that, I can run the entire game once again. I can now dash, and there's always a delay between the dashes. Cool, that's looking really good. That means we are nearly done with the player movement. There's just one more thing that we have to work on, and that is the player ducking. For that, under movement, I want to have another variable called duck. Actually, I call this one ducking, but doesn't really matter. This is going to be a Boolean value that by default will be false. After that, inside of get input, I want to have another section for ducking. In there, we are overwriting the ducking variable, and the value here is simply going to be input is action pressed. And important for this one, we do want to get action pressed, not action just pressed, because this one should be checked continuously. The input we want to check is called duck. Also, this should only be possible if the player is on some kind of floor. Since those two values combined are going to return a Boolean value, we are good to go now. I suppose we could print the results, print ducking, and then inside of the game, I can press the duck button and we're getting true or false. Although other than that, it doesn't do anything at the moment. To make it actually do something, we want to minimize get input and then work inside of apply movement. If the player is ducking, we shouldn't allow left or right movement, which means after we are getting the velocity from that part, I want to check if ducking and then update velocity.x from that. If the player is ducking, we're going to set velocity.x to 0. That way, if I run all of this again, I can move left or right, but if I press the duck button, we do not get any horizontal movement anymore. We can still jump, and then we can move. So this part is working. This is a bit hard to see if you're just watching the video, so definitely try this one on your own. It's a bit strange if you don't see the proper graphics, something we are going to work on next. But anyway, with that, we have quite a bit of logic for the player movement. So we have written nearly 100 lines of code, and I hope the entire system so far wasn't too complicated. I suppose the one additional thing you could be adding is a wall jump. For that, you would want to check if the player is on a wall and then lower the gravity. That would be a good starting point. You would need a bit more, but I think at this point you can figure this part out on your own. In my case, I am going to continue with the player graphics. That part is much more important. The next major bit are the player graphics, for which we have a ton of animations that need to be managed. In fact, the player consists of two parts, the legs and the torso. The legs are controlled by the movement direction, while the torso gets updated by the aim direction, which we don't have yet. Also for this section, we will use an animation tree, which I think lots of people struggle with. I'll be extra detailed for that part. First of all though, back inside of Godot and the player scene, I want to add the crosshair, for which, first of all, I want to add a sprite 2D to the player scene. This we can rename to crosshair. And then if you look at the graphics bit, we have guns and crosshair.png. This I want to drag in there, and then we have the crosshair. At the moment, this thing is a bit too large, so let's go to transform, and 0.1 might be a bit too small. Let's go with 0.25. We can readjust all of this when we have the proper player graphics. What is much more important for now is that we are controlling the position of this crosshair. The way you want to think about that is if the player is aiming to the right, that I want this crosshair to be roughly here. So we are indicating visually to the player that we can shoot to the right. And this we want to do for all of the directions. The player can shoot to the top right, up, up left, and so on. We get in total 8 directions. Also really important for this part, we should get to this aim direction via the mouse or via the gamepad. Speaking of which, if you look at the project settings in the input map, if you scroll down, we have aim left, aim down, aim up, and aim right. And those only have the joypad axes. For all of that, we are using the right joystick. And those are only necessary for the gamepad. If we have a mouse and keyboard, for the aim direction, we will use the mouse, for which we don't need an input map, so it's not in here. For all of that, I want to work inside of get input. We already have a few things in there. Next up, I want to add aim. I want to create 2 variables. The first one is the aim input gamepad. Besides that, I want to have an aim input underscore mouse. And let's for now focus on the gamepad. For that, basically all I want to do is to get the input from the right joystick. And that I can get via input.getVector. GetVector works very similar compared to what we have seen with getAxis. The only difference is that getAxis works on 1 axis, while getVector works on 2. So there we can get left, right, up, and down. We have to start with the left action or the negative action, which in our case is aim left. And let me expand all of this. Next up, we want to have positive x, which in our case is going to be aim right. The next argument is the negative y, which in our case is aim up. And finally, we will need the positive y, which is aim down. And that is all we need. If I now print aim input gamepad and run the game, I am only using my gamepad now and I can move things around. For example, if I move the gamepad joystick to the right, we're getting roughly 1 and 0. If I go down, we're getting roughly 0 and 1. Let me get it a bit better. There we go. And so on. So this input works pretty well. Perfect. That means next up, we want to get the mouse input. What we want to do for this one, let me comment this part out and go back to the player scene. So if I show my mouse, there we go. I basically want to get the direction between the mouse and the center of the player. Or in other words, if the mouse, for example, is here and the center of the player is here, I want to get this vector. But for this part, you do need to be careful, because when we are inside of the station, we have the player anywhere inside of the level, so the center of the player can be a very relative number. Especially if you add a camera, this can get a bit confusing. Although, fortunately, we don't really have to worry about it too much, because inside of Godot, there is a function called getLocalMousePosition, which is giving us, well, the local mouse position. So we don't have to worry about the actual center of the player, we only care about the mouse position inside of the player scene, basically. Let me print a result. So aim, input, mouse. I can now run the game and it should be visible. There we go. So we can see if a mouse is to the right of the player, we are getting 8 and roughly 0. If I go to the left of the center of the player, we get -8 and a very small number for y. Now this we can improve just a bit, because this vector that we are getting should be normalized. That way, I can run all of this again, and now we can see the numbers a bit better. If a mouse is to the right of the center of the player, we are getting for the vector x being 1 and y being roughly 0. Next up, we have to figure out which of these variables to use. And for that, I have created another variable at the top. Under move, I have controller underscore active, which is going to be a Boolean value that by default is true. I do assume that by default the player wants to use a gamepad because that just feels better. However, as soon as we're getting mouse input, I want to disable this value. But first of all, I want to create another variable, var aim underscore input. This one is going to be aim input gamepad if controller active. And I realize this should be called gamepad just to be a bit more consistent. So gamepad active. Let's do it at the top here as well. Gamepad active. If that is not the case, else I want to use the aim input mouse. We do have to refine this just a bit more, but for now this is fine. First of all, I want to work with gamepad active. And for that, I basically want to check if we have any kind of mouse input. And if that is the case, gamepad active should be false. Now to track mouse movement, we will need another inbuilt function in Godot called function underscore input. Because in there, we can get the input event, which can track the mouse very easily. All we have to do is if event is input mouse motion. This is going to trigger as soon as we have any kind of mouse movement. For example, I could print mouse is moving if this if statement triggers, which is going to be whenever the mouse is moving. So inside of the game, if I move the mouse, we get mouse is moving. If that is the case, I want to get gamepad active and set it to false. Also in there, I want to check the same thing we have done inside of this line, where we are checking the aim input. If we get a value from this thing returned, then I want to set gamepad active back to true. So with that logic, as soon as the player is using the mouse, we are switching to the mouse input. And if the player starts aiming with the gamepad, then we are using the gamepad again. Now you might be wondering, why do we only activate the gamepad if the player is aiming in a different direction with the gamepad? Why not activate the gamepad if we are pressing shoot or if we are moving the player? And well, we don't need to. If you look at the project input map, for the left movement, we are already capturing the keyboard or the gamepad at the same time. So for this part, it doesn't really matter what kind of input we have. The only part where we have to separate the mouse and the gamepad is when we are aiming. But once we have that, we can work on the next part. And the issue we now have to fix is if this is the player, we want to have a crosshair to the right, to the bottom right, and to the bottom, at least for this section. What we do not want is a crosshair in between. So in this area and in this area, it shouldn't be possible for the player to have the crosshair. We only want to allow certain positions, which basically means that we want to round this aim input. Or to be a bit more specific, I want to check if aim input has any value, which we can check via the length if this value is greater than 0.5. Then we know we're getting some kind of reasonable movement. And remember, we can get a value that is very low because on a gamepad, you can move the joystick just a bit. So we want to have at least some activation strength required here. And if that is the case, I want to set an aim underscore direction, which doesn't exist yet, but at the top, I want to create another section. So let me copy the export group, and I want to have a section for the gun. For now, in there, I want to have an aim underscore direction, which is going to be a vector 2 that by default points to the right. Also, I guess while we are here, we can create an export variable that I have called crosshair underscore distance, which gets a default value of 20. With that, back inside of the aiming section, I want to make sure that the aim direction gets only specific kind of values. Although that sounds almost too complicated. Basically, all that we want to do is create another vector 2 with x and y. And this value we're getting from the aim input, which is either going to be for the gamepad or for the mouse. So in there, I want to get the aim input.x and the aim input.y. Let me print the result so you can tell what's going on. Aim input, and let's run all of this. If I show my mouse, you can see that we are getting the same result we had earlier. So if I am to the right of the player, we're getting roughly 1 and 0. So we know we are pointing to the right. And if I use the gamepad, I can press up, and we are getting similar values. So right now, I am holding my joystick to the left, and we're getting -1 and roughly 0. So this is working reasonably well. But we are still covering a whole range. Whereas I only want the player to be able to point to the right or up, basically. And that we can achieve by rounding both of them. So aim input.x, aim input.y, and both should be rounded. That way, let me print the aim direction. I can run all of this again. And if my mouse is to the right, we're getting 1 and 0. If I go up, we're getting 1 and -1. And if I'm just above the player, we're getting 0 and -1. So this part is working pretty good. I can also use the gamepad. And if I hold up, we're getting 0 and -1. If I hold right, we're getting 1 and 0, and so on. So that covers the input. With that, we simply have to get the aim direction into the crosshair sprite, the one we have created earlier, and then we can update the position. In fact, for all of this, I want to create another script inside of the crosshair to keep things a bit more organized. So I want to create a new script and create a crosshair. Then we don't need any of this, and we can start writing our own logic. Although, first of all, I think if you look at scenes and entities, this could be a bit better organized, because for the player, we are going to create a few more scenes. So I think what's going to be a good idea is to create a new folder inside of entities called player. And then put all of the player stuff, so the crosshair, player GD, and player scene inside of that folder. It's not necessary, but we are going to create a few more entities, and this just feels cleaner. All right, next up. We don't need get input anymore. And instead, I want to create another function. Let's do it right at the top. Function animate. This function is going to cover all of the animations for the player. And for now, I want to get the crosshair, so the sprite 2D that we have created just a second ago, this crosshair. And on that, we want to call a method. I call this one update, for which we're going to need 3 arguments. The aim direction, we want to know the crosshair distance, and we want to know if the player is ducking or not. Because if that is the case, we want to lower the crosshair by just a few pixels. Once we have that, inside of crosshair.gd, we want to create function update with a direction, a distance, and ducking. All we really want to do in there is to update the position of the crosshair. And since this crosshair is a child of the player, we know that player is always in the position 0 and 0. Which means for our purposes, all we have to do is get the direction and multiply it with the distance. And then we should already get something. The last thing that we have to do is call this animate function. That happens inside of process. If the player can move, I also want to call animate. Let's try all of that. And now we're getting the crosshair following the mouse. So very happy with that. And if I use the gamepad, I can point up left, to the left, and I get all of the directions. So this part is working pretty well. If you feel like the crosshair is too close, you can simply go to the player under gun. We have crosshair distance. If I set this to, let's say, 50 and try the entire thing again, then the crosshair is much further away. That is definitely too much. So play around and see what value you like. I'm going to stick with 20. Nearly done. There's just one more thing we need, and that is we have to cover ducking. For that, I want to create an offset. So var duck underscore offset. is going to be, for now, let's say 6, if ducking, and if that is not the case, else it should be 0. And this value I want to add to the position, which means we have to add a vector 2 with x being 0 and y being the duck offset. With that, if I run the game again and the crosshair is pointing to the right, I can duck and the crosshair is going down just a bit. Once we have the proper graphics, this is going to look much more reasonable. Although this isn't perfect yet, because this 6 isn't ideal. Ideally what I want. Inside of the player under gun is a variable crosshair y offset, which is going to get a value of 6. And this value we want to use for the crosshair and later on for a couple of other things. And also this value doesn't change, so it can be a constant. So now we have to figure out how to get this crosshair y offset into the actual crosshair. We could pass it in as an argument, and I guess that would work, but it doesn't feel right. Instead, what I have done, once this scene is ready, so on ready, I want to create a y offset. And for that, we want to get the parent of the scene. And since that is the player, in there we have the crosshair y offset, which is what we can use instead of this 6 to make all of this a bit more flexible. The end result though should still look the same. So I can duck and we get the same movement. This also works in other directions. That is pretty nice. But now we are storing the offset for ducking in one central place. So if we are changing the graphics later on, we have to update one number and then everything updates along with it, which is much more reliable. Cool. With that, we have the crosshair. And that covers the entirety of the crosshair actually. So I can close this script to keep things a bit more streamlined. Next up, I want to create the actual player graphics. And that part is going to get a bit more complex. So to keep things a bit more organized, I want to create a separate scene purely for the player graphics. Which means a new scene, the parent scene is going to be a node 2D. Let's call it player graphics. This I want to save under scenes, entities, and player. And then we are going to need a whole bunch of animations. And for that, I want to copy in a couple of things. So let me open the scene tutorial data. In there, we have the player animation. We have a legs animated sprite with duck, idle, jump, and run. Very simple animations. Besides that, we have the torso. And let me hide the soldier. That part comes later. Inside of the torso, we have a sprite sheet with all of the player images. In fact, let me open that part. Under entities, we have player.png. If I drag this thing in, you can see that on there, we have all of the various positions for the torso with the different guns. The first line is for the AK, the second line for the shotgun, and the final one for the rocket. And if we go down a bit, we have all of the lag positions. There's quite a bit of white space because I messed up the planning, but that's really not that much of an issue. To animate the torso, we are using an animation player. And in there, we have all of the animations I talked about earlier. So for example, in there, we have AK down, which is basically one image of the player pointing down, with the AK selected. If I go to rocket down or RO down left, we're getting the rocket launcher pointing to the bottom left. So that's really all that's happening in here. Basically, via the animation player, I am selecting one frame from the torso sprite. That part isn't hard to do, it's just tedious, so it's kind of annoying to do it for a tutorial. To skip all of that, I want to copy the legs, the torso, and the animation player, and copy them, and then drag them into the player graphics. You should still get something like this, where you can animate the player torso via the animation player. So let me select the shotgun left, and we're getting the shotgun left. Also, for the legs for the animated sprite, you can get idle. And if you click on run and play the animation, you should be getting an animation. So that part is also working. Although I do want to set idle to autoplay. And I think before we continue, definitely have a look around the animation player and the animated sprite, so you know the setup of what we are working with. Once again, none of this is particularly difficult. It's just a lot of stuff, so I hope it's not overwhelming. Now for all of this, let me select the default AK right. So we have the default look of the player. This I want to add to the actual player scene. In there, I want to add another scene, player graphics. And this should be a bit more in the center, something like this. And then we don't need the sprite 2D anymore. We can just get rid of it entirely. Also for the collision shape, we want to update the shape to something that fits the player a bit better. In fact, I don't want to have a rectangle at all anymore. I want to have a capsule shape 2D, which usually feels a lot better. And then we have to get the points just right, something like this. And make sure that the bottom of the player aligns with the collision shape. So right now, we have half a pixel of an offset. To fix that, for the player graphics under transform, we want to move up by negative 7.5 pixels. And then align the collision shape along with it. And that looks good. Now we can get rid of the ruler. And we have a proper collision shape. Let's try the game. And this is feeling much better. All the collisions also work just fine. And we can still dash. That's a good start. Perfect. That means we can close the tutorial data scene and then work inside of player graphics. For this one, we want to add a script to player graphics, which should also be inside of entities, player, and then we can call it player graphics. That part is totally fine. There are two things that we want to do in here. Number one is we want to update the legs, which we are going to do via a function. And for this function, we will need three arguments. The direction, if the player is on the floor, and if the player is ducking. Although for now, we don't want to do anything in here. Because first of all, I want to create another function called update torso. For this one, we will also need a direction. Although for this direction, we are talking about the aim direction, while the direction for the legs was the moving direction. But since those two are separate functions, we can keep direction. For the torso, we also want to know if the player is ducking. And finally, we want to get the current gun. Because for the torso, we have three different gun animations. And that we have to account for. That comes later though. For now, simply pass in here is fine. So with that, I don't need tutorial data, and inside of the player, we already have an animate function. I want to get the player graphics and then call update underscore legs, for which we need three arguments. The first one is the moving direction of the player, or the direction vector we have set earlier. The next argument is if the player is on the floor or not. For that, we can use the inbuilt function isOnFloor. Finally, we want to know if the player is ducking or not. That is simply the ducking variable. Cool. With that, we are calling this function with all of the proper arguments. That we can already use right away, because I want to flip the graphics if the player is moving to the left. Let's add a comment for the lip. And basically all I want to do, if direction.x exists. If that is the case, I want to check if the player is facing to the left or to the right, and use that to flip the legs. By default, they are pointing to the right. But if the player is moving left, then obviously we want to flip all of this on the horizontal axis. But really important, once the player stops moving, we still want the legs to point to the left. So we are only going to update the animation if the player is moving. That way, if the player moves to the left, stops moving, we keep the left animation, even though the player isn't actually animating. All we need for this part is the legs and then the parameter flip h. This wants to have a Boolean value, which we can get via direction.x being smaller than 0. That way, I can run all of this. If we're moving to the right, the legs are facing in the right direction, and if I'm moving left, they're being flipped. And this works even if we're not moving, so quite happy. But obviously, this still doesn't look amazing because we need an actual animation. Or to be a bit more specific, we want to set the animation state because we, for the legs, are working with an animated sprite, for which we have 4 different animations: duck, idle, jump, and run. All we have to do in the code is to set the right animation. For example, what we could be doing inside of legs, we can set the animation to run. If I now run all of this, the player is running. And this still works with the flipping, so we are always pointing in the right direction. But we do have to select the right animation. Or to be a bit more specific, we want to set the right animation state. For which I want to create a variable, state, which by default is going to be idle, but only if we are not ducking. If we are ducking, then the state should be duck. There should be an else in there as well. And this state we are then using for the actual animation. Let's try all of that. If I now duck, we are getting the proper duck and idle animation. And this works pretty well. So we can move around, we can stop moving, we are facing always the right direction, and we're getting the right frame. The torso not being animated makes all of this look a bit weird, but that we're going to fix in just a bit. First of all though, I want to get the run and the jump animation. First of all, for running, I want to check if we are on the floor and we are moving. In other words, we have direction.x. Also, I want to check and not ducking. If all of that is the case, I want to get the state and set it to run. With that, we can idle, we can duck, and we can run. So that is working really well. The last thing that we have to work on is the jumping, because right now this looks a bit weird. Fortunately, that is just another if statement. If we are not on the floor, then the state should be jump. Let's try this one, and if I jump, we're getting the jumping frame. So with that, we have the legs covered. That is working really well. Let's fall off a cliff, and that's also working really good. Very nice. That is actually all we need for the lag animation. So we can minimize the function and never think about it again. Next up, for the torso, there's one very easy thing that we can already do. That is update the position if the player is ducking. All we need for that is to get the torso and then update the position. In fact, we only care about position.y because the x position should never change. And for this y position, we want to get the crosshair y offset that we have set earlier. And I realized the name here might not be perfect. Let's just call it y offset. Although with that, we have to reopen the crosshair script because this line wouldn't work anymore. We simply want to get y offset. Now we can close this script and then work inside of the player graphics. Like we have done with the crosshair, I want to get onReady var y underscore offset, which we get from get parent and then y underscore offset. After we have that, position.y is going to be the y offset if ducking is the case, and if it is not the case, else it's going to be 0. With that, let's try all of this again. I can duck, and the torso doesn't update. And I think I know why. Inside of the player, when we are calling animate, we are only calling update legs, not update torso. For that, we can duplicate this line. And now we want to update the torso, for which we need other arguments though. First of all, for update torso, and let me actually copy the parameters. For the direction, I want to get the aim direction, not the direction itself. Direction is for moving, aim direction is, well, for aiming. Ducking can stay the same, and current gun doesn't exist at the moment. And we're going to work on this in just a bit. For now, I'm going to set this to 0 to just ignore it. And now we should have ducking in the player. That is working much better. That means we can now start with the proper animation. So inside of player graphics, in the animation player, and let me disable the animation for the legs because that's going to get annoying. For the torso, we have an animation player with a huge amount of animations. Now you could manage all of this writing code. It would be possible, but well, really annoying to work with. Instead, what you would rather use is an inbuilt Godot node that is called an animation tree. This part essentially controls an animation player. In fact, when you look at the inspector, there we have an animation player. And for our purposes, we want to drag our animation player in there. So now, via this animation tree, we can select one animation from the animation player. We just have to figure out how. And for that, we can set a tree root. And there are a few things that you can do. In our case, we want to create an animation state machine. If you click on that, you get something like this. Looks a bit strange, but let me explain. Basically what this thing is doing, it tries to figure out the state of the player. So in our case, we have 3 different states. If the player is holding the AK-47, the shotgun, or the rocket. Which means from the starting position, we can add a node. So if you right click, you can add an animation. So we can check any of the animations from the animation player. But this is not actually what we want to do. Instead, we want to create a blend space 2D. And this we can rename to AK. Also, I want to move it a bit further to the right, something like this. And then I want to connect the start point to the AK, for which you want to select this symbol thingy. Then select start to AK. This means that we are transitioning from start to AK by default. And then inside of this node, we can select an animation. For this transition, you can set this to immediate, sync, or at end. We're going to work on this in just a second. For now, we are simply going immediately to the AK animation. That means we want to get back to the general selection thingy or this mouse thing and then click on the pencil. And then we are getting something like this. This is a blend space 2D. And this we can also extend by clicking on this symbol. So, what is happening here? In the most basic sense, the way you want to think about it is that we are getting this crosshair in the middle. That thing we can control via code. But you can also move it with the mouse. So if I move it around, then we are getting a point. And we're going to update it later on via the aim direction. For example, if the player is aiming to the right, then we're going to set this point all the way to the right. And what Godot allows you to do is to check if this crosshair is close to a specific point that we are going to create. And for that, let me move it out of the way and then select this pencil, which is called create points. And then if I left click, I can add the actual animation that I want to play, which in my case is going to be AK right. And then we're getting a point. And once this crosshair gets close to this point, then we are playing this animation. Now for that to work, we have to create multiple animations. So at the bottom, I want to left click again and then add another animation. And you might be tempted here to add AK down. But that would be incorrect because if you look on the left side, there we have the Y coordinate, which is -1 and 1. So usually in Godot, the coordinate system starts in the top left. Meaning, if you want to go down, you have to increase y. But for this particular system, the coordinate looks like this, where the origin point is in the bottom left. So if you want to go down, you have to decrease y. I have no idea why the coordinate system changes between these 2 different systems, but it is what it is. It can get really confusing. Now to get around that, you could simply invert these numbers. Or alternatively, you can simply add AK up at the bottom. which doesn't feel right, but it is what it is. Now you can see here, this point is not actually at the bottom, which is going to be a problem. I'll fix that in just a bit. First of all though, I want to add one more point, so we are getting a triangle, for which we need 3 points. The point I want to add for this one is AK down. And then we have a triangle. But I messed up 2 points. This point at the top should be at the top border, and this point at the bottom should be at the bottom border. And if you try to drag these points, you can't really do it. Godot is simply giving you the menu. To move these points, you want to select this move point symbol, and then you can drag the points. Like so. In fact, I would generally recommend to have this thing selected, because if you have it selected and you right click, then you can still add animations. For example, for this side, I want to add AK left. And then we get the final, well, not the final point, but we get the first 4 points. And via that system, we can move the crosshair. For example, if the crosshair is somewhere down here, then Godot is going to play this animation. If, however, the crosshair gets to this point, then we are going to play this animation, which is the best way to manage loads of animations like we have for the player. And for all of that, if you have the animation tree selected, once you have one of these blend space 2Ds, you're getting a parameter. And in there, you have AK and the blend position. Let me open AK again. The blend position at the moment is 0.9 and roughly 0. That is because our crosshair is pretty much on the right side, in the middle. But if I change this position to, let's say, 0.5 and 0, then I can get out and the crosshair has updated. Sometimes there's a bit of a delay, but you get the idea. So this blend position, we want to update in the code, for which we want to look at this script, and let me go out of the main view. I want to get in code the animation tree, and then via indexing, get the parameter. In there I have AK, and in there we have the blend underscore position. And that value is going to be the direction that we are getting from the parameter. For both of those, we want to have a vector too. With that system, inside of the animation tree, the blend space, we are controlling this crosshair with our aim direction. Now there's just one more thing that I do want to do. When you look at blend, at the moment, this is continuous, but that's not what we want. We want to have this second point selected. That is because if you have this point selected, Godot is trying to find continuous points inside of this animation, but those don't exist. On this point, there's no animation. Instead, we want to jump to the next point that is available, which I get via this thing. If I now run the game, we're getting an error that parameter, aka blend and blend position, doesn't accept a value of vector 2. So what happened? And well, I simply made a typo. This should be parameters. An easy way of getting that is if you have the animation tree and AK, you can simply right-click on blend position and then copy the property path. With that, you are getting the proper path. Next attempt, the game doesn't crash anymore, and now we're getting the right animation. This is looking really good. Although we don't have all of the animations. If the mouse cursor is in the top right of the player, we don't have the right ones, and the same for the other position. So we have to add just a bit more. That also happens inside of the animation tree in the blend space 2D. We have to add 4 more points. And this part is going to be your exercise. Add the remaining points to the blend space 2D in the animation tree. There should be 4 more animations to add. Pause the video now and see how far you get. Back inside of Godot, I want to maximize this thing again, and then with the mouse cursor selected, in the top right of this thing, I want to add an animation for AK. And remember, the vertical axis is inverted, meaning up is down and down is up. Or in our case, we want to get AK down right. And for the other side, this should be AK down left. On the bottom, we want to get AK up left and AK up right. There we go. And this covers the entire spectrum. So if I now run all of this again, the player should get a proper sprite in every single direction. This works with the mouse or with the gamepad perfectly fine. So cool, this is working really well. That would cover one of the guns, but now we have to figure out the other two. Or if we are looking at the code, for the current gun, we have to figure out which gun the player is actually holding. Right now, we only have a placeholder 0 in there. On top of that, the guns should be available globally. That way, the soldiers later on can also reuse the gun data. And to make all of that work, if I go back to the 2D screen and minimize all of the folders, I want to add another folder, which I am calling global. In that folder, I am going to create a new script that I am also going to call global. Click on create, and now in there we have another script. This script should be available in every single scene, which means under project, project settings, and autoload, I want to autoload this script all the time. For that, I want to select the script in global, and then as a node name, I want to call it global as well. Now click on add, and we have this script available everywhere. Which means if you're running the game, you can look under remote in the scene tree. There we have global available in every single scene. That's a really good start. And in there, we want to create an enum that I have called guns. And the guns we have are called AK, shotgun, and rocket, all in uppercase letters. Now, you might not be entirely familiar with enums in Godot. If that is the case, definitely read the documentation on enums. They are really useful. But fundamentally, they're also fairly simple. Basically, via this system, we are creating a bunch of constants called AK, shotgun, and rocket. And we are assigning a value to them, which by default is simply going to be an integer. So the value associated with AK is going to be 0. The way you would access them, let's do this in func_ready. You would simply want to print guns, and then if you press the dot, you get a preview of the available values. Let's print AK once the scene is ready, and if I run the game, we're getting the output of 0, because that is the value associated with AK. Via this system, it's really easy to see when we have the guns, what guns we have available. For example, for the player, all the way at the top, under gun, I want to create a variable called current_gun. And this value we're getting from global, and in there we have the guns. If you now press dot again, you're getting the available guns, and the current gun at the start should be AK. That way, when we are animating the player, I can pass through the current gun. And also, while we are here, we want to give the player the ability to toggle through different guns, for which we will need input one more time. I want to add another section called switch and check if input is action pressed, and the action we are looking for is called switch. I have to find this one in the input map. For now, let's make sure it's working. I want to print switch. Now we can run all of this, and I think in the game we have the middle mouse button for switch, and on the gamepad it is one of the shoulder buttons. Yeah, the top left shoulder button gets you switch. That means the input is working. Now we have to figure out how to get the next value inside of the enum. So at the moment we are on AK, and if we're pressing switch, we want to get shotgun. For all of that, we always want to get global and then the guns. And I suppose while we are here, let's print the result that we are getting. If I now run all of this simply with global guns, I am getting the dictionary with the appropriate values. So AK 0, shotgun 1, and rocket 2. And I can also access the values via the string. So for example, what we could be doing, I want to get only the keys on this dictionary at the moment. And don't forget to call it. If I now run this again and I switch, I am only getting the key names. And on this, I can perform indexing. So for example, if I want to have the first value, I can get AK. That works just fine. All of that I want to store in a local variable. Var, let's call it selected gun. And for all of that, we want to pick what we have just created. Now, I don't always want to pick the first index. Instead, I want to get the current value, so global guns AK, or the value 0, and then increment it by 1. And if we exceed the length of the number of guns, then I want to go back to 0. Now, to fix the indexing part, we simply want to get the integer of our current gun. That way, we are converting the enum to an integer, which Godot is happy with. So let me print the selected gun and run all of this. We are getting AK. And the integer part isn't strictly necessary. You can remove it because remember, we are simply declaring a const with a value. So this part would also work, but sometimes the Godot debugger is complaining about it. I think for now he is okay. We are simply not using the current gun argument, but that's fine. So for now, I can simply add +1 to our current gun. If I now run all of this again, and I press the middle mouse button, we're getting shotgun, shotgun, and well, this only works once. That is because our current gun always starts at 0, and we are never changing this value. To fix that, we actually want to update our current gun right away, which is also what we want to print. Let's try this again, and now we're getting shotgun and an error that we are having string and int and operator plus. So effectively what we are trying to do here on the first operation, we are returning one of the keys, which is something like AK, shotgun, or rocket. And then once we have done this once, we are trying to add the value 1 to it, which obviously doesn't work. What we actually want to do is to use the selected key to pick a value from the actual global guns dictionary. So in other words, I want to use all of this in indexing and then get my global.guns. Now this part should be mostly working. I can press it once, we get 1, 2, and then a crash, because index 3 is not inside of this dictionary. We have simply exceeded the length of it. To account for that, when we are getting the current gun, I want to put this in parentheses and then use modulus with length of global.guns. And that way, I can press the middle mouse button and we're getting 0, 1, 2 forever. This part is now working pretty good. And I guess this line does get a bit more complex, so maybe go through it in your own time. But fundamentally, we're getting the global guns dictionary. And from that, we want to use indexing to pick one item. For that, we're getting the global guns keys and pick one of the items depending on the current gun index. That's all that's happening in here. And that is also the value that we are passing through inside of animate. The current gun is what we are passing through to player graphics and update torso. So now we can work in there. And in here, we can work inside of the animation tree. More specifically, we want to create 2 more blend spaces 2D. The first one is going to be a blend space 2D for the shotgun. This one is going to look very similar compared to the AK. Or in other words, if I click on the pen symbol, once again, we are inside of this blend space. Let me expand it, and then with this arrow selected, I can, for example, add on the right side the animation for shotgun or SG in short and right. The same thing for the left side, shotgun left. Then at the top, I want to add animation for shotgun down. And at the bottom, animation shotgun up. That would once again be the 4 main sides. Then we can do the corners in the bottom right. We have shotgun up, right. On the bottom left, we have shotgun up, left. In the top left, we have shotgun down, left. And then in the top right, shotgun up, down, right. And I messed quite a few things up, so let's fix that part really quick. This part can be slightly fidgety, but basically, you always want to have either the corners or the edges. But that is basically it. So with that, we can at the top go back to root, and then we are in the overview. And for example, at this point, we could remove this forward arrow and then instead go from start to shotgun. If I now run the game, the animation for the player should be for the shotgun. And something went wrong, the player is only looking up. So let's investigate. Inside of the animation tree, at the moment I can't select anything because we are getting the path. So what is happening here is that I have to select the arrow. This can be really fidgety sometimes, so make sure that you have selected the right tool. Anyway, now I can go to shotgun, and the main issue is that we are selecting a continuous path, but we have to get discrete points. So with that, this should work. Let's try. And it's still not working. So next attempt, I think I know the issue now. Inside of the animation tree, we are only updating the blend position for AK. But if you look at the animation tree, inside of parameters, we now have AK and shotgun. So for the shotgun blend position, we have to update a separate property path. Or in other words, we basically want to update the animation tree for the AK position and for the shotgun position, and then update the direction in the same way. Next attempt. Let's see if this one is working. And there we go. This is looking much better. Now we have the gun animation, and everything else also works just fine. That brings us to the next issue, that we want to be able to switch between the shotgun and the AK. Also, the AK by default should be the starting animation, so it should be looking like this. However, if the player switches a gun, we want to go from AK to shotgun. Or in other words, we want to have another transition from the AK to the shotgun. But this by itself is not going to work. If we now go back to the 2D blend space, we are always going to get the shotgun because we are starting at the, starting point, then we are going to the AK, and then immediately we are going to the shotgun. That is not something we want to do. So with the transition node selected, so click on this green thing. If you look at the inspector, you can see switch and advance. Under advance, you can set a mode. There's auto enabled and disabled, but this we don't really want to touch. And then you can set a condition and an expression. So essentially how this is going to work. We only want to go from AK to shotgun if a certain condition is met. And the condition that we are looking for, if I go to the script inside of the player, the condition we are looking for is that the current gun is equal to global guns and shotgun, for example. Then we are going to the shotgun. So how can we check for that? And well, for that, you can either set a condition or an expression. And well, expression is the one you actually want to use. Condition, I find, is really limited, so I tend to avoid it. And expressions are very, very powerful. You basically write some GD script in here, and then if this value returns true, you're automatically going from AK to shotgun. Although we do have to set a few things up. For that, I want to work inside of player graphics. And then for the animation tree, I have to add a script. We don't have to change the name because we only have a single animation tree inside of player graphics. This is totally fine. In there, we have to create the variables that we want to check inside of this transition node. We want to write an expression that is basically going to be selected underscore gun is equal to options dot shot gun. Or in other words, we are comparing the player gun with the available guns. But for that to work inside of the animation tree node, we have to have these two variables available, which means in there, we have to have a variable for selected underscore gun, and we have to have a variable for the options. For the options, we simply want to get global and then guns. That's all we need here. We want to essentially copy this enums dictionary. For the selected gun, I suppose for the starting point, we always want to start with global.guns and AK. That though, we are going to overwrite. For that, inside of player animation, and let me minimize the animation tree, I want to update, I suppose we can do that all the way at the top, the animation tree dot selected gun. And this one should be the current gun that we are getting from the player. That way, inside of the game, by default, we have the AK selected. But if I press the middle mouse button, we're getting the shotgun. And all the other animations still work just fine. So that's a good sign. Although if I press the middle mouse button multiple times, nothing happens. So we're not there yet. But before we fix that, I do want to talk about the animation tree just a bit more, because this is really important to understand. So this is a very simple animation tree. We always have a starting position, and by default, we are going to the AK state. And in there, we have a blend space 2D that checks which kind of animation we want to pick. However, from this point, we can go forward to the shotgun if a certain condition is met. The condition we have outlined there. After that, inside of the shotgun, we have another blend space 2D that selects the right animation inside of the shotgun state. When you're getting started, this kind of system can be incredibly confusing. So I hope it's not too overwhelming. If you play with it for a bit, it should become fairly straightforward, but it does need some time. Anyway, at the moment, the issue is that once we're getting to the shotgun, we can never go back. For that, I want to add another forward transition. This one goes from the shotgun back to AK. And for that, we have to add another advanced expression. We want to get the selected underscore gun, the one variable that we have created, and also the one that we are overwriting, and check if this is equal to options.ak. If that is the case, I can run the game again. And now, if I press the middle mouse button, we're getting to shotgun, and if I press it again, nothing happens. Because now we are trying to get to the rocket launcher that doesn't exist yet. But if I press one more time, we are back with the AK. So this part is working just fine. I can press again, and we have the shotgun once more. Perfect. And with that, we can switch between the AK animations and the shotgun animation. We simply have to set an advanced condition for any of these forward transitions. Alternatively, you could also work with the mode that you don't advance automatically, and instead, in code, you forward to another blend space 2D. It's possible, but I find it kind of tedious, and having all of this automatically works much better. So, with that, there is just one more state that we have to cover, and that is for the rocket. And this is going to be an exercise. I want you guys to add the rocket launcher animations to the animation tree. Pause the video now and see how far you get. Back in the code, I want to add another blend space 2D. This one is going to be for the rocket. It could also be rocket launcher, it doesn't really matter. In there, we want to add all of the rocket animations. So at the top, we want to get a rocket, and this one is going to be for rocket down. Then on the other end, we want to get RO up. There we go. And let's move it down right away. Then on the right, we want to have RO right. And on the left, we have RO left. Those are the 4 main points, and for the corners in the top right, I want to have rocket down right. Then we have rocket down left, and top left. There we go. 2 more points. We have RO up right. There we go. And finally, we have RO up left. And once again, move the points in the right position. This covers all of the animation states that could be possible. With that, we can go back to Rocket, and now we have to add the forward conditions. And we are going to need quite a few. So from the AK, we can go to Rocket, and from Rocket, we can go to AK. And now we have an issue. Since these animations work automatically, we are switching between them really fast. And if you look at this inside of the game, this is not working ideally. Let's remove one of them to have all of this a bit more straightforward. I only want to go from AK to Rocket if a certain condition is true, and that we're setting inside of the expression. It's ultimately going to be fairly similar compared to what we have done with AK and Shotgun. I can literally copy all of this and paste it in there. The only difference is that we want to check if the selected gun is equal to Rocket. And once we have that, we can do the other case that by default is going to be automatic, but we only want to do it if we have selected gun equal to options.ak. And then one more path from the rocket to the shotgun. This one we can literally keep as it is, and for the other path, we want to advance to rocket if selected gun is equal to options and rocket. And that is all we need. With that, we have a fairly robust system for the animations. Now for that to work though, inside of player graphics, we also need to update the blend position for Rocket. And for that, I can duplicate this line one more time, indent it properly, and I believe I called this one Rocket. Once we have all of that, I can run the game, and we get the AK animation. I can press the middle mouse button. We're getting the shotgun animation, and if I press it one more time, we are getting the rocket, but nothing else is happening. And usually when that happens, inside of the rocket blend space 2D, check that you're getting discrete points. So let's try this one again. And now this is working. So this feels really good. And with that, we have the player animations. Now obviously nothing else is happening at the moment, but that we can work on in just a bit. For now, I am pretty happy with that. With the player covered, we can start adding things to the level. The two major objects that I want to add are the lights and the level transitions. But for both, we have somewhat of an issue. For example, for the lights, we have 6 variants that are somewhat similar. And on top of that, every single one of them should have a unique point light 2D with its own texture. First one, I want to have something that goes like this. For the second one, I want to have a more narrow one. For the third one, I want to have something that goes around it, and so on. Now, we could turn every single light into a separate scene and then add a bit of extra stuff. That would be possible, but also not really ideal. We would just create 6 scenes with the same nodes and slightly different textures. It just doesn't feel right. Instead, I want to have a single light scene that lets me select the look of the light in the inspector and gives me a preview in the editor. That we can do quite easily by turning the scene into a tool. That way the script will be executed in the editor and we can see the result right away. Which can help you enormously to create, well, tools inside of the editor that are more reusable and interactive. That system we are going to use for the lights and for the transition gates. Besides that, we are also going to create the moving saw blades, although those are going to work a bit differently. They're also fairly simple, and I didn't know exactly where to put them, so we are just going to add them right here. They are still kind of objects, but also enemies, so it was a bit awkward. But doesn't really matter too much, this part is easy. Don't worry too much about it, instead, let's get started by building some tools. Back in Godot, at least for now, we don't need entity, player, or player graphics anymore. Instead, I want to create a new scene, with the parent node being a 2D scene that I'm going to rename right away to light. I also want to save all of this under scenes. I want to create a new folder called objects, and in there we have light.tscn. And now, just to understand how a tool is going to work, let me add a sprite 2D to this light with the Godot logo. Not something we are going to use for the final game, it's just a placeholder for now. Also, this logo I want to scale down a bit to 0.25. Then I can save it, go to the station. We can add the light. Doesn't matter where you put it inside of the scene tree, but make sure it's somewhat visible to the player. Let's say here. If I now run the game, we can see the Godot logo and it doesn't do anything. That is the expected result at this point, so let's add a script. Inside of objects and light, that is totally fine, and create. Let's say I want to make this Godot logo rotate, for which I want to use the process function and then update the rotation degrees. We can simply add this by some amount. Let's say 100 times delta, and if I now run the entire thing, we're getting a rotation. So that works just fine. However, this result you can only see inside of the game. If I go to the station in the editor, the Godot logo is entirely stationary. Most of the time, this is totally fine. But for this particular case, I do want to see the result in the editor right away. How can I do that? And well, it's quite easy. All you have to do in this script, all the way at the top, add tool. And that's literally it. If I now save the entire thing and then reopen the scene, we have the Godot logo rotating inside of the editor. And that is working pretty well. So simply by adding a single line, we can build much more interactive stuff right inside of the editor, which is something that we are going to use quite a bit. But you do want to be careful here. If you add too many of those, the Godot editor is going to become very slow. So only add things that are actually necessary. Oh, and by the way, what you can also do with this system is add a hint with if engine.isEditorHint. That way we can tell if we are in the editor or not. For example, I could make the Godot logo only rotate inside of the editor, but not in the actual game. There you go. Now, why you would want to do something like that, I have no idea, but it is possible. That is basically all you need for the basics of tool. Inside of the light, we still cannot see a preview inside of the light scene. So very often, when you're using a tool, you want to close the scene and then reopen it. Then things are updating. So with that, we can start working on the actual light. Let me get rid of all of the stuff we have done so far, but keep tool. Also, inside of light, I don't want to have the sprite 2D anymore, so this we can remove. And then I want to reopen the scene just to make sure we don't have any kind of residue. For example, right now, you can see that this gizmo that shows us the origin of the node 2D is slightly rotated. It's not supposed to look like this. And inside of the inspector, you can see there's one change, that we have a rotation, which I do not want. Once you're adding tool, whatever change you make inside of the editor will be permanent, so it will also show up in the game, which can add some weird behavior. Now, this system we are going to use along with a whole bunch of lights. So if you look at the graphics folder, there we have objects, and inside of objects we have lights, which I want to add to a sprite 2D. Then we can drag it in there, and there you can see the lights you have seen in the intro. To only get one of them, I want to go to animations and then H-frames, and in total we have 6. So now we can pick one of them. Besides that, for every single light, I want to add a point light 2D, for which we are going to need a light texture that we have to add inside of the inspector. In the lights folder, you have a couple of them. For example, for the first light, the one on frame 0, I want to use L0 and drag it into the point light 2D. Now this right now we cannot see because we don't have a background. For that, inside of light, I want to add a colored rectangle behind everything else and then change the color to something a bit darker. If you now extend the entire thing, you can tell what's going on. Also make sure to lock this rectangle so you don't select it accidentally. Now with that, we can move the light into the right position, Something like this looks about right. If I now hide the background, you can't see the light anymore. But if we go back to the station, you can see we have the light, which is the rotated for which you want to reload this station scene. And it's still looking weird. For that, inside of the light node, under transform, you can see we have changed rotation in here as well. And if we reset that, now it's looking all right. So with that, we have a light. Now that would be a single light. But in my case, for the light scene, I want to have multiple lights. So for example, for the second light, I want to get frame 2. And then for the point light for this one, I simply want to squash the entire thing on the horizontal axis. Something like this. So if I save it now, inside of station, you can see the result roughly. And this I need to do for all of the lights. Since that is some manual labor, if you open tutorial data, there we have all of the light options. So all we have in here, let me make this one visible and hide everything else. You can see we have the sprite 2D along with the point light inside of a node 2D. For the second light, then we have the third light, the fourth light, and so on. They always have the same setup. We have a sprite 2D and a point light. And all of these options I want to copy. So with options selected, copy it, and paste it into light. Then we don't need the original point light, sprite 2D, or color rectangle, so those can all go. And now we simply have the options left. This still works just fine, so I am quite happy so far. And now the system that we are going to implement is inside of the light, which is still a tool. I want to have a drop-down menu in the inspector that is going to select a number between 0 and 5. And depending on what we are selecting, we are hiding all of these nodes bar 1, the one that we have selected. And for that, I want to work inside of the script for light and create another export variable. The one I want to create now is called export enum. This one allows us to set a couple of options inside of a drop-down menu. As an argument, you want to have strings with all of the items. For example, in my case, I want to have a string for 0, for 1, for 2, for 3, 4, and finally 5. This we then have to store in a variable that I have called type. With a default value, let's go with 0. If I now save the scene and select the light again, inside of the inspector, we have a type with the options we have just specified. With that setup, as soon as the user selects one of these items, I want to hide all of these nodes and then reveal the one that we have selected. And for that, I want to use setGet. To achieve that, I want to add a colon and then use set, which wants to have one parameter that is going to be the value. Whenever we are updating this value, we are calling this function. And via that, we still want to overwrite the original value. So we always have to add type is equal to value. That way we are actually storing the new value. But on top of that, what we could be doing is simply print the value that we are getting. With that, I can close tutorial data. We can save it, doesn't really matter. And if I now reopen the light, on the parent node, I can select different options. And if you have output open, you should be seeing the result right away. Inside of the editor, for this, we don't have to have the game running. So with that, we are getting the individual number, and that we can use to hide all of the nodes and then only reveal the one with the right number. Or in other words, I want to have for child in the options, and then I want to get the children and run child.hide. Besides that, I want to get the new child, the one that we want to keep visible, which I can get via the options once again, except now I am using getChild along with the type that we have selected. Although important at this point, inside of export enum, we have created strings, but for getChild, we need an integer. So the string we need to convert to an integer. Once we have that, we want to run child.show. With that system, we are hiding all of the nodes, and then we are showing only the one that was selected. This would work in theory, but in practice, I think there are going to be some issues. So once again, let me reopen the light scene. And if I now select one of the options, oh, it actually works. We get only the one visible item that we actually want. So in theory, this is working, but if you look in the bottom left on the output, we are getting some weird stuff. That sometimes we have an invalid call, non-existent integer constructor. And that is something that is a bit annoying with tools. That sometimes these things are loaded before the actual scene is ready, which makes sense because we are running all of this in the editor, so sometimes things can be a bit weird. Generally, what I have found best is before you're making any changes in the code, you want to check for two things. Number one, the value that we are getting actually is a value, or in other words, it's not null. Besides that, you also want to check that there are children inside of the scene. Or in other words, before we are doing anything, I want to check if get children or child count is greater than 0, meaning we have at the very least a single child. And the value is different from null. Only if that is the case do we want to do all of this. With that, if I go back to the scene and I select another option, we should not be getting an output error anymore. And if I go to the game, this should also be working just fine. Perfect. So with that, we are getting the right option, and we have some safeguards to make sure that the game doesn't crash. I suppose we can also refine this just a bit, because this child variable doesn't need to be there. We can simply get options get child of the type, then show the result. Very minor improvement. In practice, this is not going to change a thing. Perfect. Oh, and by the way, when you're looking at the output, we are always getting a 0. That is because inside of global, we are printing the gun option, which I think is a bit confusing at this point, so let's remove it entirely. Righty, with that, we can select the right kind of light, which is a good start, but I want to add a bit more. So for example, when you're looking at one of these lights, let's do it inside of the station. You can see that we have a light texture, although it's not terribly visible. This thing I want to customize just a bit more by adding a custom color. When you're going to the light and have the point light 2D selected, there we can set the color. And if you update this one, let's go with a pure red color, save all of this, and then back in the station, we have a red color. This I want to update in real time in the editor. Or in other words, with the parent node selected, I want to, below the type, set the color of this light, for which we can set another export variable. I want to create an export color no alpha, for which we need a variable name. Let's call it color. And then a default value, which I have set to the color type. And then we need a default value. We can set this one simply to 1, and then we should be good to go. I can now save the entire thing, and back inside of the scene, you can see we have a default color. Although by default, this one is black at the moment, and it should probably be white. So just to make sure we're getting the right value, let's go with 1.0, 1.0, 1.0, and 1.0. That way I can reset the value, and we're getting white by default. Now we have a color, and every time this color value changes, I want to update the color of the point light. This part is going to be your exercise. When the color value is updated, change the color of the point light 2D. Also, make sure that you're adding safeguards as well, like I have done before. Pause the video now and see how far you get. To get started, I want to use the set method along with a value. And fundamentally, I want to update the color to the value that we are getting. So we are actually updating this variable. On top of that, I want to get the currently selected child and then update the color. Or in other words, I want to get the options Then use get child along with the integer of the type, the value we are getting from this export enum. That would give us, for example, this node setup, where we have a parent node 2D, then we have a sprite 2D, and then a point light. And the point light is always child number 1, or, well, the child with the index 1, which means I can simply get the child with the index 1. And since this is a point light 2D, I can update the color. The value I want to set is the value that we are getting from the parameter. That's basically all we need for the basic logic. Although, before we are doing all of this, I want to add the safeguards once again, which means I want to check if getChildCount is greater than 0 and value is different from null. Only if that is the case do I want to do all of this. But other than that, now this should be working. I suppose we should reload the scene, which you want to do very regularly when you're working with tools. And I guess now, just to see what we are getting, I want to add a color rectangle as a background once again. Working with lights in Godot occasionally can be a bit frustrating because you cannot see them by default in the editor. So there we go. By default, we have a red light. But if I change the color to something else, this updates in real time. I can also change the color to something bluish or something greenish, and this is looking really good. Perfect. We can also try all of this with a different light, and it does work. Although the issue here that you could refine later is when you're changing the light, this color isn't reapplied. Oh, and also for this light, we have hidden the actual point light 2D. Just to make sure I didn't do this more often. No, I think it's just for this one light. Okay, cool. So this is working. And just to talk about it again. So one issue that we have right now is that we can change the light and the type separately. For example, if I go to 1, we're getting 1 light. But if in there I'm changing the color, let's go with something really visible, this dark purpley color. If I now change to another light, we keep the value we had before. Although this we could change by simply selecting the color once again, and then we're getting the updated value. I suppose this is a bug minor enough that you can work on it on your own. In my case, I want to add some other stuff first of all. Most importantly, I want to set another export enum that is going to be an export underscore range with a start and an end value. Let's go from 0 to 10. Then once again, we can create a variable with the strength of the light. And the value I want to store for this one is going to be 1.0 by default. The 0.0 here is important because I do want to create a floating point value to get a greater range of values. In there, I want to set the value once again, or in other words, I want to update the strength to the value. After that, like we have done before on this line, and let me extend it. So when we set the color, we have gotten always the first child of whatever type we had selected. This I want to do again for the export range for the strength of the light. Except now we don't want to get the color, we want to get the energy. Because when you look at any of these nodes, the point light 2D, besides color, we have energy with a default value of 0.8. I think I've set this one earlier. And once again, this we only want to do if there are children inside of the scene and if the value is different from null. With that, we should be able to set the strength of this thing as well. And I think at this point you get the idea of all of this. So back inside of the light, I want to get a different one, and there you can see we can update the strength of the entire thing. Works pretty well, and this is a really nice effect. If I hide the color rectangle and save the thing and go back to the station, there we can actually set the values. So in there, I can update all of this, and then we are getting some pretty decent values. Although if I reset the values, we are getting what we have set in here. So the way you want to think about it, when you're setting the values for a tool inside of the inspector in the actual scene, you are setting the start values for any of the instances. Those values you can still update, like I'm doing here or here. You get the idea. So you only really want to update any of the instance you are creating from the original scene. And I guess let's go with some slightly better color, more bright. Guess we can go with a very slight yellow color and then reduce the strength quite a bit. I think something like this would look alright. And if we try all of this in the game, it also works just fine. Perfect. At this point, also inside of debug, we don't need visible collision shapes anymore. And with that, we have made quite a bit of progress, that we have created a tool that can be much more reusable inside of the game. And let me reset the default values, so this is looking just a bit better. Besides this light texture, I also want to have another light texture around the entire thing, so that we have a bit more light in general when the player is close to a, well, light. For that, back inside of the light, I want to add another point light D, and this we can add before we are doing anything else, and call it main light. For this main light, we are now going to need a light texture, which you can find under lights and main.png. This I want to drag into the texture. And now we cannot really see this inside of the scene, but if you add the color rectangle and expand this thing a bit, you can roughly tell what's going on. I guess if I hide this thing and then save the entire scene back inside of station, now you can see a bit better that we have a light radius around this light. Now this I also want to customize via the inspector. Or in other words, I can minimize all of this and then add another export variable, which once again is going to be an export range1 with a value from 0 to 20, and the variable you want to create is called radius, with a default value of 1.0, after which we can use value. And I think at this point you have seen this often enough. We want to add the safeguard and then update the actual radius by setting it to the value that we are getting from the parameter. After that, I want to get the main light, target the texture scale, and set this to the value that we are getting. And with that, if I save the scene and go to the station with the light selected, I have a radius, and this radius I can use to change the size of the light, which I think is working really well. Nearly done. There's just one more thing that I would like to add. And this is going to be another export range with a value from 0 to 200. The variable I want to create is called flicker, which is going to get a default value of 100.0. So we have a floating point value once again. Essentially, this light shouldn't be static. It should be flickering, just to make it feel a bit more worn down. For that, we don't actually need to use set again. Instead, we want to use inside of process. Oh, and I realized I didn't mention, I added an underscore so Godot doesn't complain about the parameter. What we want to do now is make the light flicker, or in other words, generate a random value and then update the energy of the point light 2D. So it looks like it's slowly turning on and off at random intervals. The way I have approached that, first of all, I have created a noise texture, which we can do by creating a fast noise light.new. What this is going to do, if I go back to the editor and simply add a sprite 2D without any texture, if you now go to texture, there we can create a noise texture 2D, which is a bit large. If you click on this one again, there we have a noise and we can create a fast noise light. This is what a fast noise light looks like. It's more or less a cloud. What we want to do is pick one row of this texture and then simply look at the values. So do we get white values or dark values or white values again, and so on. That value is then going to be between 0 and 1. 1 for pure white color and black for pure black color, along with all of the shades of gray in between. Since we then start from the left side and go further to the right, we are essentially getting random values that slowly change over time, which can be a really nice effect. And that is what we want to do. So with that, I can get rid of the sprite 2D and instead work inside of the process function. First of all, I want to update a value, which doesn't exist at the moment. For that, I want to create another variable value with a default value of 0.0, and this should always be a floating point value. After that, to this value, I want to add the flicker multiplied with delta. The flicker we just created and delta we're getting from the parameter to make sure things are frame rate independent. After that, we want to target our currently active light, or in other words, our visible light at the moment, which currently is light 0. For that, I want to create another variable, active underscore light. I suppose visible light might be a bit better here, but you can name this whatever you want. This needs to be some kind of point light 2D, and we have to sign it when the scene is ready. For that, I want to use func underscore ready, then a for child in options and get children, in which I can check if child is visible. If that is the case, the active light is going to be child.get child1. I hope this part is fairly straightforward. We are simply looping through all of the children and then setting the visible light to the active light. Once we have that, inside of the process function, I can check if we have an active light, and if that is the case, I want to get the active light and update the energy. And on that, I want to get the noise texture we have just created up here, and then use the function getNoise1D, on which we want to have a value. If I now run this scene, nothing is happening. And that is because, this should be underscore process, not just process. Let's try this again. And now we are getting something. So this is looking all right, although a bit weird. To understand a bit better what's going on, let's print a value that we are setting. So I want to print noise getNoise1D value, and then you can see that we are usually getting a value around 0. Sometimes a bit below, sometimes a bit above. This we want to modify because these values are generally too low. The formula I found on the internet that worked best is +1 divided by 4.0. And then to the entire value, I want to add 0.5. There isn't really a specific math behind it. This just looked good. So if I now run this again, this looks much nicer. With that, we don't have to print the getNoise1D anymore. And instead, we have a nice flicker for the light, which, by the way, is also going to work inside of the station. So in there, you can see the light flicker. And if we update the value, let's say to something lower, the flicker gets much slower. And if it's 200, it becomes much more noticeable. We can also disable it entirely, so play around with this as much as you like. And that would be a tool light that is incredibly powerful. So now, inside of the editor, you can simply duplicate the light, move it around, and then change the type that we have, let's say to something like this. You can update the color, then the strength you can update, the radius you can make smaller for this one, I suppose, and we could work with the flicker. Let's disable it for this one. And that's the whole idea. With that system, instead of having 5 scenes, one for each light, you can simply update the light right in the editor, which makes everything just much more organized. Now, in terms of organization, inside of the level, I want to add a couple of lights to the background. So in there, I want to have a node 2D with BG lights. Those are always going to be behind the player. Besides that, if you want to have a light in front of the player, under FG, I want to have FG lights. Now you can save all of that, and back in the station, let's say I want to have this first light in front of the player, FG lights. And this light should be behind the player. It should be in BG light. If I now run the entire thing, we have the light in front of the player, and we have the light behind the player. So quite happy with that. For the actual game, I have placed a whole lot more lights. I will repeat that process at the end of this section. What I have also done to make the lights look much better, inside of the level, I have added straight to the level another light. But this is not a point light, but a directional light. If you add this one and save the entire thing, if you now look at the station, everything is much brighter. Because via this directional light, we are adding a whole bunch of extra light. If you change the color for this one, you could make the entire thing feel much more different, depending on what color you have selected. Although this is not exactly what I want, because I want to make all of this much darker. And for that, you can work with the blend mode. At the moment, we are simply adding the color. But if you change this to subtract, then we are removing the color we have selected here. So right now we have an orange brownish color, and these are values that are removed from the colors in the actual scene. Meaning at the moment, we are removing lots of red colors, so the entire thing looks dark and blue. If you change this to, let's say, a brighter color, the thing gets darker, and if you go darker, the thing gets brighter. If it's pure black, the end result is going to look like the default. And in my case, I want to make it just a bit darker, and then work with the color. This doesn't look exactly good. I guess we can have a fairly neutral color and then make all of this much darker in general. Something like this. Once again, play around with this for an actual game. In my case, I'm going to be a bit quicker, so it doesn't take too long. And now you can see that the game itself is quite dark for most of the time, but once we get to a light, we still have the flicker, and the game brightens up. This also applies to the player itself, and this is looking pretty good. So with that, we have the lights for our game. Later on, we will customize the directional light just a bit more, but I think for now this is fine. Now, besides the light, we don't need this part anymore actually. I also want to create a transition gate, which is going to be another node where the parent scene will be an area to be, which I want to rename right away to transition gate. As soon as the player is entering this area, then we want to stop the player movement, fade the screen to black, and then load another scene. That scene is then going to be another level. All of this we want to save right away. I placed all of that inside of objects. It might not be perfect, but for a small project like this, I suppose it's fine. First of all, in there, for the transition gate, we will have to add one more node, which is a collision shape 2D. For the gate, I want to have a rectangle shape 2D that I want to make taller and wider. Just to test how things are looking, inside of the station, I want to add the transition gate. Then we can tell how large it is compared to the player. And this is much too big. So this needs to be quite a bit smaller. Something like this maybe. That looks more reasonable. I guess we can make it just a bit smaller, so shorter and narrower. And that looks pretty good. On this transition gate, I want to do two things. Number one, when the player is colliding with it, it should emit a signal. Although for that to work, we first of all want to work with the collisions that the gate can only see the player, which means it should not be on the terrain layer, but it should be on the transition layer. And then it can only see the player layer. That way, if a bullet hits a door, we don't transition to another level. That would be kind of weird. Next up, inside of Node, we want to check if a body has entered. Although to connect the signal, the transition gate, first of all, we'll need a script, which we can call transitiongate.gd. That's totally fine. And now in the transition gate, I want to check if a body has entered. That I want to connect to transition gate on body entered. For now, let's simply print transition. And let's try the entire game. If I move a bit to the left, we're getting transition. That's looking good. The actual transition we're going to cover in just a bit. First of all, though, I want to convert this transition gate to a tool as well, so that inside of the inspector, when we are placing the transition gate, we can also select the target scene. For that, I want to add tool all the way at the beginning and then export an enum, for which we will need the names of the scenes. We have station, then we have sky, and finally we have underground, with the default level being station. Other than that, I also want to create a levels dictionary. The issue we have at the moment is that via this export enum, we are simply selecting a string, either station, sky, or underground. This we need to connect to inside of scenes. We have all of the levels, and inside of these levels, we have sky, station, and underground. I suppose also test, but this I'm going to ignore. I want to connect the name that we're getting from export enum to the actual scene. And for that, once the game is actually ready, so func underscore ready, then I want to check if we are not in the editor, meaning if not engine.isEditor hint. That means we are in the game, and then I want to update this dictionary to have key value pairs, where, for example, we have levels with station getting a path to the station scene. Let me add a bit more space so all of this is visible. There we go. Now we have one entry inside of the dictionary. Besides that, I want to get levels again, create a sky entry, and then get the sky scene in there as well. Finally, one more entry for the underground, and this is going to be the underground scene. If I have transition gate selected, I can select the target level, and via this target level, we are selecting a target scene that we are then able to transition to once the player entered this area 2D. And that we can then use to transition to another scene. In practice, that would mean we are calling get free and then change scene to file. Now Godot is going to give us all of the available scenes, but that's not what we actually want. Instead, we want to go to levels and then select the current level. And that should be it, at least in a very basic sense. If I now start the game and go a bit to the left, at some point, we are getting to the sky level. Now, since that one doesn't have a player at the moment, we don't really get a proper outcome. And also, we are getting some debugger errors, but that is something we can work on. Also, one more minor thing that we can add is an underscore to body, because we are not going to need it. With that, let's open the sky scene and let's have a look. In there, we have another level. To that, I first of all want to add the player. So to the entities node, I want to add the player and then place the player in the starting position right next to the door here. On top of that, I also want to add the transition gate to go back to the station, and this should be on this area here. That being said though, in this station as well, we have the transition gates just randomly in the scene tree, which I just don't really like. To fix that, inside of level, I want to add another node 2D, which is going to be for the transitions. Or I guess we could call it transition gates. Doesn't really matter what you call it. This I now want to save, and if I go back to station, the transition gate, this one should be inside of transition gates. That way we can minimize it, and the entire thing looks much cleaner. After that, inside of the sky, we also have transition gates, and to that, I want to add a single transition gate, which should bring us back to the station. This we have to reposition to get to the door, so pick the transition gate and place it roughly here. And now, if I move a bit to the left, we are ending up in the sky level. If I go to the door, we are in the station again. So we can transition between the levels. It doesn't work terribly well yet, but it's a start. First of all, though, this transition is way too abrupt. It shouldn't happen this fast. Instead, I want to fade out to black, then change the scene, and then fade out back to the level. For that, I want to create a new scene, which as a parent is going to get a canvas layer that I am going to rename right away to transition layer. Via this transition layer, we are going to ignore the camera. And the only node that we are going to add to this thing is a color rectangle that is going to span the entire window and will always be completely black. After we have that, I want to save the scene and I want to save it inside of global because we want to have this thing available at all times. So save it in there and then go to project, project settings, auto load. We already have global in there, but now I also want to get global and transition layer. The node name, transition layer, is totally fine. Then click on add. And now the way you have to think about this system. By default, this area is going to be invisible. But then once the player steps into the transition gate area, we're going to fade it to black. Once we reach full black, we're going to switch the level. And then we are gradually fading out the black color one more time. That way, we have a nice transition. For that, first of all though, when the player is entering the transition gate area, get my transition layer, and then call a method that doesn't exist yet, but I want to call change scene, which needs to get one argument, levels, and level. For that to work, inside of the transition layer scene, I want to add another script called transition layer inside of global. That's totally fine. In here, I want to have the function change underscore scene. The one parameter that we need is called target. I suppose for now, just to test if things are working, I want to print what we are getting. Although now, if I run the entire thing, we cannot see anything because by default, everything is black. And since this transition layer is always visible, we always have a black thing on top of everything else. So not amazing. To fix that, when we are getting started, inside of the transition layer script, I want to get the ready function, target the color rectangle, and change the alpha value via modulate. The way to do that is by assigning a color value, which is going to get 0 for the color and 0 for the alpha value. That way I can run all of this one more time and we can see the level once again. If I now go to the left, we can see the right scene. So inside of output, this is the proper output. That's a good start. Now I want to use a tween to fade to black, load a scene, and then go back to make the level visible. First of all, for that, I will need a tween in general. Create tween. I want to tween a property of the color rectangle. The property I want to target is modulate. The final value, let me expand the code field. The final value is going to be color, where the color itself is going to be 0. Although this part doesn't really matter. The important bit is, for the alpha value, I want to have 1. Whereas in the original, we had a value of 0. Finally, we will need a duration. I went with 0.5, but this you could work with. It's fairly subjective. After we have that, we can duplicate this line because tweens always run in series, which means we are first doing this tween, and after this one's done, we are doing this one. Which means we know on this thing, we want to set modulate back to a color value of 0. Over a certain duration of time, let's stick with 0.5. That means if I now run all of this and I get to the gate, we have a fade to black animation. That works multiple times, so that's a good sign. But obviously, we have to actually load the scene. And for that, we can add another thing, tween and tween callback, which is a function that is going to be called once a tween has finished. It wants to have a single argument, which is the function that we want to call. In my case, open scene. Godot is now going to complain that this function doesn't exist, so let's create it open underscore scene. For now, without any argument. To test things, I want to print open scene. With that, let's try all of this. And we are getting open scene when the screen is entirely black. A really important thing to understand about tweens is that they always run in sequence, meaning we are doing this line first, then we are doing this one, and finally we are doing this one. Meaning this function is always going to run after we have faded the screen to black, which is exactly what we want. But now we have an issue. We have to pass the target into the open scene function, for which we can add one more nice Godot feature. We want to create a callable. Via this functionality, we can always assign an argument to a function. For that to work, we will first of all need two arguments. The object that this callable should be part of. In our case, this will be self. And then we will need the string name of the function that we want to call. Open_scene. And this by itself wouldn't do anything. We can still run the game just as before with the same result. However, what we can do now is add the bind method. And via that, we can bind any argument to this function, and then that argument would be passed into OpenScene. I want to pass the target that we are getting from the parameter from changeScene into the bind method as an argument. And OpenScene will capture that via the parameter. I suppose we could call this one the scene that we want to open. Once we have that, we actually want to get the tree now, and then change scene to file with the scene that we are getting. I suppose the best name for this one would be the scene path. Finally then, if I now run all of this again, I can get to the right place, and now this is working much nicer. So let's try it again, and there we go. Now there's one more issue that we have to deal with. The player during the transition can keep on moving, which feels really weird. To fix that, we have to reopen the player scene. And let me minimize everything. There we go. So for the player movement, inside of process, we have can move. And while there's a scene transition, this value should be false. For that to work, we have to get access to the player from inside of the transition layer. And that you can do in a couple of different ways. I find the best way to do it is to place the player scene inside of a group. Let's call this one player. Then save the scene. And now inside of the transition layer script, I want to get, before we are creating the tween, get tree. Don't forget to call this one. And then get first node in group. The group we want to target is player. Since there's only ever going to be a single node inside of this group, we are always going to get the player character. And on this player, we want to call block_movement, a method that doesn't exist at the moment. So inside of player, we want to add all the way at the bottom, func block_movement. All we want to do in here really is can move should be false. And on top of that, if we have any kind of velocity, it should be set to vector2.0. That way, if the player is currently moving, we are stopping all of that. Let's try all of that. And now if I get to a transition gate, we are at the very least stopping the movement. Also, if we are jumping, this is still working just fine. The last annoying thing is that the player legs keep on moving when we are walking into the gate. To fix that, I want to get the player graphics, and in there we have the legs, which are an animated sprite. So if we are looking at player graphics, open the scene, we have the legs, which is an animated sprite. So on this node, we can simply call stop, and then the animation should stop. Let's try all of that. I can now run into the transition gate, and the player stops animating. Or well, the legs stop animating, but you get the idea. So with that, we have transition gates. That means I can now close transition layer and transition gate. That's all we needed in here. Player graphics we also don't need, and I guess we should keep the player open. Sky though, we don't need for now. That covers the second major part of this section. With that, we have transition gates that we can move around, and we can change the target. I suppose I should show this would also work with underground, or at least I hope it would. If I now go to this part, we're getting to the underground, which doesn't have a player at the moment, so the result is going to be a bit weird. But that I'm going to fix in just a bit. First of all, though, I want to add one more thing. There's saw that is going to move around the platforms. For example, for these two platforms, I want to have a saw that moves in a path around them. Something like this. And this path should be really flexible. Ideally, what I would like is that I can set the path straight inside of the station scene, and then the saw is going to follow it. But let's go through it step by step. First of all, we have to create a new scene. The parent node is going to be an area 2D that I will rename right away to saw, which I want to save, not in global, but in scenes and objects. After that, we can add an animated sprite 2D. And for the graphics, I want to load the saw animation. Although I guess the way this is going to work under animation, I want to add new sprite frames, click on that again, and now click on this grid symbol. With that, we can go to graphics, objects, and saw animation, and tell Godot that we have 4 horizontal frames, but only 1 vertical one. And then you can select the individual images, click on add 4 frames, and we get the animation. If you zoom in a bit, you can also autoplay all of this and make sure you play it as well. With that, we're getting the saw animation. A bit slow right now, let's say 10 for this one, and then this is looking alright. As always, play around to see what works best for you. Besides that, I want to have a collision shape 2D, which should be a circle shape. And the default one here actually works really well. I suppose I could make it a bit smaller. Also for the area 2D parent node in collisions, I want the saw to be on the projectile layer and it can only see the player. After we have that, I want to give the saw a script. Inside of objects, saw.gd is totally fine. And then inside of node, under signals, I want to add body entered and connect it to the script. If this function triggers, we know that the player was hit. So let's print player hit. And so Godot doesn't complain, and underscore to the body parameter. After that, inside of station, we have to add the saw somewhere. And to keep things organized, inside of main, or well, inside of level, and then inside of main, I want to add another node 2D, which is going to be for the objects. I can save this, return to station, and now to objects. I want to add the saw, and by default, it spawns in position 0 and 0. So hold Alt and then move it to the right position. I suppose we can move it right down here, and then also move the player in this general area. That way, I don't have to move around so much while testing. Let's try to run the entire thing, and then we're getting a saw that's animating, and if the player collides, we're getting player hit. That's working pretty good. Now I want to move the saw. And for that, I want to add a path 2D. The way the system works in Godot is that this path 2D is expecting a child, path follow 2D. On this path follow 2D, we have progress. The progress it's referring to is the progress on this path 2D. So on there, you can add something like this and then close the path. We are getting a path that path follow 2D can follow. And then inside of the script, you would write a function to increase the progress and update the position of the entire node. This, however, we can't really do because we want to have multiple saws. Or in other words, inside of the station, we might get this one path 2D. But if we want to have a second one, we couldn't just copy it because the path is always the same for every single node. So that doesn't really work for us. Let me delete the second node and then return to the saw. In there for now, I want to remove the path follow 2D, and on this path 2D, I am going to delete the path I have just created. The easiest way of doing that is under curve, you are resetting the value. That way, there is nothing inside of this thing at the moment. In fact, I just realized we don't want to have a path to D in there at all. We should only have the saw area to D parent node, animated sprite, and collision shape. Because inside of the station, I want to add a path straight to the saw. Although for that, under transform, I want to reset the value. That is usually a good idea to avoid some errors. So right now, the saw is in the origin point of the scene. And after we have that, I want to add another child, which is going to be the path to D that we want this saw to follow. And then I want to go to the place where I want the path to be and draw the points for this path, like so, and then close the path. Now we have a path associated with this scene, and that means we can work inside of saw. And first of all, let's see what we actually get. If I run func underscore ready and print get children, I can run the entire thing, and we can see that in the output, we're getting an animated sprite 2D, a collision shape 2D, and a path 2D. And all of this is inside of a single list, meaning Godot doesn't really care if you have a node inside of the scene tree or if you add another node to the instance of the scene in another scene tree. Which for our purposes can be really nice because that system we can use for the saw. And let me extend all of this. I want to create, first of all, two more variables. The first one I have called path, and this one needs to be a path to D. Next up, another variable is going to be a path underscore follow. The only data type allowed for this variable is going to be a path follow 2D. And then, when the scene is ready, I want to assign the path that we have created inside of this station, this one here, to this variable, which we can do quite easily. I want to get the path and then get the children of this node. And since this path to D is always going to be the final child, we can simply add indexing and -1. Next up, we need to have a path follow to D node, which we're going to store inside of this variable, which means I want to have my path follow variable and then assign a path follow to D new node, which we also have to add as a child to the path. In other words, I want to get the path and then add a child, which is going to be path follow the thing we just created. And then I hope Godot stops complaining. This should be alright. Just to test all of this, if I now run this scene, the game doesn't crash, and I can go to remote, and in there we already have the saw open, and we have a path to D and a path follow to D as a child. This is the setup we actually need. Now we just have to make sure that this path follow to D is updating, or well, progressing, and then that the entire node is following that path follow node. For all of that, we will need another function that is going to be underscore process. Basically, I want to get my path follow variable and add a value to progress. For now, this can be something fairly crude. Let's say 100 times delta. And next up, I want to update the position of the entire scene to the position of this path follow, which means I want to get path follow and position. With that, I can run the game and we're getting the saw in the right place. That's looking pretty good. We also get player hit, so all of this works really well. If you want to be really fancy, you could also make all of this a tool. That way you'd get a live preview of the saw movement. Although I wouldn't really recommend it, because if you make everything a tool, eventually the performance in Godot is going to crash pretty hard. So I am not going to do it, and instead, I want to specify 3 things for the source. I want to have an export var speed, I want to have an export var offset, and an export var for board. That way, we can control the speed of this thing, we can add an offset when it's starting, and we can move it forward or backwards. Creating these 3 variables and using them inside of the logic is going to be an exercise for you. This should be fairly straightforward, so add speed, offset, and a forward mechanic to the saw. Pause the video now and see how far you get. First of all, for the speed. And while we're doing this, I'm going to comment out offset and forward. Speed is the easiest one. I simply want to have some kind of value. Let's go with 100 by default. This speed we then need to use inside of the process function and add speed in there. Then I can run all of this. We're getting the same result. But now for the saw, I can set the speed to, let's say, something really large that we can see a difference. 400. And it is moving much faster. Next up, I guess the easier part is forward. This is simply going to be a Boolean value, which I want to set to true by default. Once we have that, inside of process, I want to have var direction, which is going to be 1 if forward, and if it is not the case, else it's going to be -1. That value I then want to multiply with the progress addition, so multiplied with direction, and then inside of the editor, I can set a tick mark for forward or not, and if it's disabled, then the saw should be going the other way. Yeah, that looks good. So I'm gonna keep it at forward and the default speed, but once again, choose whatever you like. Finally, I want to have an offset, which by default is going to get a value of 0, which can be an integer. And then, when the scene is ready, I want to apply this offset to the progress of path follow. We can simply drag it from there and then set the progress to the offset. And to make sure we can see all of this well, I'm going to set the speed to something super low. Let's say 5. That way, when I start the game, you can see the saw is in the top left. But if I change this value to 100 and run all of this again, then the saw is much further to the right. Perfect. That's all we needed. And with that, we have finished the saw. Now, later on, the function on hitting the player is going to be much more extensive. But that functionality only really makes sense once we have all of the enemies, which is going to be the next part. I'll see you there. Before we finish though, here is an updated version of all of the levels. So inside of Station, Sky, and Underground, I have now added a few more things, but nothing life-changing. Most importantly, for the Underground, I have added the player and the transition gate, along with a bunch of lights. I also updated the directional light for the entire scene, but that's not that much. Same for the sky. In there, I have now a transition gate to go back to the underground, to go back to the station, and we have an overall scene light. Nothing too fancy. So now, if we are running all of this, we can go to the underground, do some things in here, and come back and explore the rest of the level along with a bunch of other things. Feels much more like a real game by now. Oh, also, you might have already spotted. Inside of Project Settings, under Window, I have increased the window size, or the viewport to be a bit more specific, to be 1920 by 1080. For an actual game, we will need a challenge, and for a challenge, we will need some enemies, which is what this part will be about. There are fundamentally 3 kinds of enemies: a drone, soldiers, and some kind of monstery thing. I suppose on top of that, we also have the sword that we already added. Now, for this part, I am going to go in 2 stages. Number 1, we are going to add the basic enemies. Although for now, they are only going to move, but not shoot. That's going to be the second part, because for shooting, we will need bullets, which I want to implement in a way that we have 1 bullet class that we can reuse for the player, for the soldiers, and for the monster. The drone works slightly differently. It simply explodes once it collides with anything. And for that, here we are back in Godot, and let me add a bit more space to the editor. And I suppose also we only need this station. We don't need sky or underground. We also don't need the player right now. Instead, I want to create a new scene. Actually, I don't. I want to create a new inherited scene. The parent node should be inside of entities, the entity.tscn. This is what I want to open. In there, with the parent node selected, I want to create an animated sprite to which I want to add sprite frames, And then for the default animation, that's the only one we need, click on the grid again. And now we want to go to graphics. There we have the entities and the drone. Once again, we have 4 horizontal frames and only a single vertical one. Then select the 4 frames in order and add all of them. For the frame rate, I guess we can go to 12 and then play the animation. That looks about right. It's really nothing fancy. Next up, we will have to set a collision shape, which for this one, I went with a round one. Something like this. Could be refined a bit, but I think it's fine. Also, I want to rename entity to drone, and then save the entire thing inside of the entities folder. You could make another subfolder for enemies in there. I don't think it's really necessary. So next up, inside of the station, under entities, I want to add the drone, and then place things in such a way that we can see them right away. So I want to move the drone, let's say, up here, and the player can also go up there. So we can see things immediately. Let's try all of this. And there we go. We have a drone. Doesn't do anything at the moment, but that's totally fine. Next up, I want to add 2 area 2Ds. The first one is going to be the player detection area. And the other area is going to be the collision detection area. As soon as the player enters this area, the drone will become active and always move towards the player. Collision detection area is going to be a detection area, and once we're hitting that, the drone is going to explode. I wanted to make this just a little bit larger than the collision shape itself. There isn't really a specific reason for it, it just felt better. For the player detection area, I want to add a collision shape B with a circle shape, and then make this thing reasonably large. For the collision detection area, I'm going to do something fairly similar. So collision shape 2D along with a circle shape, and then something just a bit larger than the actual collision shape itself. With that, let's have a look at this station, and that feels just about right. I guess we can move the player a bit further to the side. Next up then, for the drone, I want to add a script, which means we need entities and drone.gd. That looks all right. And now we have a script for the drone, for which I want to create 3 variables first of all. The first one is variable active, which is going to be a Boolean value that's false by default. Next up, var speed, some kind of integer value of 100. Finally, I want to have access to the player right away, which we can access via onReady var player is going to be get underscore 3 and get first node in group player. I think all of this is reasonably straightforward. We are checking if the drone is active, so should it move towards the player, the speed it should be moving at, and then the player itself. Now this we can refine just a bit, because the speed should be set globally. And that we can do inside of global. For example, in there, you could create const enemy parameters, which will be a dictionary with a key for the drone. In there, we can have another dictionary with the speed, for example. And let's go with 110, just to have something slightly different. After we have that, for the drone, for the speed, instead of 100 for the speed, I want to get global dot enemy parameters, then the drone, and finally the speed. That's a slightly better system because now inside of global, we can store all of the enemy behavior parameters. You could even add the player parameters in here as well, although that would add a lot more. You simply have to find the right balance for your own game. And fundamentally, I want to call the process function and check if the drone is active, and if that is the case, I want to move towards the player, for which we are going to need a direction. The math for this one is fairly simple. we always need the end position and the start position and normalize that thing. Very simple vector math. Or in other words, we want to get player.position minus the position of the drone itself, so just position, and then normalized. That will give us a direction that we can use to update the velocity, because remember, the drone is simply a character body. So velocity will be direction times speed. And finally, we can move and slide, and then we should be good to go. The one thing that we have to do is to set active to true, because by default it's false. For that, we will need the player detection area. We can go to the signals and check for body entered and connect. Although for this part, I think we need to be a bit more careful, because the player detection area at the moment, inspector under collision, we can only see terrain. So this should be on the layer, I guess projectiles is fine. And for the mask, we only want to be able to see the player. And for the drone, for the collision shape, for the collision layer and mask system, I want the drone to be on layer 3 for the enemies. And the drone can see the terrain and it can see the player. I guess while we're here, for the collision detection area, this one should also be on projectiles, and for the detection, I want terrain, layer, and I guess other enemies, along with the projectiles. Our game is getting just a bit more complex, and the collision, mask, and layer system does reflect that. So let's test if things are working. I want to check if the player is entering, and if that's the case, print, let's say, player entering, or rather player detected. Let's try to run the game. And now if I move left, we should get player detected, and we do. This also works multiple times. Perfect. That's great, because all we want to do inside of this signal is set active to true. And if that is the case, the drone should be following us. And that is looking pretty good. Now, obviously, once the drone collides with us, we're getting some weird behavior, but that's okay. Because for that case, we want to trigger the collision detection area. Or in other words, on the node, we want to get if a body has entered, and then do a thing. For now, to get started, I simply want to Q3 the drone, so it should disappear. Let's try. And the drone has disappeared right away. So this collision area has collided with a body. To check what's going on, let's print the body that it has collided with. Let's run all of this again, and we are getting a collision with the drone itself. So this collision detection area is colliding with the drone. I guess one way around that in the collision mask is we could take out the enemies. Now we shouldn't see a print statement anymore, and we don't. Now with that system though, we do not get collisions with the enemies. So not ideal. Let's reactivate it. And then we only want to Q3 if the body is different from self. So we're not colliding with the own body. Let's try this one. And there we go. We have the drone again. And the drone can collide with the player. And it could also collide with other objects and still disappear. I guess what we can also try, that it can collide with the terrain and there it disappears. So once that happens, I want to have an explosion. Also, let's check the debugger, because that's always an annoying part. We are not using delta or the body in on-player detection area body entered. For that, we can simply add a couple of underscores, and that should fix everything. Yep, that looks good. Perfect. Next up, I want to create the actual explosion. And the way that system is going to work. Once the drone is colliding with anything, it's supposed to send a signal, and this signal we are capturing inside of the level. This in turn is then going to create another scene with an explosion, and that's basically just an animation. For that though, first of all, inside of the drone, I want to create a signal. Let's call it detonate, for which we are going to need a position, which should be a vector 2. And as soon as we are colliding with anything, we are destroying the drone, and we are emitting the detonate signal. Detonate.emit with the global position of the drone. And this we should do before we are running Q3, just to make sure that we are emitting detonate before we are destroying the scene. Next up, we have to capture this signal, which needs to happen inside the level scene, which at the moment doesn't work because we do not have a script. In fact, the station doesn't have a script either, so we can create an entirely new script for the level, which I want to store in the levels folder. That's fine. So create inside of the ready function. I want to loop through all of the children inside of entities, which means for entity in main.entities.get children. In there, I want to check if an entity has the signal detonate, which is only the case for drone. Remember, inside of entities, we have at the moment the player and the drone. And later on, we will have other entities in there as well. To check if a scene has a signal, all you need is the scene itself and then has signal. Super easy. The signal we are looking for is called detonate. Also make sure that you are adding if in there as well. If that is the case, I want to get the entity and connect a signal. The signal is detonate itself, and the function that we want to run is called create explosion. This one doesn't exist at the moment, so let me add a bit more space. And then function create explosion, which is going to need a position. For now though, just to make sure this is working, let's print explosion along with the position that we are getting. And this should be working already. So if I run the entire thing and the player collides with the drone disappears, we get explosion and a position. I just assume this is going to be the right one, but it seems broadly reasonable. That means next up, we can create another scene for the explosion. This is going to be super simple. I just want to have an animated sprite that I will rename to explosion. I want to save all of this as well, and I suppose under scenes, we can create a new folder that I have called projectiles. Not perfect for an explosion, but the bullets are going to be in there as well, and it broadly fits. Okay, save it in there, and now we have an explosion. Or well, we have an animated sprite called explosion. To get the actual explosion, we want to add some sprite frames, and then once again use the grid symbol, and under guns and projectiles, we have an explosion. In fact, we have a couple of explosions. The one I care about is bomb.png. And once again, we only have a single vertical frame, but we have a bunch of horizontal ones, 8 in total. Then in sequence, I want to go from left to right and select all of them and add the frames. Now we have a default animation. Let's have a look how this one looks. We need a higher frame rate, 20, maybe a bit too large, 15, I suppose still a bit high. Let's go with 10. And yeah, that fits nicer. And this should also autoplay. That's a really good start. So next up, inside of the level, I want to preload the explosion all the way at the top. Constant explosion underscore scene, which is going to be preload with the explosion.tscn. That gives us the scene we have just created. And when we are calling create explosion, we want to create one instance of that, which means var explosion will be the explosion scene dot instantiate. That is giving us a node that we now want to add to the scene tree of level. And I don't think we have a good place to put it. So under main, I want to add another node called projectiles. Once again, not the perfect name, but close enough. To this node, I want to add the explosion animation, which means projectiles in main.addChild with the explosion. Finally, we have to update the position of the explosion, which means explosion.position is getting the position from the parameter. With that, we have a pretty good start. If I now collide with the drone, we are getting an animation, but the animation keeps on looping, so not amazing. For that, inside of the explosion scene, first of all, make sure that this looping symbol is not activated. That way, I can try all of this one more time, and now we only get a single animation, but we keep on having some other stuff at the end. Not amazing. To fix this last part, I want to add a script to explosion. We can keep explosion as a name, that's fine, but I do not want ready or process in there. Instead, I simply want to check when the explosion animation has finished, for which inside of the nodes we have a signal, animation finished. This I want to connect to the explosion, and then we can do something once the animation is done. For now, we simply want to run Q3, which is generally a good idea because if you didn't destroy the scene after the explosion is done, we would keep on adding more stuff to the projectiles. These scenes wouldn't do anything and they wouldn't be visible, but they would still be there and take up some processing time. Eventually, this would cause a performance issue. So, something to keep in mind, but now let's try all of this, and the explosion disappears, and also under remote, station, main, and projectiles, there's no child. Perfect. Now, later on, for the explosion and for the drone, we are going to add just a bit more. But I think for now, this is totally fine. Also, to keep things just a bit cleaner, I want to close a bunch of scripts. Light.gd, we don't need player graphics, we don't need the saw, we don't need the transition gates, the layer, the tutorial data, or the capsule shape 2D. These are the only scripts that we will need for now. You can keep everything open if you have a bit more space. I suppose while we're at it, we can also for now close the drone scene and the explosion scene. And then finally move the drone to another place so we can work on the next enemy. Let's move the drone here, and next up, I want to create a soldier, which once again is going to be a new inherited scene. And the parent scene will be entities and entity. I can rename this one right away to soldier, and then save all of this under entities soldier.tscn. Now, the soldier animation is going to get quite a bit more complex. So, to avoid us having to do too much manual labor, inside of the tutorial data scene, we have one final entry, the soldier animation, which contains an animation player and a sprite 2D. So, let's make this part visible. We basically have a simple sprite 2D, which contains a whole bunch of frames for the soldier. 24 in total, and via an animation player, we are selecting different parts. For example, there's the death animation, we have a run animation, and things like a shoot down animation. Once again, nothing too complicated, but a bit tedious to implement. So copy the animation player and the sprite 2D and paste them into the soldier scene. Besides that, we will need a collision shape, which, just like for the player, is going to be a capsule, which fits roughly around the body of the soldier. Also, you want to make sure that the floor aligns. That looks good. Perfect. With that, we don't need tutorial data at all anymore, and I want to save the soldier as well. For this soldier, I want to add a script called soldier.gd and then create. To make all of this work, I want to create a few variables. First of all, var x_direction by default is going to be 1, and this needs to be an integer at all times. Next up, var speed is going to be a value we are going to get from global and enemy parameters. In there, I want to have a key value pair for soldier that contains the speed of the soldier. Although at the moment this doesn't exist, so Godot complains, but that we can fix quite easily. I want to copy this line for the drone and change it to soldier. For the soldier speed, I went with 50. After that, Godot should be happy again. Perfect. That means next up, I want to create a speed underscore modifier. By default, this one is going to be 1, and once again, it always needs to be an integer. Next up, I want to know if the soldier is attacking or not. So var attack, Boolean value, that is false by default. Finally, I want to get the player. So on ready var player is going to be get underscore tree and then get first node in group player. That covers a whole lot of setup. To use all of this, once again, I want to have the underscore process function and then update velocity.x. The soldiers are only going to move left and right. They don't actually have gravity. Because of that, we can use the x direction and multiply it with the speed. And I also want to use the speed modifier. By the way, for the speed modifier, later on, once the soldier is attacking, his values become 0. So the soldier stops moving. Although that part isn't too important for now. For now, I want to move the soldier, which I'm doing by calling move and slide. That should do something in the code. To test all of this, I want under entities add the soldier. And just to make sure we can see what's going on, I want to move the soldier next to the player. And then run the entire thing. And this soldier is moving. He can even push the player, so that's a decent start. Although not great yet. There are a few things that we have to add. Most importantly, something that I always forget, under collisions, we have to update the collision layer and the collision mask. The soldier should be on layer 3 for the enemies. And the soldier can see the terrain, the player, and the projectiles on layer 5. Next up, we have to cover two major things. Number one, we want to check for cliffs and walls. If the soldier hits either of them, X direction should be reversed. So we're going back and forth. Besides that, I want to animate things. I suppose for now, we can check for cliffs and walls. And for that, I want to add a few more things. So the way you want to think about all of this, the soldier can move left and right, and we might have a cliff, or we might have a wall somewhere on the side. How do we check for both of those? And the way I approach this is, number one, for the cliff, we are going to have two raycasts that go down right and down left. As soon as they are colliding with some kind of floor, we are good to go. But as soon as there's no collision anymore, then the soldier is going to turn around. Besides that, for the wall, I want to set a collision shape around the soldier, and as soon as this thing collides with any kind of object, then the soldier, once again, is going to turn around. For all of this, let's start with an area 2D that I have called wall check area, for which we are going to need a collision shape. In my case, I went with a rectangular shape that covers the entire height of the soldier and a bit more than the width of the original collision shape. For this wall check area, in terms of collisions, we do not want to be on any layer, but we want to be able to see the terrain. And if this thing collides with anything, so we have body entered, then we want to do something. And that something is going to be x direction multiply equal -1. That part we can test right away inside of station. I want to move the soldier, let's say, down here. And the player as well, just to make sure we can see what's going on. If I now try all of this, we get the soldier moving back and forth. That looks pretty good. The bin here doesn't look ideal, but I think it's good enough. Next up for the soldier, I want to check for a cliff. And for that, I'm going to add a node 2D and rename it to floor race. Because inside of this node, we are going to do some raycasting. 2 times actually. So raycasting is just an arrow that checks for collisions. I want to have one facing to the bottom right and another facing the bottom left. The first one should have a target position of 20 and 20 and target the terrain. That's all we need. In terms of naming, this should be the right floor raycast. Then I can duplicate all of this and rename it to the left side. The only change we have to make is that x should be -20. And there we go. Now we are checking for 2 points to the bottom right and the bottom left of this soldier. Now for a raycast, we don't really use signals for some reason. Instead, what you would rather do is I want to do this in another function, check underscore live, without any parameters, to check if a raycast is colliding with anything. All you need is the raycast itself. So let's go with floor raise right and then get collider. This will return the object we are colliding with. And if nothing is being returned, then we don't have a collision. Also, this should be check cliff for proper spelling. I want to check if x underscore direction is greater than 0 and not floor raise right get collider, which means the soldier is moving to the right and we have no collision on the floor to the right. If that is the case, x direction should be -1. The same thing we want to do for the other side. I can duplicate all of this and check if x direction is below 0 and we have floor raise left. Get collider. If that is the case, x direction should be 1. Once we have that, we can call check if, and then we should be good to go. Although to test all of this, I want to move this soldier back up here along with the player. And then the soldier should turn around. And he does. Perfect. Next up then, I want to add the animation logic. Because right now all of this looks a bit weird. I want to create a function animate. And at least for now, I only want to do 2 things. Number 1, I want to get the sprite 2D and then flip H if we are going to the left, because by default, the sprite is going to the right. That makes this part really easy. I simply want to check if x direction is below 0. Also, I want to call animate, and then we can place the soldier on this little platform and make a move left and right. This is working really good. Perfect. Next up, I want to get the animation player and set the current animation to run. So if you look at the soldier, there we have animation player and we have a run animation in there. I suppose we also have an idle animation that we could include in here as well. I want to check run, but only if we have an x direction. If that is not the case, else the animation should be idle. Next attempt, and now this should be animated, which looks a lot better. That is some pretty decent progress. Next up, I want the soldier to look out for the player. So if the player gets close enough, the soldier should start shooting, which at the moment simply means that inside of the animation player, we want to play the right shooting animation. Or in other words, if the player is to the right of the soldier, it should be shoot right. If the player is above the soldier, it should be shoot up, and so on. For that, inside of soldier.gd, I first of all want to add a function called check player distance. This function is going to check if the player is close enough, which I want to define as closer than 120 pixels. If that is the case, attack should be true and the soldier should stop. And for now, let's add pass in here so Godot stops complaining. Besides that, once the soldier is attacking, I also want to update the animations. Which means after we are flipping the sprite, I want to have an attack animation logic. These 2 parts are going to be your exercise. All you have to do is, number 1, check if the soldier is close to the player. And if that is the case, make the soldier play the correct attack animation. Pause the video now and see how far you get. First of all, I want to check the player distance. For that, I want to check if position.distance to. The argument in there is going to be player.position. If the resulting value is below 120, then I want to set a tag to true. And to make sure that the soldier is stopping, I want to set the speed modifier to 0. If that is not the case, else we basically want to do the inverse. So a tag is going to be false and the speed modifier will be 1. Don't forget to call this one. Let's do it right before animate. I want to check the player distance. And then place the soldier roughly here, I guess. And right now I think the player is close enough. So there we go. The soldier has stopped. And if I go far enough away, the soldier does move again. But come back and eventually stops. Cool. So that's looking good. That covers the check player distance. Next up, I want to expand the animate logic. If the soldier is attacking, then I want to do something else. Now to get started, I want to know what side the player is on relative to the soldier. Let's say by default, the player is to the right. That we can already use because I want to get, once again, the animation player and set the current animation. This value should be shoot, then underscore, and plus the side, which at the moment is only ever going to be right. After we have that, we want to make sure that the function ends there. We do not want to call the last line because that would set the animation back to run or idle. To get that, I simply want to call return and ideally also spell it correctly. There we go. With that, we should already have something. So now the soldier is shooting at the player. This, though, only works in one direction, so not amazing yet. For that, I need to know the positional difference between the soldier and the player, which I stored in another variable, var difference. Once again, we simply want to get the end position, so player dot position, and from that we're going to subtract the current position, or well, the start position, which is the soldier position itself. All of that we want to normalize, and then we have a difference. So with that, in a vector, we know if the player is to the left or to the right of the soldier, or above or below. This we can already use. For example, sprite2d.flip_h is going to be the difference.x being smaller than 0. That should already cover left and right. So now the soldier is attacking us, and this works left and right. Next up, I want to check if difference.y is smaller than negative 0.5. And the absolute value of difference.x is smaller than 0.4. If that is the case, the side is going to be up. Let's try all of this and then I will explain. So the soldier can shoot to the right, he can shoot up, and he can shoot left. And also, by the way, we can jump on the soldier, which I think is pretty funny. We have the soldier, and then we have the player. And let's say right now the player is above the soldier. That means difference.y is going to be smaller than 0.5. Or in other words, if the difference vector pointing to the player needs to be pointing up, and to get to negative 0.5, we need to be roughly in this cone. The second part, absolute difference of x is smaller than 0.4, is simply covering basically this side and this side. In fact, we can duplicate all of this and simply check if difference.y is greater than 0.5 and the absolute difference of x being smaller than 0.4 can stay the same. If that is the case, the side should be down. And to test all of this, let's move the soldier up by a bit. Since there's no gravity, that's not really a problem. And now the soldier is shooting down. So that part is working pretty good. Now I've moved the soldier up just a bit too high, so we can't still check up, but I think this is going to work. Although, let's move the soldier back down here, then everything looks a lot more normal. This covers all of the basics of the soldier. That means now we can start working on the basic bullet shooting mechanic. Or rather, I want to create a function called trigger underscore attack, for which we basically want to emit a shoot signal. So shoot.emit with a position, a direction, and then the gun that we want to use, which we can already do actually. For that, we have global.guns and then AK. Position and direction, though, don't exist right now. But that we can work on. First of all, to get the position and the way you want to think about that. Imagine that this is once again the soldier and the player is somewhere up here. Because of that, we know the soldier wants to shoot in this direction. So that would be our direction. On top of that, when we are emitting shoot, the position is going to be used for the starting position of the bullet, which should be roughly here. The position for this one is going to be the center of the soldier plus some kind of distance multiplied by the direction. Or in other words, we want to get the current position of the soldier and then add the direction multiplied by 20. On top of that, I want to get a variable direction, which is once again going to be the target position, i.e. the player.position, minus the current position, and all of this we want to normalize. That way Godot is mostly going to stop complaining. The issue now is that shoot.emit does not exist. And you could create this signal inside of the soldier. So all you would have to do in there is signal shoot, which would be possible, but also not ideal, because I want to have this signal inside of the soldier and inside of the player. And later on, these two classes should also share a few more things. So ideally, I want to create a signal inside of the entity, which at the moment doesn't have a script. And as a reminder, entity is the parent class for soldier and player. It's been a while since I talked about that. So I want to give entity a script, which is then going to contain the signal shoot with a position, a direction, and let's call it bullet type. However, we now have another issue, and that is that entity has a script, but also inside of soldier and the player, we have a script as well. And this script is going to overwrite the script inside of the entity, meaning this wouldn't really do anything. To get around that, I want to add a class name and rename this entire thing to entity. What this allows us to do is inside of the soldier and the player, or to be a bit more specific, in their respective scripts. Instead of extending a character body 2D, I want to extend the entity. And then we're getting an error right away that member shoot already exists in the parent class, which is exactly what I want. We can now remove this, and we can use this signal from the parent class. The same thing I want to do inside of the player script. I want to extend entity. Via that system, we can add quite a few things to the entity script and reuse them inside of the child scripts, which is super handy to create some inheritance systems. With that in place, we can once again work inside of level.gd. There, we are already connecting the detonate signal. Besides that, and let's do it before, I kind of want to do something very similar. So let me copy those two lines. I want to check if an entity has a signal shoot, and if that is the case, I want to connect the shoot signal to create underscore bullet, which is a function that doesn't exist at the moment. And once again, I want to create it before create explosion, although the order doesn't really matter. Func create underscore explosion, for which we will need a position, a direction, and a bullet underscore type. For now, let's simply print all three of them. I want to have a position, I want to have a direction, and I want to get the bullet type, just to make sure things are working. Oh, and this should be create bullet. Let's try all of this. So now the soldier can shoot, but nothing is happening. And that is because inside of the soldier, this trigger attack is never called, which we have to do inside of the animation player. Because if I zoom in just a bit, we want to create a bullet when we are on this animation frame. Which means in my case, after 0.1 seconds, I want to add a call method track to the parent character body 2D scene. Then I want to add a key on this time and call trigger attack. The same thing I want to do for the other sides as well. So shoot right should also get a call method track that connects to the soldier. Then we can add a key that is calling trigger attack. And finally shoot shoot down. Same thing, call method track and the soldier. Then we want to have insert key with trigger attack. If we now try all of this again, we're getting trigger attack and the information. So with that, we know where the bullet should spawn, which direction the bullet should go in, and what kind of bullet we have. That looks really good. So this system we also want to apply to the player. Although, first of all, inside of the debugger, we're getting two issues that delta and body are not used, which we can fix quite easily by adding underscores, and then Godot should be happy again. There we go. Everything still works just fine, so we can continue to the player. For which, we once again want to look at get input. We haven't covered this in a while, but in there, we're getting all of the player input. The one thing we now have to add is, let's call it shoot. All we need is to check if input is action just pressed. The action we are looking for is called shoot. If that is the case, we do want to do quite a few things. So I'm going to add a function shoot gun and then keep all of the logic in there. All the way at the bottom, function shoot underscore gun. Now, fundamentally, all that we want to do in here is get the shoot signal and emit it with a position, a direction, and then the current gun. This we already have from this switch part. Also, I can minimize the input function so we have a bit more space. For every single bullet, we have to figure out a position and a direction. On top of that, if you look at the timers, we have a coyote timer, a jump buffer, and a dash cooldown. On top of that, I want to add 3 more timers. One for the AK, one for the shotgun, and one for the rocket launcher. They should all have different reload times, and this we also want to account for inside of this function. I suppose let's go through it one by one. First of all, I will need another timer. Let's call it AK reload. I can duplicate this because this one is going to be called shotgun reload. And finally, I want to have rocket reload. For all 3 of those, I want to set one shot to true. That part is really important. And then we have to set a wait time. And I think this one is best handled inside of the export group for the gun. I want to create an export range variable that goes from 0.2 to 2.0. This one I'm going to call AK underscore cooldown with a default value of the float 0.5. I can duplicate this 2 times because besides AK, we have the shotgun and the rocket cooldown. For the shotgun, I went with 1.2, for the rocket 1.5. If I now comment out the issues we have down here and add pass in there, I can save the entire thing. And then under gun, we're getting AK cooldown, shotgun cooldown, and rocket cooldown. Although these values at the moment don't do anything. For that, inside of ready, we need to add a few more things. The way you want to approach this, you want to get the AK reload and then update the wait time to the AK cooldown. After that, I want to do the same thing for the shotgun, so wait time and shotgun cooldown. Finally, rocket reload dot wait time is going to be rocket cooldown. With that, we have a couple of timers that we can control from the parent node, and that we want to use inside of this shootgun function. And once again, I want to get a position and a direction that can only trigger when the timer is not active anymore. Although, first of all, I want to get the position in general, which is always going to stay the same. I want to get the current position of the player. And to that, I want to add the aim direction multiplied with the crosshair distance. That's the same thing we have done for the soldier. So we start from the center of the player, and then we go a bit outwards in the direction that the player is shooting in. Although we do need an offset if the player is ducking. So I want to update position. It should be position itself if the player is not ducking. If that is not the case, else it should be position plus vector 2 with x being 0 and y being the y of z. With that, I can get this signal back. We have a position, and the direction is simply going to be the aim direction. To test all of this for now, back in the game under station, I want to move the player a bit further away from the soldier, so we're not getting interfered. Let's put the player down here. And I guess just to be sure, the soldier could be all the way over there. If I now run all of this, and shooting is left-clicking on the mouse, we are getting different directions and positions, and if I switch the gun, we are also getting a different gun. That's 0, 1, or 2, the last value we are getting. Perfect. That means, in the most basic sense, this part is working. That being said, though, we do have to extend it because we have to include the timers. If the current gun is equal to global.guns.ak and not, now I want to get the timers. Let me simply drag them in. Inside of the player, we have the AK reload timer. I only want to emit the signal if there is no time left for this timer. If that's the case, I want to emit the signal and then get the timer once again. Let me copy it and then start it. With that system, I can run the game again, and now I can click really fast on the mouse, but we are only getting the shoot signal, I think, twice a second. Yep, the cooldown is 0.5 seconds. Next up, I can copy the if statement because I want to check if the current gun is rocket. And for that, I will need to check the rocket reload. Inside of that if statement, I want to emit the same signal, but now I want to start the rocket reload timer. After that, I can copy all of this one more time. Now we want to check for the shotgun, which has its own reload timer, shotgun reload. We want to emit the same signal, but restart the shotgun timer. Now for the shotgun, there are going to be 2 extra bits. Number 1 is going to be a whole bunch of particles. I suppose we can do that part right away. Besides that, there should be a shotgun jump. If the player is in the air and shoots down with the shotgun, then we should get a small extra jump. Let's start with the particles. For that, I want to give the player a GPU particles 2D node, on which we first of all have to add a process material, which needs to be a new particle process material. And let me actually work in the 2D space, then we can see things a bit better. So now we can see that we have a particle process material, and this one emits a couple of particles. Doesn't look good at the moment. To make all of this look better, first of all, I want to add a sprite animation, and I already have it open. Under Graphics, Guns, Projectiles, we have explosion2.png. This is a very simple explosion animation, which I don't want to have as a sprite. I do want to have it though inside of the texture, which is going to look a bit weird. So at the moment, Godot is simply displaying the entire texture, which I do not want. I want to animate over this thing. And for that, we have to go to Material and then create a canvas item material, which doesn't do anything at the moment. But in there, we can set particles animation and then define H frames and V frames. In this thing, you can tell we have 1, 2, 3, 4, 5, 6, 7 H frames. So 7, and this is looking much better. Although not perfect yet. To actually get the animation, you want to look at display and animation and then set a minimum speed and a maximum speed, or a curve. If I set a minimum speed and make this a bit larger, then we are getting something. So this might be a bit large. So there we get something much more appropriate. Although, once again, this needs to be refined. First of all, under accelerations, we have gravity, and I want to set the gravity to 0. Instead, I want to go to spawn, and then set the spawn velocity. Or more specifically, I want to set the initial velocity, which I have set to 200 for the minimum value, and for the maximum value, I went with 280. Which already looks a lot better. Oh, and also, you want to set the spread to 45, which I think gives you a nice range for the particles. And that is mostly actually what we need for this particle system. Next up, inside of time. I want to activate one shot. That way, we are emitting all of the particles at once. Now, for the lifetime of the particle, I want to go with 0.3, and for the explosiveness, I have set this to 0.5. That way, if I run all of this again, we are getting something. We can refine this in just a bit, but for now, we have something that looks at the very least somewhat okay. With that, inside of the player script, as soon as the player is shooting the shotgun, I want to display these particles. And they also have to go in the right direction. I want to get the GPU particles 2D and then set the position. The starting position should be the crosshair dot position. Next up, I have to set the direction. So inside of GPU particles, if you look at the velocity, we can set a direction. This value we can access via the GPU particles. Let me copy it. Dot process material, and then set the direction to the aim direction. Finally, the last thing that we need is the GPU particles, and then emitting should be true. With that, I can run the game, switch to the shotgun, and shoot, and we are getting something that's not looking too terrible. So I think we can only shoot after 1.5 seconds, but this overall looks alright. I'm quite happy with that. As always, you can refine these things a lot, but for a tutorial, I think this is good enough. So besides that, I want to work on a shotgun jump, which basically means if we are shooting with the shotgun and the aim direction is down, or in other words, if aim direction.y is equal to 1. You can also add and velocity.y is greater or equal to 0. That way, we're not going up, which sometimes can look a bit weird, but I'm not sure if this is really necessary. It very much depends on what kind of field you want to have in the game. If that is the case, I want to set a variable called gunJump to true. This gunJump doesn't exist, so Godot is going to complain. Under the jump export group, I want to create var gun_jump, which is going to be a Boolean value that's false by default. I suppose we can move this right under jump. Once we have that, we can look at apply movement, and then right after jump, I want to have the gun jump, for which we want to check if gun jump, and then set the velocity.y to negative gun underscore jump underscore strength. I think I called this one for the jump strength. We have that. I want to copy this because now we also want to have a gun jump strength, which should be a bit weaker. Let's go with 180. This one looked alright while I was testing things. Besides that, we also have to set gun jump to false, and I want to set faster fall to false as well. Let's try all of that now, and with the shotgun selected, I can shoot down and jump up. If I fall, we can do the same thing. And via that system, I can jump and then get a bit of an extra jump. If I try this with any other gun, nothing is going to happen. Also with the shotgun, if I shoot in another direction, we do not get an extra jump. So, cool. This part is also working. That means we can minimize apply movement, and we have covered shoot gun. Although this bit of white space was annoying. Cool, that covers the player. That means next up, we can work on the monster, the final enemy, for which I want to create another new inherited scene with the parent being entity. Let's rename this right away to monster, and I want to save it under entities. There we go. Now we have a monster. After that, I want to add a sprite 2D, and then under graphics and entities, we have attack.png, which I want to drag into the texture, and there you can see we have the monster. Obviously, this is an animation, so I want to add animation h frames to 5. Also, while we are here, we should set a collision shape, which I have set to a rectangle shape, and expand all of this just a bit, make it a bit wider, and then I can drag the sprite 2D roughly in this area. I think that looks alright. Not perfect, but good enough for our purposes. Before I forget, inside of the monster, under collisions, this monster should be on the enemy layer, and it can see not the terrain. It should actually only see projectiles, so layer 5. Later on, I want this thing to always be on the right side of the window. It shouldn't collide with any terrain. You'll see in a second what I mean. Now, besides that, for the animations, I want to add an animation layer, which is going to get 3 animations. So a new animation that I have called idle. That's the simplest one. I simply want to add a track for the property and then the sprite 2D, specifically the frame. And the key for this one is going to be 0. And that's it. That's all we need for idle. Then I want to duplicate this animation to get a tag. Let's zoom in just a bit, and I want to go through the attack animation. For that, I can have the sprite 2D selected. I want to go from 0 to 1, then at 2, I want to get the second key, then number 3, and 4, and 5. With that, we are getting a very basic animation. On top of that, I want to go back to the idle state, which means I can add another key with the value 3. And then on second 0.7, add a final key with the frame 0. That way, I can play this thing in loop, and we are getting an attack animation that looks pretty alright. So if you're following along, the frames for all of this are going to be 0, 1, 2, 3, and 4. After which we have a short break, and then we go to 3 and 0. Later on, we are also going to have a death animation, but that's not too important for now. Next up, I want to add 2 timers. So add a timer node. I want to have an attack timer, and I want to have a move timer. Both of these timers should be one-shot and auto-start, That's pretty important. And to use them, we have to give the monster a script. And you might be confused at this point because, well, we already have a script. That's the one we're getting from entities, and that's not the one that we want to use. So on this monster, I'm going to remove the script currently attached and then add a new one. We can call this one monster, that's totally fine. And importantly, we want to inherit from entity, like we have done before for the player and the soldier. Once we have that, we can connect the attack timer and the move timer via very simple signals. That's a good setup, and I suppose before we continue, let's test all of this. For that, I don't need the station, the soldier, or the player, and instead, I want to open the sky scene. The monster should only be inside of this scene, and it should live inside of entities. So in there, I want to add the monster, and then place it in a position where we can see it right away. I guess we can do it here, and then move the player up there as well. If I now run only this scene, we can see the monster, and that looks alright. We also get collisions, so cool, good start. Next up, we have to add some movement. And the system I want to have, if this is the window, we always have the player roughly in the center. The monster should be on the right side of the window, meaning the right border of the monster is never visible, which I guess generally is a good idea because if you look at it, the right side simply doesn't have anything. To get all of that, first of all, we will need on ready var player with get underscore tree and get first node in group player. This we can already use to set the Y position of the monster, which I want to do inside of func underscore process. All I want to do in here is position.y is player.position.y. If I now run the sky scene, the monster is always in the same Y position. So that is working pretty well. And later on, I want to have something like this, where the monster is always on the right side, and then it's going to attack us. And also move along the x-axis. Now for that, we have a bit of a problem, because ultimately I want to set the x position of the monster, or rather position.x, to something like player.position.x, and then plus, let's say, 50 pixels. If I now run this sky scene, we're getting the monster that is to the right of the player. That is a reasonable start, but I want the monster to be on the right border. And for that, I have to figure out the camera size. Or in other words, if you look at the scene, I want to get this camera bounding box. From that, I can tell how far away the monster needs to be from the player. And to get that back inside of the script, I want to get on ready var player camera, which we are going to get via player.get_cam, which does not exist at the moment. For that, inside of the player, I want to create a function get_camera. No need for parameters. All we want to do in here is to return the camera 2D node. I suppose alternatively, inside of the monster, you could have also simply gotten the camera in here more directly. But a system like this allows you inside of the player to add some extra logic if you have to. So if you have a fancy camera setup, this might be better. Next up, I want to get the camera size, which has to happen on ready as well. var cam_size, and then we want to get the player camera along with get viewport rectangle. This is going to give us a position and a rectangle of the camera, on which we only care about the size, and on this we only care about the horizontal dimension. On top of that, this value we want to divide by the player camera once again, Because the player has a zoom level. In our case, zoom.x. So the way you want to think about all of this. If you have a camera, for that let's open the layer inside of a camera 2D. You are getting some kind of a rectangle that has a position, but this position is affected by the zoom level. So if you want to have the accurate size of a camera rectangle, you need to do something like this, where you get the size and divide it by the zoom level. Once you have that, we can add the cam size divided by 2 to the player X position. And now I can run the sky scene, and we're getting the monster on the right side of the window. Although we might want to subtract a very small amount from that. For example, to this value, you could add -20, and then if you try all of this again, this looks a bit better. Let's go with -10. And yeah, this looks alright. Cool, so with that, we have a very crude position, but this isn't ideal yet, because, well, the monster is always in the static position, which gets to look a bit weird quite fast. This we have to update quite a bit. And first of all, inside of process, I want to refine things just a bit. First of all, I want to keep the X position in a separate variable. So we can simply get all of this. Position.x we can get rid of for now. First of all, I want to limit the X position via a max function where we are getting limits.x and then a minimum function with limits.y and the actual X position. So this is going to look a bit weird. Most importantly, because we don't have limits yet. That we can create all the way at the top, export var limits, which is going to be a vector to integer. The way I want to use this one, inside of the monster scene. The way I want to use it is for a minimum and a maximum position. So X and Y doesn't really apply here. But when you are looking at this line, we are picking the larger of two values. And if this value is 0, then we can never go below that value. Same with minimum. If our limits y is 100, then we can never go beyond that value overall. Combining these two allows us to clamp something within a certain range. And then to use it inside of the sky scene, you basically want to look via the ruler how far the monster can go. Let's say the monster can only go up to this point. I suppose 50 pixels works. With that, for the monster, we can set the X position to 50 and the maximum position for now to 200. That's the basic idea. Although for that to work inside of the monster, we have to actually use this X position. I want to create another variable, first of all, for Y, and then at the end, set the position to vector to X and Y. If I now run all of this, the monster is not moving at all, which I think is because of this line. Most likely because the limits are too narrow. Let's set the maximum one to 1000. And then at the very least, we should be going in one direction. That looks much better. So now at some point, the monster is going to stop right at the end. And if I go to the left, it should also stop and here somewhere, although we might need a larger value. Let's try 200. Next attempt. I can now go to the left, and at some point, the monster disappears. So that part is also working. That way, once the player enters the scene, he can't see this monster immediately. And I suppose the maximum value should be just a bit larger, 1100. Next up, the monster at the moment is always in the same Y position as the player, which isn't ideal. To make this a bit more interactive, I want to add 3 more variables. Var y underscore range which is going to be a vector 2 with some kind of range. Let's go with -50 and 50. Besides that, I want to have var y underscore offset, which needs to be some kind of floating point value. And finally, I want to have var direction. Actually, this one we don't need. You're going to see in a second why. We only need y range and y offset. Essentially, when we are setting the y position of the monster, I want to be on the same position for y as the player, but then potentially add a y offset, which we are getting whenever on move timer timeout times out. In there, I want to create a queen. And let me hide everything else so we have a bit more space. So as always, I want to create a tween and then tween a proper key. The object we want to work on is self, and the property path will be y underscore offset. After that, we want to get a random value from inside of the range, which means we will need a random number generator that we don't have at the moment. For that, at the top, and let me comment out this line so Godot stops complaining, I want to have a var random number generator, which we can create via a random number generator.new. That's all we need. Now I can uncomment this line and use rng.randf_range, for which I will need a minimum value and a maximum value. The minimum value will be yRange.x, and the maximum value will be yRange.y. Finally, we will need a time or duration. Let's go with 0.6. This should already do something. If I now run the game, we're getting some movement after 1 second, and that's about it. To run all of this again, I want to get a tween and a tween call back, for which we simply want to get the move timer and start the entire thing. Make sure not to call it. If I now run all of this again, we're getting a movement, and this movement keeps on running. So now we have a monster that updates its Y position. Although we always stick somewhat close to the player. That is because we are only adding a fairly small offset that always adds a value to the player Y position. That way the monster can never get too far away from the player. That covers the movement. Next up, I want to work on the attack timer timeout. If this timer triggers, I want to get the animation player and set the current animation to attack. Let's try this one, and we are getting the attack animation. I want to get the attack timer once again and set a random wait time to make the attacks feel a bit more organic. For that, RNG, once again, randf range with a value of 0.5 for the minimum and 2.0 for the maximum. Also, this should be randf range. Finally, once we're done with all of this, I want to get the attack timer once again and start it all over again. So with that, we should have more organic attacks, although I think something is missing. If you look at the monster, this doesn't look right. We always have the same attack interval. That is because if we look at the monster animation player, we only ever have the attack animation, and this one is looping. And since we simply go to this one, it never stops, and well, we get the same outcome. So what we want to do after this animation is done, we want to go back to the idle state. For that, I want to create another function. Let's do it below the move timer signals. Func return to idle. All we want to do in there is get the current animation and set it to idle. Then save the scene, and inside of the attack animation, add another track or call method, go to monster, and then at the end of this animation, we'll return to idle. And now select the sky scene and run the entire thing. We should get only attacks in certain intervals. And that feels much more organic. So now we don't attack constantly anymore. That means we can minimize return to idle, and we also covered the attack timer timeout. Next up then, we have to add the logic to actually shoot bullets. The basic idea for the monster, if I go back to the scene, is that we are going to define a couple of points in front of the monster, and as soon as the monster is attacking, we are shooting bullets from these points. For that, first of all, inside of the monster, I want to add another node, which can be a node 2D that I have called bullet options. In there, I am going to add a couple of children. The first one is another node 2D called 0, in which we are going to add a marker 2D node, which I want to move to another position. Let's move it right in front of the monster, maybe a bit closer. So in a bit, we are going to add a few more children and then select them at random. If we are selecting this first one, we are looking at this marker and shoot a bullet from this point. Besides that, I can duplicate all of this and then move the marker, let's say here, duplicate it and move it down there. Or in other words, if we select this child, we are shooting a bullet from these two markers. I guess we can add a third one just to make it look a bit prettier. So we have one in the middle as well. Finally, we can duplicate all of this one more time, because now I want to have, and let me hide the other children, I want to have a marker up there. I want to have a marker down here. The next marker should be roughly here, which I want to duplicate, and then have another one down here. I hope all of that still makes sense. We basically have a couple of children that contain a bunch of markers, and those will be our bullet starting positions. Back in the script, I want to create, I suppose we can do it above return to idle, func trigger underscore attack. For which, first of all, we want to pick one of the bullet option starting positions, which I have called option underscore index. All we need in here is the random number generator and then rand I range. We want to create integers within a certain range. The starting point is always going to be 0, and the final value will be the bullet options dot get child count -1. Let me add a bit more space, and with that, we're getting a random number to pick one of the starting positions. Via that, we can get the selected, let's simply call it selected. For that, I want to get the bullet options and then get child with the option index. After that, I simply want to get for marker in selected.getChildren. And finally, I can call shoot.emit with the position, direction, and the gun type. The position is super easy. We simply want to have marker.global position. For the direction, the bullets should always go vector2.left. Finally, for the gun type, I want to get globals.guns.ak. And I believe I called this global. There we go. So with that, we are emitting a signal for every single position when we are calling trigger attack. Although for that, we have to figure out when to call trigger attack, which once again happens inside of the attack animation. We already have a call method track, and I want to call trigger attack when we get to this point. So in there, add another key with trigger attack, which doesn't exist because I didn't save the script. Save it, and then it should show up inside of the animation player. So void trigger attack, and there we go. With that, if I now run the sky scene. The monster can attack, and we're getting a bunch of positions. That looks really good. So with that, we have trigger attack, and that means we have a whole bunch of entities that can shoot bullets. So next up, we can work on the actual bullets. So at this point, we have all of the entities, and every single one of them has a signal to shoot a bullet. We can actually create a bullet class that takes care of all of the logic. And for that, back in Godot, I want to create a new scene, for which I want to use an area 2D, which is going to need a sprite and a collision shape, at least for now. And so that we have something, I want to go to guns and projectiles. There we have default.png, which I want to drag into the sprite D, and then we can see a very small bullet. While we are here, we can also add the shape. I think a capsule shape would work best. Something like this, and under transform, we have to rotate the shape by 90 degrees to something like this. Also, before we continue, I have realized that the debugger is unhappy with us because of delta not being used, so there should be an underscore. Also, I want to rename area 2D bullet, and then we can save all of this under projectiles and bullet. And now if I run the entire thing, everything is working all right. Perfect. So now we have a bullet, and this bullet is going to need a script. We can keep the default name, that's totally fine. And in here, fundamentally, we simply want to move the bullet in the direction. But I think we should go step by step. First of all, when any of the entities is shooting a bullet, we are emitting the shoot signal that we are capturing inside of the level. Which means when we are creating a bullet, I want to actually create a bullet. And for that, first of all, like we have done for the explosion, I want to create a const bullet scene, which needs to be a scene. So we want to preload the bullet.tscn. Once we have that, when we are running create bullet, I want to create a bullet from the bullet scene via instantiate. After we have that, I want to get the projectiles and add a child, like we have done for the explosion. Let me copy it and instead add the bullet. That should already work. If I now run the game, I can shoot and nothing happens. Although, I think if you look at remote, under station and main projectiles, we have a whole bunch of bullets. The issue is, inside of the game, we are not updating the position of the bullet, so they are always in the top left. To fix that, I simply want to get the bullet and update the position to the position that we are getting from the parameters. If I now try all of this, I can shoot and we are getting a bullet. Looking good. Also, if I go and find the soldier, he can also shoot a bullet, although there we have a bit of an issue, that the soldier turns around once he collides with a bullet. So not amazing. That we can fix right away, because at the moment the bullets are inside of terrain. They should instead be on projectiles and can see the terrain, the player, and the enemies. Also, when we are creating a bullet, I want to pass in the position, direction, and gun type that we are getting from the level. Or in other words, these three arguments need to get into the bullet. And the best way of doing that, I find, was by running a setup method with position, direction, and the bullet type. For that to work, inside of the bullet, we will need func setup with position, direction, and the bullet type. First of all, in there, we want to update the position of this node and set it to the position. Next up, for the direction. Inside of this class, var direction, I want to have a vector2. And the direction we are getting from setup is going to overwrite that value. Or in other words, direction is going to be here. The bullet type we don't need for now, so let me add an underscore. And after that, I want to have func underscore process, in which we are going to move the area to D via updating the position. And all we have to do is plus equal direction times some kind of speed, which doesn't exist at the moment. So let's go with 100 instead. We'll fix that part in just a second. If I now run all of this, I can shoot and we're getting an error. That setup doesn't exist inside of the position, and that's easy to fix. This should be bullet.setup, not bullet.position.setup. Next attempt, and now the bullets are moving, but they're moving way too fast. That is because inside of the bullet, we are not adding delta. So next attempt, and now the bullets work, but they're also working very, very slowly. And you can also tell that if we are shooting diagonally, they're moving much faster. That is because the direction was not normalized. Very easy to fix. We, when we are getting the direction, want to get the normalized direction. So that should give us a constant speed, and it does. Perfect. Besides that, I want to change up the images depending on what gun we have. So if we have an AK or the default, then we want to have default.png, the one we already have. But if we're shooting a rocket, I want to have large.png. And if we're using a shotgun, there shouldn't be any visible bullet because we already have the particle effect. I want to check if the type of the gun, the one we have added an underscore to just a second ago, if that one is in global.guns.ak or global.guns, let me copy it, .rocket. If that is the case, I want to update the sprite 2d.texture and assign it a new texture. Now for that, inside of global, I want to set a general gun data dictionary, so we don't have to set everything manually. This gun data dictionary you can find inside of tutorial data. In there, we have gun data, and this is what I want to use. If you simply uncomment it, you are going to get an error because we do not have guns inside of this script. But if you copy it into global, then it should be working, because now we have the enum guns. And all we are doing in here is for each of the guns, for example for AK, we have damage, speed, and a texture that we are preloading. Which means I can save the script and go back to bullet. In there, I want to get global, gun, data, the current type of the gun, and then get the texture. Besides that, I can also create a speed and a damage for this bullet. Although for that, first of all, I want to create two more variables, speed and var damage. Speed needs to be some kind of integer, and the same for damage. After that, for the speed, I want to have global gun data type and speed, while for the damage, I want to do the same thing except for the damage. If you look at global.gd, there we always have damage and speed, except for the shotgun. That means if I now run all of this, if I shoot the AK, we have a small bullet. If I shoot the rocket, we have a larger bullet. Although the speed we are not using yet, because inside of process we always have 100. This should be speed. Next attempt, and now this feels much better. Also, if I use the rocket, this thing moves slower. Very good. Also, what I want to do in here. If we are shooting a rocket, the bullet needs to be explosive, which I want to store inside of another variable, which is going to get a Boolean value that by default is false. And then we want to set explosive to the gun type being equal to global.guns.rocket. If we have a rocket, this value will be true. If we have an AK, it will be false. And just to make sure we are implementing all of this, I want to check if this bullet is colliding with any. So with the area to deselected, I want to check if we have body entered. If that is the case, I want to get detonate and emit the signal, along with a position. Now this detonate signal doesn't exist. So at the top, I want to have a signal called detonate with a position that needs to be a vector too. The same thing that we have done inside of the drone. In fact, you could create a parent class for the drone and the bullet, because those two share quite a few things. But that might be a bit of an overkill for such a simple game. But for a more complex one, it would make sense. Anyway, now inside of the bullet, we have detonate, which we want to emit along with a position, which should be the current position of the node. And after we have done that, I want to run Q3. The only thing we now have to do is inside of the level. When we are creating a bullet, we have to connect the signal. Or in other words, if the bullet type is equal to global.guns.rocket, then we want to get the bullet and connect the signal. We have already done this before, so I want to get the detonate signal and connect it to create explosion. Although make sure not to call it, we only want to pass in the function. If I now try all of this in the game, I can select the rocket launcher and shoot at things. This is working. And if I go up, I think to the right we have the drone. Let me try to hit it. And this also works. We are getting the same explosion. Perfect. Besides that, the debugger is unhappy with me because we are not using the body on body entered. We are going to do that later, but for now, I want to keep the debugger happy. So, with that, we have 2 of the bullets. Besides that, I want to check for the shotgun, which is inside of else. Or in other words, the type is not in AK or rocket. It can only be the shotgun. If that is the case, I want to basically disable the bullet entirely. Or in other words, I want to get rid of the collision shape 2D, or at the very least set it to disabled. And I want to hide the sprite 2D. Let's try that part. If I now select the shotgun, we are only getting the particles. Cool, that's working. Nearly done. There are just 2 more things that I want to do. Number 1, inside of the bullet, I do want to add a timer, which I have called kill timer. The basic idea is that if the bullet exists for too long, we want to destroy it. That way, if for example we are in the sky level and the player shoots up, the bullet might go on forever and never stops existing. Or in other words, at the moment, bullets only disappear once they collide with anything in the terrain. But if that doesn't happen, they might never disappear. So to work on that, I simply want to add a timer that every bullet disappears after 10 seconds, just to be sure. Which means I want to connect a signal, and once this timer runs out, then I want to call Q3. After that, inside of the timer, I want to set auto start and one shot to true, and for the wait time, let's go with 10 seconds. That should already work. Besides that, I want to add a point light, and for now, let me simply hide it. So if I am running the game and I shoot a bullet, the bullet might be a bit hard to see, and adding a light to it might make it more visible. Although this part you don't have to do. For this bullet, I want to go to lights and then use main.png. Drag it into the texture, and this is going to be way too large. So we want to set the texture scale to something much more reasonable. Let's say 0.1. Actually, 0.05. Obviously, play around with this, and the strength could also be a bit lower. If I now try this one, and I shoot a bullet, they are much more visible. Although at this point, if I shoot with the shotgun, there is going to be a very faint light effect somewhere. Which means when we are shooting with a shotgun, I also want to hide the light. Or in other words, I want to get the point light 2D and hide it. With that, we can shoot a bullet. Also, if I go to the sky scene and run this one, this enemy should also be shooting bullets, and that is looking pretty good. They also disappear once they collide with the player. We are making progress. That means next up, I want to implement the actual hit mechanic, which is simply going to be a function inside of entity. In there, I want to create function hit along with the damage for now. If that is the case, I want to print the node itself and then the amount of damage that we should be receiving. This function I want to call as soon as a bullet is colliding with this body. Or in other words, when the bullet or this area 2D is colliding with a body, then we want to call hit on this body. Although that we only want to do if it exists inside of this body. If that is the case, body.hit along with the damage of the bullet. Now to test all of this, I want to reopen this station scene and then move the opponent somewhere down here. After that, we can try the scene and shoot at the enemy, and we're getting soldier or player along with the damage. That's already working pretty well. Once we have that, there are 3 things that we need to do. Number 1 is actual health, so that all of the entities have some amount of health, and that amount of health gets reduced whenever we get hit by a bullet. And if the health reaches 0, then we die. Besides that, I want to create a hit shader, so that the entity flashes in white once we get hit. And finally, I want to have an invul timer, so that after every single hit, we are invulnerable for a very short amount of time. So if we get hit 5 times at once, we don't die immediately. That would be a bit annoying. I suppose the health part is the easiest bit, because for that, inside of entity, we simply have to create a variable called health, which always is going to be an integer, and let's say a default value of 100. After that, inside of the hit function, I want to reduce health by the amount of damage that we are getting. So health minus equal damage. Once we have that, after the health goes below or equal to 0, we want to call a function, which we can set once again via a set function, which always wants the value that we are receiving, and then we want to override the health value with the value we are getting. Besides that, I can check if health is smaller than or equal to 0. If that is the case, I want to trigger death, which doesn't exist at the moment, so func trigger death. For now, let's simply print death so we have something. And for testing purposes, after any entity got hit, I want to print the health amount. Let's try all of that. I can now shoot at the soldier, and let me do it like this so we only get one output. If you look at the output, we are getting health being reduced, and at some point we're getting death and 0. We don't have the actual logic, but the important part is in place. And also, we don't need the print statement anymore. Instead, inside of the entity, under timers, I want to create one more timer that I have called the invul timer, which is going to get a one-shot and a duration of 0.4. So the issue at the moment is that this health is going to get reduced as soon as the player is hit, or as soon as any entity is hit. And this works fine. However, if we are going to the station, and the player, for example, collides with a saw, which should also trigger the hit method, and if we don't add an invul timer, the saw is going to hit the player on every single frame of the game, which means the player is guaranteed to be dead within like 10 frames. And to avoid that, we want to use the invul timer. And to use it, we don't even need a signal. All we have to do is check if not invul timer dot time left. Only if that is the case, do we want to update the health. And whenever we do update it, we once again want to get the invul timer and then start it. And to actually test it, we have to look at the saw again. So let me open saw. We already checking if a body has entered the saw. This we now want to use. All we have to do is get the body and then call hit with some amount of damage. Let's say 10 for this one. And just to be extra sure, I still want to check if hit is in the body. And only then do I want to call the method. And with that, let's go to the station and move the player into the right spot. So in here. Oh, and also, once any entity gets hit, I want to print the damage. Let's try all of this now. And the player should get hit. And there we go. So now the player only gets hit once. But if we didn't do that and simply printed something, let's say damage, when there's contact, if I now run all of this, we are getting hit. Oh, still only once. Oh, and I realized why. Because inside of Godot, for on body entered, this only triggers once when the body is entering the shape, which I guess is another nice safeguard. So we didn't really have to worry about a timer, but it's generally a good idea. With that, we have the invul timer and we have a start for the health. Next up, I want to work on a hit shader. That way, once an entity gets hit, it flashes white for a short amount of time. And for that, first of all, we have to create the shader, which we have to do in one of the entity scenes. Let's do it for the monster. Inside of Sprite 2D, I want to go to Material and then create a new shader material. And for that, we don't need the animation player. Inside of this material, I want to create a new shader and I want to use a visual shader. Although for the name, I do not want to call this monster.tress. Instead, I want to call this shader Flash because we are going to reuse it. Also, I want to save it not in entities. Instead, I want to create a new folder called shaders. In there, we have the Flash shader. And now I can create it. In there, we have, let me reorganize all of this a bit. Fundamentally, we only want to update the color, for which we can create a color parameter that I want to rename simply to color. And I think for this one, we can also set a default value of white. This I want to connect to the color. And then we are already getting a silhouette. This we want to be able to mix with the original color of the texture, which means besides that, I want to get the original texture, which I can get via the texture. This will contain the original color information. And to read it, I will need a texture 2D. And let me zoom out a bit. Actually, let me full screen all of this. I want to place the texture into the sampler 2D port. Then Godot is going to complain that this should be a sampler port. There we go. Now Godot is happy, and by default, we are already getting the UV, so this we don't have to worry about. As an output, we are now getting a vector 4 that we want to mix with this color. And for that, we can use a mix function and make sure you're getting vector 4. We want to get the first value and then the second value, and the output is going to be our actual color. That should already give us some of the original color back. Because right now, the weight is at 0.5. So we are getting 50% of this color and 50% of the new color. To control this weight, I want to add a float parameter and connect it to the weight. Also, I want to rename the float parameter to progress and set a hint range. We want to go from 0 to 1. That finishes the shader. I can now go to shader parameters and set the shader progress along with the color. So if you want to have some really freaky color, go with that. I'm going to stick with white. And by default, the progress should be 0. This shader we now want to apply to all of the textures of every single entity. Which means for the player, I want to go to player graphics, and in there we have legs and torso, which should both get the shader material, and then we can quick load the shader we have just created. Same for the torso, material, I want to create a new shader material, and then quick load the flash shader. By default, this doesn't do anything, but that we're going to work on in just a bit. Next up, I want to work on the soldier, because in there, we simply have a sprite 2D, which once again is going to get a shader, and then in there, I want to quick load the flash shader. Finally, we have the drone, and for the drone, we have an animated sprite 2D, which can also get a shader material, once again, quick load, and flash. Cool. With that, every single entity texture can be flashed. And let me clean up all of the scenes just a bit. We don't need the sky, and we don't need the bullet. Now, inside of the hit function, I want to call something like flash with the nodes that can be flashed. This is a function that doesn't exist at the moment, so func flash along with the nodes. And for now, I simply want to print the nodes that we are getting. And let me talk through this. By nodes, I am talking about all of the nodes that have the flash shader. And this I want to get from inside of the hit function. So in there, I also want to get the nodes. That means inside of the bullet, when we are calling hit, we have to somehow get all of the nodes. How can we do that? And well, I basically want to get the body and then get the sprites. The way this system is going to work, for example, for the player, I can minimize everything else, and then at the bottom, func get underscore sprites. No need for parameters for this one. I simply want to return an array with the nodes that have the shader. For the player, this would be player graphics, legs, and then we have player graphics and torso. Those are being returned by get sprites. So when we are inside of the bullet calling this function, we are getting all of the nodes inside of an array. And then inside of entity, when we are calling this function, we are getting the nodes that we are passing into this flash function. And in there, we are printing them. The same thing I want to do for the saw. So in there, we have the damage. Besides that, I want to get body.get underscore sprites. Get sprites is not the perfect name, but I think it captures the essence reasonably well. So with that, I can run all of this, and now if the player gets hit by a saw, we are getting the sprites that have the shader. That's really all we need. Once we have that, we can work with the shader. Inside of the entity, I want to create a tween to control the parameters of the shader, which means I will need var tween and create tween once more. After that, on this tween, I want to call a tween method. I find when updating a shader using tween method works best. The way it works is that we have to pass a function into this tween method as an argument. Let's create it first of all. I want to create a function set flash value, which always needs to have a value that in our case should be a float. For testing purposes, for now, I simply want to print that value. After that, inside of this tween method, I want to get set flash value without calling it. The tween itself is going to call it. I don't want to do this manually. After that, we have to do the usual stuff for the tween. We need a start value, we need a final value, in my case 0.0 and 1.0, and then a duration. For now, let's go with 1 second. If I now run all of this, you should be able to see the values going from 0.0 all the way to 1 over a duration of 1 second. That is what we have gotten from this function. So basically, we are simply calling it over and over again until we reach that point. To this function, I now want to add all of the nodes, which I can do via bind, and then pass through all of the nodes. To capture them, I have to add another parameter for the nodes. I can simply go through all of the nodes via for loop for node in nodes, and then actually update the value. So I want to get node material and then set shader parameter. The parameter I want to update is called progress, and the value I want to give it is called value. That should actually be it. If I now run all of this, The player should flash up once we get hit, and he doesn't. I think that's because we need an uppercase P for progress. Next attempt. And now this is working. The player very slowly becomes white. To make this a bit more snappy, I want to set the duration to 0.1 and then set the transition, for which I want to use tween and quadratic. Next attempt, and now the player should flash up much faster. And there we go, this works. After this tween is finished as well, I can duplicate the entire line and then go from 1.0 to 0.0 over a duration of 0.4. With that, the player should only flash up for a short amount of time, and there we go. This looks pretty good. So that covers the shader for the player. And I do realize that all of this was probably somewhat confusing. So let me go over it again a bit more slowly. Inside of every single entity, for example for the player, we have some kind of sprite that contains all of the graphics. Inside of the player, this means legs and torso. I have given all of these sprites a shader, the flash shader. And this shader can be updated by the color or by progress. So if you toggle progress and set it to 1, then you're setting the texture to white. And that's all that's happening in there. After that, for every single sprite, we are going to create, for example, the player, a getSprites function that simply returns all of the nodes that have the shader. And as soon as anything hits that body, for example, a saw hitting the player, then we are calling body.hit with the amount of damage and with the sprites. That means then inside of entity, we are calling the hit function, and via that, we are calling flash, which in turn is going to create a tween that itself is calling a method. In our case, setFlashValue, and passes in all of the nodes along with a value, which we are catching via the parameters, value and nodes. And finally, after that, we are looping through all of the nodes and then updating the shader. That's basically all that's happening in here. The ultimate logic is fairly simple, but we are passing through a whole bunch of steps, which might make all of this more complicated. Also, what you always want to be aware of, when you're working with a tween, you want to be really specific with your data type. So make sure you are basically always using floats. If you used integers in here, like simply a 0, then there is a pretty good chance that Godot is going to pass in an integer, which wouldn't really work for our shader. Now, all of this, I really want you guys to practice, which means for the shader logic for the soldier, the drone, and the monster, you should implement the logic yourself. Most of the work I have already done, but you will still have to implement a few more parts. So pause the video now and try to finish up the shader. Alrighty, I suppose just to see what's happening. If I go to the station scene and then move the player over to the soldier. If I now run the entire game and shoot at the soldier, we're getting an error that getSprites doesn't exist in the character body 2D soldier. That makes sense because inside of body hit, the soldier doesn't have getSprites. That is easy to fix. So for this soldier, I need to add another function, get_sprites. All this one needs to do, let me open up the soldier scene. The only thing that we want to do is to return the sprite 2D. Or at the very least, the node with the shader. So this I want to return. And since we are going to loop over it, I want to return it inside of an array. And that should fix the soldier. If I now shoot at the soldier, he also flashes for a bit. Next up then, we can work on the drone, which as a reminder, if I open the drone scene, for the graphics has an animated sprite, and this we want to return via get_sprites. Return the array with animated sprite 2D. Finally, we have the monster, which has simply a sprite 2D, which means we can copy the thing we have done for the soldier and simply return sprite 2D. Let's do it all the way at the bottom. Function get sprites, return sprite 2D. That should be it. If I now run all of this, I guess we should try the soldier, still works. Then we can go up and shoot at the drone. Just have to make sure I'm hitting it. And this one doesn't work yet. Also, if I go to the sky scene, it does work for the monster. So this part is okay. All right, with that, we are nearly done. I just have to make sure that inside of the station, we can shoot at the drone. And let me put it roughly on the same level as the player, so it's a bit easier to test. If I shoot at the drone, nothing happens. And just to test things, inside of onBody entered for the bullet, I want to check, first of all, if print drone hit is the case, and if then hit is in body. For that, I can print hit. I think that's the issue. If I now shoot at a bullet, we are getting drone hit. This part does work, but the actual hit inside of the body does not. That means there's no hit in the body of the drone. And if you open the scene, you can tell why. The drone inherits from character body 2D, while it should inherit from entity. If we now try all of this again, there we go. Now the drone is flashing. Perfect. Awesome. With that, we have the basic shader for all of the entities. That is some pretty good progress. There's one more thing I do want to do before we come to death, and that is set a proper amount of health for all of the entities. At the moment, we are always going with 100, but if you look at global, I would rather set some kind of enemy parameter for health. For example, for the drones, I want to have a health of 20, and for the soldier, I want to have a health of, let's say, 60. Besides that, I want to have one more entry, which would be the monster. This one doesn't need speed. I suppose 200 is pretty good with this one. And then, when we are inside of the drone, for example, we can call func_ready and update health to be the value that we are getting from globals. So enemy parameters, drone, and health. And obviously, this should be global. This line I can now copy because next up, I want to work inside of the soldier, in which we can do the same. I want to have func_ready and update the health in there, except now I want to have the soldier. Finally, we have the monster, on which we can do the same thing, func_ready, and then we are setting health to the monster health. I suppose after that, inside of entity, we can keep 100 for the player. And just to test if this is working, I want inside of bullet, when we are hitting anything, print body.health. Let's try this. And for the drones, I think we should get 10 or 20. So this is working pretty well. With that in place, we can start working on the dev logic. So for example, for the drone, if health gets to 0, this thing should explode. Whereas for the enemy soldier, we want to play the death animation. And for the monster, we want to play something a bit larger. So let's go step by step. Oh, and before we start with that, inside of entity, we are already checking via the health if this value is below 0. And then we are calling trigger death. This at the moment doesn't do anything. Or well, it prints something, but I want it to do nothing. Because this function I want to override. For example, in the drone, I want to have trigger death as well. And this trigger death is now going to override this trigger death, although you could call it via super. And in there, we have trigger death once again. But that we don't want to do, since trigger death in entity doesn't do anything. Inside of the drone, if the drone dies, we want to emit the detonate signal, so detonate emit, with the global position of this node. And besides that, we want to Q3 the entire thing. That should be it. and the drone dies in a single hit. So I can shoot, and the drone disappears. Next up, we can work on the soldier, which once again is going to need a trigger def function, in which we first of all want to set the speed underscore modifier to 0, and then we want to set the animation player dot current animation to def. Or in other words, if I close the drone scene and open the soldier one inside of the animation player, earlier we created a def animation. This we want to play as soon as the soldier dies. And that should actually be it, at least for this part. So inside of the station, I want to move the player over there. Let's try all of this now. And I can shoot at the soldier. And eventually we should get the def animation. And we don't. So let's check if this function is being called in the first place. Print def. So at some point we should be getting def. And we do. That means this function does run. And I think we do play the animation, but then because of animate, we are switching straight back to the regular shooting animation. So what I want to do instead is under process, only do all of this if health is greater than 0. If that is not the case, we want to play the def animation once, and then we are good to go. So if I now shoot at the soldier, there we go. We're getting the def animation. And this almost works. The one issue we have now is that the collision shape for the soldier is still there. Also, we can do this, which is arguably pretty funny. Anyway, what we want to do after the soldier has died, we want to get the collision shape 2D and set disabled to true. Although this usually gives you some weird behavior and Godot is going to complain. Let me try. And there we are getting a debugger issue that we have to update physics inside of call deferred. That's not a problem. We simply have to create another function called disable collisions, although the name doesn't really matter. All we want to do in here is disable the collisions. And then use call deferred and the name of the function that we want to call. In my case, disable collisions. That way we can do all of this again. And now we are not getting collisions anymore. Perfect. That looks all right. So finally, we can come to the monster. Or first of all, I want to close the soldier scene. Once again, I want to create a function. I suppose we can do it right below trigger attack. Function trigger def. I want to start by disabling all of the timers. Move timer.stop and attack timer.stop. Besides that, I want to get the animation player and set the current animation to def. I don't think this one exists at the moment. Inside of the animation player, we have to create another animation. So a new animation called def, for which we first of all want to set a property track for the sprite 2D. And the value I am looking for is modulate. Basically, over 1 second, I want to start from a key that is all white, and then at the end, the value should have the same color, still white, but then the alpha value should go to 0. All this is going to do, it's, well, fading out the monster. While this is happening, I want to display lots of explosions, for which I want to add a call method track that connects to the monster. And in there, I want to call lots of explosions. For that though, inside of the script, we will need to add just a bit more. First of all, I want to create a signal detonate, like we have done for the drone and for the bullet. In there, we have the position. And then when we are playing the death animation, I want to call a function explode over and over again, which is then going to give us a random x and y position inside of this sprite. So fundamentally, we simply want to get detonate and emitted with a vector for random underscore x and random underscore y. These two values do not exist at the moment. To create them, I want to have var random x and var random y. For both of them, I want to get the RNG, or the random number generator, along with rand I range, for which we will need a start and an end point. In my case, I went with global position dot x minus 20 and global position dot x plus 20. The same thing we can do for y, except now I want to replace x with y. That is going to give us random positions around the center of the monster. Next up, inside of the animation player for the death animation, I want to call this explosion. Or in other words, I want to create a key with the explode function. And this I want to insert multiple times. So throughout this function, simply add explode wherever you think it's appropriate. Explode here, explode there. And we can do this a couple more times. Via this system, you are getting a ton of control, although setting it up is arguably a bit tedious. Let's say something like that, and then we should have a nice animation once the monster disappears. For all of this, let's try the sky and then play the scene. And we are getting already a semi-transparent monster. So this is not ideal, but the explosions do work. Multiple times, actually. Which I guess is also kind of funny, but not the intended experience. First of all, for the animation player, when we are playing the death animation, the default value should be 0. So make sure you are starting here. On top of that, when this thing is done, I want to play another function, which is simply Q3. That way, we're getting rid of the entire thing. Now make sure that the timeline is at the beginning, so the monster is visible, and then inside of sky, I want to defeat the monster, and the rocket launcher is best for that. Although it's going to take a bit. There we go. Now it disappears, and now the monster should be gone. And perfect. This is working quite well. That is leaving us only with the player. And for this one, I didn't really know what to do for trigger death, because we don't really have a reset state. So for this one, func trigger death, I simply want to end the game, for which we have to get the tree and then call quit. Now to test that, if I run the game, I think this soldier is going to shoot at us. And after a couple of hits, the game is going to end. Not amazing, but good enough for our purposes. Although, while I'm testing things, I want to disable this function, or, well, comment it out, so the game doesn't end randomly. We are nearly done. There's just one more thing that we have to cover, and that is inside of the bullet. We do get the bullet if the player is using the AK or the rocket. But if we are using the shotgun, none of that happens. So this one right now doesn't do any damage. In fact, if I go to the shotgun and an enemy, nothing happens. For that, first of all, I want to get all of the enemies. But this we can't really do at the moment. For that though, inside of all of the enemies, so for example, inside of the monster, we can assign them to another group, which is called enemies. This I want to do for the monster. I want to do it for the soldier. So soldier selected and manage group enemies. Finally, the same thing for the drone. In there, I want to have enemies as the group. With that, we can return to the bullet, and var enemies is simply going to be get underscore 3 and get nodes in group enemies. In fact, this we can use right away in a for loop for enemy in get tree and enemies. And then we can get var enemy underscore position, which is going to be enemy and pos. In there, we want to get two things fundamentally. Number one is the bullet angle. Number two is going to be the enemy angle. And finally, I want to check if position, so the position that we are getting from the setup method, is distance to enemy dot position below 100. Or, well, if you look at global, there we have gun data and shotgun range, which should be 100. If we are inside of this range, global gun data, shotgun, and range. If we are close enough, and the absolute value of the bullet angle minus the enemy angle is, let's say, below 90 degrees. If that is the case, we want to call the hit function on the enemy. So enemy.hit. First of all, though, we have to get the bullet angle and the enemy angle, both of which are fairly simple to get. For the bullet angle, we simply want to get bullet angle dot angle, which is going to return a value in radians, which I do not like to use, so rad 2 degree. Then for the enemy angle, I want to do the same thing, radian 2 degree, and in there, we want to get the target vector, so enemy.position, and subtract the current position, or our start point. And from that, we want to get the angle. Oh, and I made a mistake. This bullet angle should be the direction of the bullet. Next up, inside of this thing, Godot is complaining that we cannot get shotgun from the gun data. Let's have a look. Inside of global, we have gun data and guns.shotgun. So this shouldn't be shotgun, this should be global.guns.shotgun. And now Godot is happy again. So with that, we know that an enemy is close enough to the player. And on top of that, the enemy angle is within the same angle that the bullet is going in. Or at the very least, it's in the same quadrant. If that is the case, I want to call enemy.hit with global.gun data. In there, we want to once again get global.guns.shotgun, from which we can take the damage. And finally, we want to get enemy and get underscore sprites. That should be all. If I now run the game and select the shotgun, I can shoot, but we are getting an error. This should be enemy.position, not pos. Next attempt. If I now shoot, I made the same mistake in here again. This should be enemy.position. So final attempt, I have a good feeling now, and we can hit the enemy. And the enemy dies, so this is a really good sign. That means we now have the shotgun logic as well. And that covers the entirety of the bullet logic. At this point, we only have to add some minor things, like managing data between scenes and the player health indicator, along with a few more minor things like sound. All of those we're going to add in the next part. At this point, the majority of the game is basically done, and we pretty much just have to finish up some smaller bits. The two most important parts are the player health indicator and the enemy persistence across levels. So that if we are defeating a soldier in one level, switch to another scene, and then come back, the soldier is still defeated. Other than that, I want to add some sound and then refine the levels just a bit more, but those parts are going to be fairly minor. Let's jump right in. Here we are in Godot, and I want to start by giving the player a health indicator. For that, I am going to create a new scene, for which the root node is going to be a sprite 2D that I'm going to rename to health circle. This I want to save inside of scenes, entities, and player, along with the other player scenes. And I guess while we are here, I also want to open the player scene and then attach the health circle to it. Oh, and by the way, I closed all of the other scenes, so things are a bit more organized. For the health circle, the basic logic is going to be that we have a circle around the player, something like this, and if the circle is full, we are at 100% health. But if the player gets hit, we want to reduce this value, which should also be animated. And all of that we are going to do via a shader, for which, inside of the health circle, I want to assign some kind of texture. You could either use the Godot texture and place it in there, or alternatively, you could remove it and then add a noise texture and set a width and a height on it. We are going to display everything via a shader anyway, so I'm going to use the Godot logo. In there, I want to go to Material and then create a new shader material, in which I want to create a new shader. And I guess just for some variety, I'm going to use a code-based shader. The name can stay as it is and then create. And by the way, you could also use a visual shader for all of this. We are not going to write anything too complicated. So let me rearrange all of this so this becomes a bit more visible. For the shader, I want to first of all define a couple of values, all of which are going to be uniform, so we can influence them inside of the inspector. I want to have uniform vector to center, which is going to get a value of vector 2 with 0.5 and 0.5. Don't forget the semicolon. Next up, I want to have a uniform float radius, for which I want to have a hint range from 0 to 1, although without a step size, and the default value is going to be 0.3. Besides that, I want to have a uniform float width, which is also going to be hint underscore range with a value from 0.0 to 1.0. By default, it's going to be 0.2. Besides that, for now, I want to create one more, which is a uniform vector 3 for the color, which is going to get a source color hint with a default value of vector 3 1.0, so pure white. Simply by having all of these values inside of shader parameters, we can set a whole bunch of stuff. The only shader that we want to create is a void fragment shader without any parameters or arguments, and in there, I want to first of all create a circle. Or in other words, I want to set the alpha values, for which, first of all, I want to measure the distance between the center and the current pixel. Remember, once again, for a shader, we are separating the entire sprite into very small units, and then we are processing every single unit simultaneously. So when we are getting the distance from the center, this point, we can get some kind of circle. The way this is going to work, and let me call this one the outer circle. I simply want to get the distance between the center and the current UV position. This I can now use for the color alpha value, so I want to assign the outer circle. That way, it's a bit hard to see, but the center is not visible at all, and the further out we go, the more visible all of this becomes. All of this we can make much more visible by adding a step, which is going to give us a cutoff point, for which I want to use the radius. With that, we are getting a proper circle that we can also influence via the radius, so this changes the size of the entire thing. Besides that, I want to create another float for the inner circle that we are going to cut away. That way we can still see the player, for which we are still going to use the step function, along with the distance from the center to the current UV. Although for this one, we want to get the radius minus the width. Don't forget the semicolon. And then this should be working. So this is basically just a smaller circle compared to the outer circle. And effectively, we want to cut out the inner circle from the outer circle, which we can do by getting the outer circle minus the inner circle. And if I now save, we are getting a cutout in the middle. And for that, we can set the width. So if I make this smaller, we have a smaller width. I think 0.2 is a bit too much. Let's say 0.01, bit too small. Let's go with 0.05. And then if I reset the value, okay, this one is a bit too thick, but you can experiment with that. Let's go with 0.03. I think that looks okay. And for all of this, we should check the player as well. So I think that generally looks okay. Oh, and by the way, while we are here, before we continue, we can update color.rgb right away by setting it to the color. That part's super easy. With that, we are getting whatever color we are specifying inside of the shader parameters. I'm going to go with some kind of red, at least for now. Besides that, one more easy thing that we can do is I want to get uniform float alpha, which is going to get a hint range between 0 and 1 without a step size, with a default value of 1.0. This value we want to use to toggle the visibility of the health circle, which we do by simply multiplying it with the alpha value. Whatever we are getting in there will be multiplied with alpha. That way, inside of the parameters, we can make this thing visible or invisible, or anything in between. Also, you can update the center to place this thing basically wherever you want. So I think for the player, we might have to move it just a bit down, although I think this actually looks okay. Cool, so this covers the easy part. Now we have to cut away parts of it. So we only want to get the full circle if the player has 100% health. But how can we cut away a part like this? So this part, for example, I don't want. Or generally, I simply want to toggle the progress of the circle. For that, first of all, we will need one more uniform. That needs to be a float, which I called progress. Once again, we can go with hint range from 0 to 1 with a default value of 1.0. After that, to cut out parts of this, we will need some very basic trigonometry. Or in other words, before we are updating alpha value of the color, I want to get a float for the cutout, for which I'm going to use aton. And in there, I want to add uv.x and uv.y. And to see what this is doing, let me comment out color.a and instead get color.a and set it to the cutout. Okay, this is doing something. To make all of this a bit more visible, let's use this step function with 0.5. I think that's going to be more visible. Actually, what we can do is use progress instead. So now what I can do via progress is toggle this thing and get some kind of cutout. What aton is giving us is the angle between the origin point, so this point up here, and any of the pixels. If this angle is large enough or bigger than the progress, then we are going to get a visible pixel. If not, the pixel will be invisible. The first issue we have with this one is that we are starting from the top left. This is not correct. We want to start from the center. So inside of aton, and let me expand this, I want to minus center.x for x and minus center.y for y. If I now save all of this, this is already looking a lot better. So now, if I change the progress, we are getting a small part of the progress. To cover a greater range, I want to multiply the progress with 2 times pi or tau, which should already do quite a bit. if I try this one again. So now, instead of progress, we can go from 0, and then at 0.5, the circle disappears. Not a terrible start, but also not great yet. Basically, at the moment, we are covering half a circle. And to finish the circle, we simply have to add pi to it, which we have to add to a ton. There, I simply want to add pi, and then we are getting the entire circle, and we can cover the whole thing. I am fully aware I am going over this a bit faster, simply for time's sake. Later this year, I am going to make a proper tutorial on shaders. So I hope this wasn't too overwhelming. If you are entirely lost, check out an introduction to trigonometry. We are not doing anything complicated in here. Anyway, once we have that, we simply want to multiply the cutout with our current alpha value. So we want to get the outer circle minus the inner circle times alpha times the cutout. And with that, right now it's not doing anything, but if I change the progress to any other value, we are subtracting values. So right now 0 is the full amount, and if I go to 1, this value decreases, which isn't ideal. I want 1 to be the full amount, and then the further down we go, the less of a circle we have. To get that part, I simply want to put the progress into parentheses and then do 1 minus progress. That way we are inverting this value. So with that, I have the progress and I can select what amount of health I want. Perfect. So with that, inside of the level, we can see the player has a circle around it. Although in the foreground, we have some random stuff that I want to remove because this looks a bit bad. Now, one issue I have before we continue is that the health circle is affected by the directional light, for which we kind of have a problem. So usually, if you have some kind of sprite that you don't want to be affected by light, you can simply go to visibility and light mask and change it there. Unfortunately, this doesn't do anything for a directional light. I can save it. We are still getting the same result. Now you could do some fancy stuff and render the entire thing on another layer, but that's a bit too complex. Instead, I want to add a point light as a child to the health circle. And then under graphics and lights, we have the main light, which I want to add to it. Simply by having that, we are lighting up the player a lot, which doesn't look good. But what we can do now, inside of Point Light 2D, under Range, we have an item call mask. And this one determines what is affected by the light. So with this one selected, and the health circle being on Light Mask 2, if I now go to the station, the light only affects the player health circle. So inside of the level, this is not affected by the directional light of the background anymore. That means now we can animate the entire thing. I want to add a script to it, and then we don't need any of this for now. First of all though, I want to get on ready var layer, which we can get via get underscore tree and get first node in group layer. Besides that, I do want to have the ready function and get the current material and set the shader parameter alpha to 0.0. That way, when the game runs normally, we shouldn't see the health indicator, and that looks alright. But once we get hit, it should become visible, for which I want to use an update function, which is going to get a value as the parameter. Although before we work in here, let's for now simply print the value to make sure this is working. So how do we call this update? Well, we want to do it if the health changes, which we are tracking inside of entity. This part to be specific. In there, we can check if the current class is in group, and the group that we want to check is player. If that is the case, we want to get the health circle somehow. And I think the best way of doing that is to put the health circle inside of a group. Let's call it health circle. That way we can track it anywhere inside of Godot. So now get underscore tree and get first node in group health circle. Once we have that, I simply want to call the update method with the value. Could also be the health, it doesn't really matter. Once we have that, I can run the project, and if the soldier shoots at us, we're getting the health. That looks good. That means now we can work inside of the health circle. First of all, I want to create a tween, which we do in the usual way, create tween. After which, I want to tween the property. The object I want to target is self, and the property path is the material that we want to work with, and in there we have the shader underscore parameter, which has an alpha value. Via that, we are making the entire health circle visible. So I want to set the alpha value to 1.0 over a period of 0.1 seconds. Let's try that. And if we get hit, we're getting the circle. Cool. Then we can duplicate all of this. Next up, I want to update the progress of the shader. For the value, I want to get the value from the parameter and divide it by 100.0, or whatever the maximum health of the player is. For the duration, I want to go with 0.2 seconds. If I now run all of this, we are reducing the player health circle. And this works just fine. If we go below 0, nothing happens anymore. That also works. Finally, I want to make the health circle invisible again, for which we can duplicate the first line, where we are setting the alpha value, and then go back to 0.0, over a duration of 0.4 seconds. Now, if the player gets hit, we are getting a very quick update to the health, which works pretty well. That should also work with the drone. So I want to move the player next to the drone. And then... and nothing happens. So that we have to refine. I guess while we are here, we can also test if the player is affected by the saw. So in there, we should get some damage, and we do. So this part is working. That means we have to check what's happening in the drone, and then let's have a look at the script. The issue is quite simple. On collision detection area body entered, we want to call body.hit with some amount of damage. I think inside of global, I don't specify a damage for the drone. I don't. I guess we can add it in here, damage, and let's go with 15. That way we can get global enemy parameters. I want to get the drone, and I want to get damage. Next up, we will need body.get sprites. So with that, we can try the entire thing again and move the player next to the drone. So now we are getting our health updated. Perfect. And I guess we shouldn't have to test this, but if I get hit by the monster, the health also updates. Perfect. Besides that, the debugger is being annoying, and now we have the issue that we are narrowing a conversion, which happens inside of these random values. And it's usually not an issue, so we can safely ignore these warnings. And in our case, we don't really care about the precise values here. If this really annoys you, what you can do is add warning ignore, and then we are looking for narrowing conversion. And this you want to place before the line that it applies to. If we run the code, we are not getting a debugger warning anymore. And this can be really nice because the debugger tends to be very annoying at times. Anyway, with that, we have a health circle for the player. That means we can close these scenes. I guess we can keep the player open. But next up, I want to keep persistence between the scenes. Let's move the drone out of the way, down here. And then I want to get the soldier and start the game. If I now kill this soldier and move outside of the scene, then I can come back and the soldier is back alive. This shouldn't be the case. So how can we make sure that this soldier stays dead after we are coming back? And before we get to that, I realized inside of the debugger, we're getting two more issues. That we are still getting debugger narrowing conversion. The issue is that this warning ignore only applies to the next line, which means we have to do it here and here. So now if I go to the sky scene, it shouldn't come up anymore. And it doesn't. That's much better. To keep data persistent between scenes, we have to store the data globally. Or in our case, we already have a global script in which I want to create another variable. Let's call this one the enemy data, which for now is going to be an empty dictionary. I guess a cleaner way of doing this would be to create a dictionary like this. After that, inside of the level, every time we are leaving the level, which we can do via function exit tree, this is being run whenever we are exiting a scene. So for example, I can print exit scene, run the game, and then I can simply move to the sky scene, and we get exit scene. That's all that's happening in here. If that is the case, I want to create an array. Let's call it current enemy data, which is simply going to be an array. Once we have that, I want to go through all of the entities inside of the entity node, which means for entity in main and entities, and then I want to get the children. After that, I want to get the current enemy data and append a value. This should be a list with the entity dot position, the entity dot velocity, and finally the entity dot health. And just to show what we are getting, let's print the current enemy data, run all of this, and then I can go to another scene. So now, inside of the output, we have an array with a couple of nested arrays, which contain the position, the velocity, and the health of all of the enemies. These values we want to store globally, or in other words, I want to get global dot enemy data, which is the dictionary we have just created. I want to create a key value pair. The key is going to be the name of the scene, which we can get via get free and the current scene dot name. The associated value is going to be our current enemy data. So that way, every time we are leaving the scene, we are storing all of the enemy information. And that information we can use as soon as we are loading the level, which happens inside of ready. We want to check. First of all, I suppose we can get the current scene name, which we once again get in the same way that we have done down here. And then we can check if the scene name is in global.enemy data. If that is the case, we can go by index, so that the first item we have stored in there is going to be the first item in this new scene. Now for that, we have to make some minor updates. I want to go for I in main.entities.getChild count. And then the var entity is going to be main and entities.get_child with I. With that setup, we can still get all of the entities. And now I want to call a setup method on all of them, for which I can get global.enemyData and then select the current scene name, which contains all of the data points, which I can select via indexing, so I. Now for that to work inside of each entity, we will need a setup method that we don't have at the moment. All the way at the bottom, I want to have func setup. Also, this thing needs to have a parameter for the data. Now, in there, I simply want to do if self.isIn group and enemies, I believe I called it. Then I want to get the position and set it to data 0. Next up, I want to update the velocity to data 1. And finally, I want to update the health to data 2. This should already do something. So if I shoot at the enemy real quick and then leave the scene and come back, then we are getting the soldier dying. But, well, we can still see the dying animation. Effectively, what's happening now is we have stored the data globally. And once we're loading this particular soldier inside of the soldier scene, we are calling trigger death, so we are playing the death animation, and then the soldier is dead. Which isn't ideal. I just want to display the dead soldier. The animation shouldn't be there. Or in other words, I basically want to do everything inside of this setup method, plus a few more things, which we can do inside of the soldier by creating another setup method. Func setup with the data. Importantly here, we still want to do the original setup, which we can do via super.setup, into which we are going to pass the data. Just to test things, I want to print soldier setup. So once again, I want to kill the soldier, then go in and out, and we get soldier setup, but the soldier is still dead. That's a good sign. Which means now, since the soldier is dead, I want to set the speed modifier to 0 right away, get the animation player and stop whatever we are doing, and instead get the sprite and set the frame to 22, which is the dead animation frame. I can once again defeat the soldier and then leave the scene and come back. Now the soldier keeps on being dead, which is pretty much all we need. Now, unfortunately, I did realize a bug in this system, so it's not perfect. Basically, when we have a drone or the monster, those scenes are being destroyed once they are running out of health, which means when we are leaving the level and we are creating the dictionary, this entity does not exist anymore inside of get children, which would break this entire system. Now, unfortunately, I don't have time anymore to fix it, and deadlines can be rough, so sorry about that. But basically what you want to do, instead of queuing free the drone and the monster, you want to store them in some kind of dictionary so you can still access them. That way, this system will become much more reliable. But anyway, with that, we are nearly done. There are just some more minor things that I want to do. First of all, for each level, so we are still inside of the level, I want to set a camera limit. Also, we have the debugger being annoying again. Current enemy data was used but never assigned a value. That's okay. I guess once again, we can get warning ignore, and then I think this one is called unassigned variable. Now we can minimize this function, and instead I want to create an export variable, which I have called camera underscore limit. And this is simply going to be a vector for integer. So we can only store integers in there. If I now store all of this and go back to the 2D scene with the station selected, in the inspector, we are getting 4 values, which are going to be the left side, the top side, the bottom, and the right of the camera. The way we are going to implement this, once everything is ready, I want to get the camera or the player cam, doesn't really matter what we call it, which always needs to be a camera 2D. And the value we assign is from get tree, get first node in group, layer, and finally, we still have the getCam method. That way, we have the camera. And then before we are setting up all of the entities, I want to set up the camera. The way this is going to work, basically, I want to have camera.limit left, which is going to be camera.x. For limit pop, I want to have camera dot y. For camera dot right, I need camera dot z. And finally, for camera dot bottom, I want to have camera dot w. With that, if I don't do anything and run the game again, we're getting some really weird behavior. Actually, first of all, we're getting an error because this should be camera limit, not camera. Let me fix it for all of them. And now try again. So now the camera doesn't work because we have set a limit of 0 for every single side, which means we can't really get away from the origin point. So to fix that, we want to check the different sides. For example, the left side of the level would be negative 32. So I can set this to negative 32. And I already measured all of this. The top side is negative 128, the right side is 1290, and the bottom is 640. That way, if I run all of this again, the player cannot see outside of the level anymore. And I think if we go down here, we can see it best. So if I go all the way to the left, at some point the camera stops. And that way we cannot see the background anymore. The same with the bottom. I think down here, there is another part. And if we go to the underground, this doesn't work anymore. To fix those two parts really quick, inside of the underground, for the values, I want to have negative 48, negative 200, 680, and 400. Finally, I want to update the sky. In there, the values are going to be negative 160, negative 16, 1066, and 480. And that should be pretty much it. I suppose just to try one, let's try the underground. I haven't really used that scene. In there, we cannot go further to the left with the camera, and at some point in the bottom, it also stops. So that's a pretty good sign. Next up, one thing that is a bit annoying inside of the sky is that we can see the background. For that, I want to add in the background another node, which is called parallax background. The way this works is we have to add another node, a parallax layer. And this one can get a sprite. And by adding multiple parallax layers, you can create a staggered effect, which looks really nice. For example, inside of graphics, there we have sky, where we have a plain background and then two kinds of clouds. I think Nuven's 2 should be further in the background, so this is what I'm starting with. And in there, we're getting a background that I want to arrange something like this. Then I can duplicate the sprite and move the entire thing a bit further to the right. This I want to do one more time, because that way we are covering the entire width. Something like this. Also, all of this should be moved just a bit further down, so the player cannot see the bottom. I guess this would be this point. After that, I can duplicate the entire layer and then change the sprite with another texture. In there, I always want to have Nuven's 1. If I now run the entire thing, we get a much nicer looking background, although at the moment it's entirely static. This you can change inside of Parallax Layer under Motion by changing the scale. For example, for the first parallax layer, I went with 0.9, and for the second one, I went with 0.8. Now I can try all of this, and we should be getting just a bit of movement, which I think looks really good. Although we are going to need just one more layer, so I want to duplicate the first one and remove the sprites, so we only have a single one, which should get Nuven's 3, which is a plain background. Let's move it here so you can see what's going on. This thing we want to stretch out to cover the entire area. Something like this. And now if I run this, this is looking significantly better. Perfect. I should have done this ages ago. Better late than never, I suppose. That means now we simply have to add the sounds and then we are good to go. Most importantly, we want to have the bullet sounds, which I want to store inside of global. In there, we have the constant bullet sounds, which is going to be a dictionary where we have the guns and then AK. The associated value is going to be reload, and then I want to load akshoot.wav. Next up, I want to have guns.shotgun, which is going to get preload with the shotgun shoot.wav. Finally, guns.rocket preload and rocket.shoot. Oh, and I forgot, this entire part could be your exercise as well. I don't think this part should be much of a challenge, but try to add all of the sound files yourself. Pause the video now and see how far you get. Alright, now we have the bullet sounds, and those we want to play whenever we are creating a bullet. For that, we have to open the bullet scene and add another node. Audio Stream Player 2D. I guess the name we can leave as it is. And to this thing, we have to assign a stream, which I want to do inside of the setup method. I want to get the audio stream player and then assign this a stream, which we are getting from global, and I called this one the bullet sounds. For the key, we are going to need the current type of gun. The value is then going to be the stream, and after we have that, I can get the audio stream player 2D and play the entire thing. And just to test things inside of this station, I want to move the player a bit over here, so we have things a bit more isolated. I can now shoot, and we're getting a sound. Same for the shot, and same for the rocket. Perfect. Next up, I want to work inside of the entities, for which I want to open the entity scene and then add another audio stream player 2D. This is going to be the hit sound, for which we always keep the same audio file. So inside of audio, we have all of the audio files. In there, we have hit.ogg, and this we want to play as soon as an entity is hit. Since we already have a hit function, this is fairly straightforward. I simply want to get the audio stream player 2D and play the sound. Let's try this one, and if I shoot in this direction, we are getting a sound. Righty. Next up, inside of the player. Whenever the player is dashing, I also want to play a sound. And to keep things a bit more organized, which is going to be another audio stream player 2D that I want to call dash sound, which is going to get the dash.wav sound. When we are applying the movement under dash, if we can dash, I want to play the dash sound. So dash sound dot play. And I realized for the original dash, there was a particle effect, which I do want to add. All of that happened inside of the player graphics. In there, I want to create another node, GPU particles 2D. I suppose we can rename those to dash particles. For that to work, we have to add a process material, particle process material. Then once again, we're getting the basic particles. Although those I want to set to time and one shot right away. The lifetime of the particles is going to be 0.6, and the explosiveness is also going to be 0.6. After that, inside of display, I want to work with the scale. The scale minimum should be 2, and the scale maximum should be 20. So emit to true, and we are getting much larger particles. To make sure that they don't always spawn in the same position, under spawn position, an emission shape as box. The only value I want to change after that is for y, we're getting 16. And next up, for the velocity, I want to set a spread of 10, an initial velocity of 110, and initial maximum velocity of 160. Bit hard to see, but those are the full terms. Let's see what we get now, but we might be in the wrong direction, although this is definitely getting better. Now, in the code, we want to work inside of the player graphics script and create a function dash underscore particles, for which we are going to need one parameter, direction. I want to get the dash particles, target the process material, and set a direction like we have done for the shotgun. The value we want for this one is the direction from the parameter. And after we have that, I want to get the dash particles and restart it. Now, restarting is quite important because it's more reliable. When you are emitting particles, so when you are setting emitting to true, you do get particles. But if you dash fast enough, you might get new particles before the old ones have disappeared. And if that happens with emitting being true, you do not get new particles. But with restart, you do. So this is generally a bit better, at least for this specific purpose. After we have that, we can work in player.gd. We are still inside of dash, and if that is the case, I want to get player graphics and then call dash underscore particles, along with the current movement direction, which I think should be working already. So now, if we're moving, we're getting a sound and particle effects. Also, at this point, what's really nice is that we can make the player flash very easily. We already have flash, and all we need is the get sprites method, which I think adds something. You could refine all of this quite a bit, but for that, you have to play around with the process material quite a bit, which you can very safely do in your own time. I think you got the basics. There are two more things that we need: the explosion sound and the background music. Let's start with the explosion sound. I suppose this one we can store also inside of global. I simply want to have a constant explosion underscore sound, which is going to be preload and explosion medium.wav. This we now want to play whenever we have an explosion, which means inside of the explosion scene, I need to add another node, which would be an audio stream player 2D. Oh, in fact, we could actually add the explosion medium right inside of the stream. That actually is much easier. So inside of global, we don't need this constant at all. Inside of explosion, as soon as this scene is ready, we want to get the audio stream player and play the sound. With that, I can shoot a rocket, and we're getting the sound. That's pretty much it. So finally, we can work on the background music, which should play constantly, or rather on a global level. And I think the easiest way of doing that is to create another scene, which is just going to be a basic node. Doesn't even need to be 2D. And I call this one BG Music, which is going to get an audio stream player and make sure that this one is not 2D. This is going to get a music.mp3 file. Now, I think by default, this one is quite loud. So let me reduce the volume and then try. I suppose we can set it to -30, but play around with whatever feels good. This one I also want to set to autoplay. And on top of that, with music.mp3 selected, you want to go to import and then enable loop, after which we have to re-import the thing, and now the file is looping, which for background music is really important. After we have that, I can save the entire scene inside of global, and background music is totally fine. After we have that, inside of project and project settings, auto load, I want to go to global and then bgmusic.tscn. With that, if I run the game, we are getting the background music. And that finishes the entire project. Now, there are some minor bugs, most importantly, about keeping the entities across different levels. So, you would have to do a bit more work to make this project work really good. But I think if you have gotten to this point, you have made a ton of progress. So, I hope all of this was useful, and I'll see you around.